All right, we should be good to go now.
Okay. All right. So,
All right, we should be good to go now.
all right. So,
All right, we should be good to go now.
let me get started. Can you hear me all?
Okay. All right. So
I'm
All right, we should be
hearing,
good to go now.
I'm hearing it echoed. Let me just
right.
turn off something else
So-
here.
All right, we should be good to go now.
let me get started. Can you hear me all? Okay.
Okay, can you hear me? Great. Welcome, everyone, to the WHN Clean Air Expo. We're very pleased to see you. And I want to thank really all of the organizers and speakers making this program possible. So the topic is clean air, and I will leave the speakers to talk about clean air, but I want to say that the subtext of this conference is multidisciplinarity. We really need people who understand the science, those who understand the politics, the law, the engineering, the economics, many who will advocate for change to make this happen, and surely many others who I have not listed. We've invited outstanding speakers, and there will be presentations about current and new technologies. However, my hope is that we will not just have presentations today, but we will foster the ongoing conversation across disciplines and around the world that will enable the adoption of clean air as a global strategy for stopping transmission of COVID, as well as other diseases, and contributing generally to health. Our panel on strategy begins with presentations on the importance of clean air and how we should understand clean air and its impacts. To start with, our first speaker is Eric Feigl-Ding, who has contributed to science through ongoing papers, but has devoted much of his time to bringing information about the pandemic to everyone, galvanizing attention, and providing understanding of the risks and need for action to prevent harm. Thank you, Eric. I will turn it over to you.
Thanks, Yanir, and thank you everyone who are joining us today. I think the Clean Air Expo is something that we should have had more than 3 years ago. We're approaching almost 4 years into this pandemic, and still to this day, most governments are not talking about a clean air revolution. We've talked about vaccines, we've talked about testing, we've talked about masking, and for the most part, there's always controversies around, do we still need to shut down? No. Do we still need to mask? Yes. Then others will say no. Do we need to get vaccinated? Yes. But if we're vaccinated, why do we need to get boosted? Because of variants. Do we still need to get boosted? Yes. And then, of course, there's all the anti-vaxxer rhetoric. Similarly, each of these require these personal behavioral modifications, from sticking a swab up your nose to getting a jab, to putting a mask on. And one thing we've learned from the pandemic is many of these things are incredibly, incredibly frustrating and controversial and politicized. But what if we step away from that? What if we, instead of focusing on all these things that can deal with the virus afterwards, and I put vaccines now as dealing with the virus, because right now, the vaccines currently don't prevent as much as they prevent the hospitalizations. But all of these are, in many ways, not prevention. Prevention is not getting infected in the first place. What we're doing now, for the most part, is how do we not get sick? And of course, Paxlovid is not widely available and doubling in price. Vaccines are no longer freely accessible unless you have insurance and go through all the insurance hooplas. And all these things, we're many ways taking the approach of, oh, let's just fix up the car after the car crash. How about we prevent the car crash in the first place? how about we prevent the infection and the subsequent long COVID that's seen in 80, 85, 90 percent, the long COVID we're seeing in about the 15, 20%, et cetera. How do we deal with that in reverse? And I think in many ways, when the forest fires, the wildfires were burning this summer, people realized, oh, clean air is actually a thing, that it's not just outside, it's actually permeating into their home. How do we deal with that? And the greatest rush of people buying HEPA filters was actually during forest fires. But why not for COVID? Why not for the next pandemic? And in many ways, that is why we're here. How do we move beyond this politicized discussion of prevention? How do we actually focus on getting those prevention things there in the first place so that we won't even know that there was an outbreak of something, because we would have prevented it and obviated the need to deal with it, or at least a widespread outbreak of it for the long term. And I think this long-term thinking is what we're sorely lacking. The Biden administration actually passed in the last pandemic relief bill, actually provided a lot of money for clean air in schools. But many school districts didn't use it because the money could have been used for many other utility instead of the technology that we have that we can prevent these infections in schools. And we know that even though risks to children are much lower, it's not zero. And children are super spreaders to families. And that's been shown in studies again and again. So how do we get off this hamster wheel cycle that we're on? And that is why I'm really glad and really pleased that we have so many experts here to talk about HEPA filtration, far UV, upper room UV, and many other more advanced technologies of how do we prevent the thing in the first place, instead of always triaging and fixing the car wreck afterwards. And how do we do it in a way that we don't have these massive social upheavals in our everyday lives? And I think that is where the future is going. That is where the next level of pandemic prevention needs to go. So thank you, everyone. I'm very pleased that we have so many great speakers on these topics. And think of Q&A. We will have Q&A at the end of this event. So, and with that, I will let the next speaker start and hope that we have a really great, fruitful discussion. Thank you so much.
Thanks, Eric. We will actually have Q&A very soon after these cluster of speakers, and I will turn it over to John Levy. John is a chair and professor of environmental health at Boston University. He has for decades been doing research on clean air pollution, climate change, and recently on COVID-19. Thank you, John, very much for joining us today.
Thanks, Yanira. Thanks for having me here today, and for everyone for taking time out to join. So I wanted to kick things off just with some basics about indoor air pollution to make sure we all have a common foundation for some of the content that's upcoming. So I think we can start with the simple fact that most of us spend most of our time indoors. That's pretty incontrovertible. So whether you're thinking about pollution that's generated indoors or outdoors, it's ultimately the time we spend inside that influence our exposures. And we know from global burden of disease analyses that outdoor generated air pollution has been associated with millions of deaths per year across the world. Most of this burden happens from air breathed indoors. And so when we're talking about outdoor generated pollution, what you're exposed to is ultimately a function of what the air quality is outside, of course, but also how long you spend inside your home and other buildings, as well as ventilation and filtration that affects what ultimately gets inside. But in many situations and for many exposures of concern, including SARS-CoV-2 or other infectious agents or other air pollutants like fine particulate matter or NO2, the story goes well beyond outdoor sources, and we're focused on indoor sources that can exist in those settings that can actually be the dominant sources of exposure. I think we all know by now that COVID transmission is far more likely indoors than outdoors. And in the realm of other air pollutants, a single indoor combustion source can contribute more to your exposure than all of the outdoor sources put together. And again, there are a few contributing factors: how large or strong the source is, how big the space is that you're occupying, and the amount of ventilation and filtration. So everything that I've said so far is pretty basic and incontrovertible. I think those who've worked in the field for some time or have been advocates for cleaner indoor air will recognize a lot of this sort of core content. Right? The fact that when you're in a smaller space with inadequate ventilation and filtration, that this increases your risk for infection or higher exposure. This really aligns with first principles, and there's not really even a whiff of uncertainty there. And so it may seem puzzling to some why indoor air has not received that much attention over the years, either among the general public or in regulatory settings. As Ynir mentioned, I've been working on this for a while. When I started working on indoor air topics in the mid-90s, there was certainly a small but dedicated group of academics who are publishing in this space. And there are, of course, entities like ASHRAE that have provided guidance over the years. But there's really little broad action happening on indoor air, and certainly little broad recognition in the general public. There was increasing attention and focus on smoking in indoor spaces then, but it didn't really go too much beyond that. But I think we're in a different time and a different space now. I think the recognition that COVID is airborne, I think in part because of tireless work from multiple people who are on the Zoom, has led to increased awareness of what clean indoor air can do for you. At the same time, as Ynir mentioned, we're in a time with increasing focus on climate change, and our buildings are a key part of both climate mitigation and adaptation as we try to think about how to reduce our carbon footprint while also keeping our buildings healthy and thermally comfortable. But we need to recognize what some of the major barriers and challenges have been in the past in trying to get to cleaner indoor air, so that we can build on this important momentum and try to get ourselves to healthier indoor spaces. One barrier that I perceive is that it's human nature to be concerned more with unfamiliar things than familiar things. And indoor spaces just seem like part of the fabric of our everyday lives, and people don't tend to perceive them as risky as a result. So in the realm of pollution, we think of Superfund sites or coal-fired power plants or rivers on fire. We don't think about a spotless kitchen where dad is cooking dinner on the gas stove, even if that might contribute more to our exposures. This intersects as well with the politics around indoor air and COVID. A lot of the hubbub about gas stoves in recent years, and certainly the never-ending furor about masks, really reinforce that anytime there's an action that is perceived to intrude on people's autonomy or the autonomy of businesses is going to get some considerable blowback. I do think the pandemic created this increased awareness of the importance of indoor spaces for transmission risk, and this can definitely change perceptions about the indoor environment over time. But I think it's important to recognize that there are some considerable hurdles, and we need to really communicate the context-specific benefits of cleaner indoor air. For example, for schools, a lot of the conversation has been about learning loss and test scores recently. We need to talk about how less COVID risk means less school absence among teachers and students, and that this will enhance learning. We also need to talk about how lower CO2 levels indoors and better ventilated indoor spaces lead to greater ability to focus and concentrate and get you to those better test scores. We need to talk to the people who are facing wildfire smoke and explain how air filtration can help. When homes are getting energy audits as part of energy efficiency programs, we need to ensure that indoor air is part of the conversation and that occupants are aware of the implications of their actions for indoor air and that these are clear, direct, and well described. We can't assume that people will connect the dots or that they'll take actions that provide ill-defined benefits. I think the good news is that these are real benefits that can be tangibly described. And as we take action and have more positive case examples, it'll make it progressively easier to explain to the next person and take the next step down the road. So just to wrap up, the public health and economic benefits of investing in clean indoor air are large and profound, with the ability to address the COVID pandemic, but also climate change, environmental justice, and so much else in public health. And I'm glad we're having this forum today to try to tackle some of the tangible approaches that can be done to give us cleaner indoor air. Thank you.
Thank you, John. So I have a few questions, and I would like to have both Eric and John speak to them. Let me start with the following question. What can we learn from the adoption of clean water 100 years ago for the clean air movement of today? Who would like to take that on?
Well, I can briefly comment. Well, clean water was, of course, something in public health was the biggest scourge for a lot of infectious diseases, cholera, etc. But I think in many ways it didn't become a lightning on which policymakers realized, oh, we should actually change this. And similarly, until for many, many years later, I think only like 50, 60 years ago. And similarly with lead, whether lead pollution from gasolines or lead in the paint, that revolution did not happen until the late 70s, and schools were and buildings were built without lead only until like the mid to early 80s. So in many ways, we knew about the dangers, but we didn't actually lead didn't lead to policy changes until the movement, the public outcry, and not just that the science existed, but the public organizing was there to push for the policy changes. And in many ways, once you demonstrate the cost effectiveness, the savings and the universal benefit of it, was there finally a shift? And even until today, of course, as recently, Flint, Michigan, just a few years ago, still had lead water problems, and many watersheds in the United States still have inadequate testing for leaded water. You're still allowed 10% of your drinking water households to still have lead. And of course, the infrastructure bill has finally funded these lead-aligned replacements, but that has been well over 100 years in the making. And I think in many ways, if it takes another 100 years for the clean air revolution, that will be a huge problem. I think organizing now, as the science is clearly very clear, we have to translate that much more quicker. And hopefully it won't take 100 years or 50 years.
Yeah, I mean, I think the other point to add is that, again, if you look at the arc of water and getting water treatment facilities up and running, that addresses issues further upstream and in a way that doesn't rely on individuals to control their own exposures to the same extent, right? If you paralleled things and said, we're not going to clean the water upstream, when it gets to everybody's home, you're going to have to figure out how to deal with it, or you're going to have to run out to the store and get a water filter. We would not achieve the same kind of public health benefit, and things are more complex for a number of different households. So by going upstream, addressing things at the source, people can turn on the tap, and of course there remain issues, but we're able to really bring exposures down. And it's not a perfect analogy, but because of course buildings are individual entities, we don't have a magic pipe that is sending air into everybody's homes. But the further we go upstream in these things, whether it means technology standards or support systems for ventilation in buildings, monitoring infrastructure for CO2 in public spaces, the less that it's relying on individuals to take action, and the more we're able to protect everyone in the public, not just those who can afford to take action or who have the information base to be able to act.
Thank you. Let me just mention, since I didn't say anything, our third speaker this morning was supposed to join, but apparently ran into some last-minute bureaucratic issues with approvals at their institution. So unfortunately, she won't be able to join us. So I'll continue with the Q&A now. Second question. We've seen the adoption of clean air strategies very strongly in Davos for the World Economic Forum, where high levels of ventilation led people to wear coats, and at government buildings in multiple countries around the world that have not implemented them more widely. This highlights the effectiveness and significance of clean air, but what can we learn from this about how to expand adoption? Let's start with John on that first.
I mean, I led with the kind of basics of indoor air because we know what works, right? I mean, there's fancier technologies that we'll hear from, but the fundamentals of clean indoor air are the same as they were 50 years ago, right? It's about the sources, the ventilation, the filtration, and other removal mechanisms. So, I think we know what it takes to be able to get success. I think what some of these extreme cases show is that, right, with adequate investment, you're able to get to very high levels of control. And so, as with any technology, the question is how to move from the early adopters to something that is more widespread and ubiquitous. And again, I think to repeat what I said earlier, there is an intrinsic challenge because each building and each home is its own entity, and people are not going to install, UVC in their own home. But I think we can look at the layers of protection that are used in these kinds of settings and try to figure out which are most readily applicable to other congregate settings, and advocate at the local level for investments. I think Eric mentioned earlier the possibility that school funding that was intended to improve HVAC systems was being utilized for other purposes, which of course are all valuable purposes to try to improve learning and make conditions for kids better. But we need to come back to the foundational benefits of clean indoor air for health and learning in schools and other settings, and emphasize that that's the direction of the investments. And again, we can point to these large public gatherings at Davos and elsewhere as places that show you can keep people safe and healthy in these settings, and that translates into numerous types of benefits.
Eric, do you want to add to that?
Yeah, I think there's, of course, a lot of complexities with these devices. I don't expect everyday people to be able to calculate air exchanges per hour based on the volume flow rate and measure the size of their rooms. I think all of these, there's an engineering guidelines around this, around ASHRAE. And ASHRAE, in many ways, everyday people don't have to think about, well, do I have the right 12 gauge wire or 10 gauge wire for my electrical home heating systems that's plugged in? Do I have the adequate, certain guidelines around the paint, the structuring, the right concrete, etc. I think many of these things need to be done in a way that is part of all building designs and renovations, so that everyday teachers and parents don't have to worry about, well, I want to donate a HEPA filter or a Corsi box to my school because they have such poor ventilation, but how many do I need? Well, let me measure the ceilings, and then I can measure the air exchange rate of the HEPA filter. What is the volume flow rate? I think these kind of things, we need to build it into the actual building process itself, but we have to put that momentum into the legislation in many ways, as well as right now, of course, during this transitional time, understanding, well, this room has very poor ventilation. Richard Corsi, another really good airborne engineering expert, he once sampled a lot of schools, and most school classrooms have a ventilation air exchange of basically half, one, or maybe two at best. And the guidelines say you should have at least 5 air exchanges per hour. And we're having less than half, or if not even a quarter, meeting a quarter of that guideline in our school classrooms. And of course, school classrooms are very crowded. So what do? How do you measure them? Well, in many ways, let's just measure it and then put in HEPA filters. No, we need to have a complete overhaul of the system. Just like you can't mitigate old lead pipes easily, you need to rip out the lead pipes in the infrastructure bill and put in new lead water service lines without lead in them. And I think this is the main problem, where in many ways we're treadmilling, and some of the technical aspects of this is way too difficult. We need a universal way. Crowded rooms, you need upper room UV. HEPA filters are good, but they are not enough for school classrooms. We need to have a wholesale change in our society. And I think this revolution, this Clean Air Expo, what I hope will spark is a revolution that we can't, just like we can't expect asbestos and lead paint in the walls of our school, in our homes, we cannot have these things in our schools and our homes when it comes to bad air. And I think this, and moving beyond just the everyday technical thing to let's legislatively change it so that all buildings have to meet code, just like for electrical code. That is the approach we ultimately need to make long term. But in the meantime, these smaller changes and portable devices and installations, it has to also be part of the discussion. But long term, we need to make it part of the code rather than teach everyone how to make the air volume flow rate appropriate for their volume in their classroom or home.
Yeah. And I do think that the long term has to be preceded by indeed the short term interventions. And maybe one of the things to do is to really create easier cheat sheets of guidance, how to do this so that it can be done. But of course, we have to build in that direction. Let me go to the last question that I have here. Which is, and John kind of referred to this about the people think that normal things are safe. Air is transparent mostly, even when it's not safe. How do we help people think in terms of air that even is in their homes as potentially not safe? Or whether it's not in their homes, it's in their schools, it's in their supermarkets, it's in all over wherever they go, this attitude that one can go into a building and the air is not necessarily safe. What should we think about in terms of creating that shift in awareness that will drive adoption? This is not an easy question, I think, but I think it would be good to talk about it. Eric, do you want to try taking that on?
Could you repeat that question? Sorry.
The question is, if air is transparent, even when it's not safe, people don't have a signal, right? If you walk into a room and it stinks, or if you walk into a room and there's something else, whatever, that something is not okay. But with the problem with clean air is that very often it doesn't give you any signal to yourself.
Right. And this gets to the issue of the need of universal CO2 monitors. And CO2 monitors can actually give you a sense of how poorly the air is being circulated, ventilation. Because outside of air cleaning, there's two ways to clean. One, you disinfect, which is either zap it with UV or HEPA filter it, or you ventilate it. With the concept that the solution to pollution is dilution, and most of pollution in this world is clean by diluting it. But the problem is, if there's a buildup of CO2, a lot of kids, a lot of people in a classroom or meeting room, then the CO2 levels will give you the best estimation. And we've seen in many schools that the moment school starts, the CO2 monitors spike to well over 1,000, 2,000 ppm. So I think in many ways, many schools and business don't have such a early alert system. Boston schools actually do. They actually have a whole dashboard that gives live CO2 readings in all their schools. And not many other school districts have installed that. Australia is actually discussing of how to institute these kind of monitoring, because they, besides COVID, have bushfires, just like we have wildfires. But in many ways, measuring a lot of these particulates is sometimes, short of these kind of airborne devices of particulates don't tell you virus concentrations, right? So a combination, depending on the situation, of these particulate PM monitors as well as CO2 monitors are the best things to monitor for. And I also remind people, asbestos is also invisible in many ways, other than the dust that can linger in the air, but for the most part, it's invisible to our eyes. So I think these kind of monitoring is just as important. The monitoring technologies, we should have a Boston school district level of monitoring, which is, by the way, all Wi-Fi enabled and connected. We should have that kind of monitoring in every school. And these monitors are actually not that expensive. And it's just involving the school district to sign the contracts, have obviously the budget do so, and have their maintenance and the builders put it into every classroom and link them together. They're not that hard. They're not the most expensive, but it takes a concerted effort. And that kind of activation energy right now, because it's not required in the code of any buildings of any schools, is completely neglected by most school districts. And that's where we have to change and shift the conversation and the revolution.
Yeah,
John, we're down to a minute or some.
Yeah, I mean, I also think, I mean, I agree the value of monitoring. I also think we can rely a little bit on analogies and connections to people, things that people are aware of. But, you know, I think most people are aware of carbon monoxide and its risk, and that if you're in a space where you are, you know, exhausting, you may not smell it, you may not see it, but it can have an extremely high health risk. I think most people are also familiar sitting in a stuffy auditorium or classroom and feeling like you're about to fall asleep, and recognizing that this is in part because of the CO2 buildup, as well as high temperatures and so on. And so I think there are some of these analogies that we can use to say, all right, we all understand that these familiar things, you may not see them or smell them, but they can have a profound influence on your health and well-being. And so I think we need to tell those stories, just as, you know, some of the stories about, you know, COVID or SARS-CoV-2 lingering in the air may be hard for people to digest until they understand that wildfire smoke from Canada or the West Coast can find its way to the East Coast. And so I think we need to take these teachable moments and, you know, explain to people the connections and the things that, you know, maybe we've spent decades obsessing about, but they just haven't had the opportunity to think of.
Thank you. Thanks, Eric. Thanks, John, for introducing the program. Really appreciate it. I want to go now to a special intro piece for a few minutes. I'm going to invite Stefan to come and tell us for a few moments about the session that he's going to be leading, which is coming up next. And we'll go through the other session chairs to tell us what's coming up in their sessions. Go ahead, Stefan.
Thank you, Yanir. Great exchange with John, Eric, and you in the last few minutes. Absolutely awesome. So, okay, talking about the next session, essentially, we'll be focusing on legislation, standards, legal obligation, and this panel will aim at providing an overview of some legislation, as I said, and legal obligation, but also action related to prevention and improving clean indoor air. So that will be session number 2 in just a few minutes. Just after that, we'll have another session which is focused on science and engineering. This panel will aim at providing an overview of science and engineering related to indoor air quality, but also how they can interact with civil society, how we can improve the situation in different settings. So that will be the session number 3, just after the next one. Before leaving that to my colleagues, as you've outlined, Yanir, so to the other moderators, I want to highlight that we have exhibitors. Beside this the speech that you and the discussions that you're seeing right now, there is a list of exhibitors, and in a few hours you'll have a dedicated period to meet them. They have booths, virtual booths that you can meet, and where you can meet with them, discuss, see what they're proposing in terms of solutions. I will just highlight a few of them right now, and I'll let my colleague Dominic talk after that. So we have Sterile Ray. Sterile Ray is one of the world leaders, if not the world leaders, in developing the 222 nanometer disinfection equipment. So we're talking about far UV here. disinfection technologies to kill bacteria, viruses, mold, and other things. So they have a booth. You can meet them there. We also have a booth from Protect Our Province, New Brunswick, or what we called PUP NB, fellow Canadians to me. So, and they will talk about how they organized and make motions in the Legislative Assembly, moving towards a better, cleaner air. So Dominic, I will let you jump in right from here and talk about your session and maybe some of our great exhibitors.
Sure. Thanks, Stefan. That's fantastic. I'm speaking briefly on behalf of Colin, who is moderating the session after that, just because it's 5 a.m. or a bit after 5 a.m. in Australia, and it's a little bit of an early start for him to be here right now. But that session will be on future solutions. So that's looking at the various products and technologies that are going to have the greatest impact on clean air in the years to come, whether it's far UV or HEPA or filtration, improved respirators, the technology and product improvements that are coming. And like Stefan, I'll mention a couple of other of the exhibitors. One is Swegon. It's a market-leading Swedish firm for indoor environment firm with a very exciting approach to ventilation and heating and cooling ventilation products. Another is an interesting company called Make Human Technology, which do CO2 sensors that Eric was just talking about, and looking at when classrooms should be ventilated to improve air quality. I'll pass on at this point, and I've got a couple to come back to when it's my session.
Who's next, Melissa?
Yeah, I believe that's me. Yes, so after the Future Solutions panel is going to be the DIY panel. We are going to be having Jim Rosenthal, of course, the Rosenthal box fame, Joshua Agar, David Elstrom, and Mark Denning of the Air Support Project, all talking about the kind of grassroots DIY movement that has sprung up around clean air, some of the ins and outs of that, as well as the future of DIY technologies such as the Corsi Rosenthal box. So in addition to having Jim Rosenthal himself presenting in the DIY panel, we are also going to be having a booth for the Corsi Rosenthal Foundation, of which he is a co-founder. They are an organization that is working on the wider deployment and supporting people who are trying to build these DIY solutions in schools, their homes, other places where they feel that they are necessary, aka everywhere. And then we're also going to be having Clean Force and their and the air purifiers that they have built, available at the in the booth section for your perusal.
Thank you, Melissa. Are we set with the session introductions now?
Shay, I think you still need to introduce yourself.
So Shay, I couldn't,
Shay.
let me just find, there you are.
Hi, I did it. I figured out the technology. I'm Shay, and I will be running the practical implementation section from 7:20 p.m. to 8:10 p.m. Eastern time, where we'll hear from speakers who will tell us on how to bring practical clean air solutions into our homes, businesses, and communities through proactive individual and public actions. And also, I just wanted to give a shout out to two of our exhibitors that will be in the 5 p.m. to 6 p.m. Eastern time exhibitor section with their booths. Air Support Project, which is a business and social startup with the slogan, "Know Better, Breathe Better." Their team is putting the finishing touches on a prototype for a commercial air fan and filter air cleaner similar to the do-it-yourself CR box, and are in the process of taking it from project to product. And they will have a free download of a wildfire smoke edition of their new quarterly magazine, Clean Air Times, available at that booth. So definitely worth a stopover during that section. We also have Farmwood and Pathogen Reduction Solutions, who are collaborating businesses in the ventilation industry and work across commercial, industrial, and domestic sectors from design, installation, upgrades. And they have an excellent presentation at their booth as well. So be sure to check them out.
Thank you, Shay. I just now, Dominic, are you going again?
Yeah, so
Go for it.
the final session will be the one that I'm sharing for myself on the politics of how we get all these things to actually happen. And so a lot of the other sessions are in effect showing everyone, showing the horse where the water is, and our session is about how to convince it to drink. And I also want to mention one of the other exhibiting companies, Smart Air. They're an air filter company. I'm not sure if you can see this. They make air filters that are very affordable and very good. I have a couple of them for myself, and they're in the exhibitor session as well.
Thank you, Dominic. And now I think I will turn it over for the next session, because we're just about to start the next session. So Stefan, I think you are next, if I'm understanding correctly. So let me just pass the, there you are. Thank you everyone very much. Go ahead, Stefan.
Thank you, Yanir, for the introduction. I can add just a few other exhibitors just before we jump in the session. So we also have Dentec, manufacturer of safety products. We also have the WHN World Health Network, as you know, the Clean Air Accelerator, and Aranet, which is well known in the monitoring industry related to CO2 and many other things. So let's start the second session, legislations, standards, and legal obligation. In light of the highly justified concerns during the COVID-19, but more generally with other airborne disease and even with air pollution, it is crucial to understand the legal framework and the guidelines that governs indoor air quality. So that will be the core of the purpose of the discussions in the coming 45 plus or minus minutes, even a bit more. So just to put that in perspective, 2 years ago, right in the middle of the pandemic, October 8, 2021, the UN Human Rights Council declared that having a clean, healthy, and sustainable environment, so it's a wide spectrum, but definitely including clean air, is a human right. So air quality, or lack thereof, indeed, and air pollution, so air pollution, but also airborne disease, kills. So it's just air pollution. This side is 8.7 million premature deaths a year. Typically, in the last few years, it has been 8.2, 8.7. So that's kind of a huge number. COVID itself officially reported 7 million deaths, but we all know that it's more than that if we go beyond the officially reported one. Just to put that in perspective, there are 55 million deaths per year in the world, premature deaths. So I'm not talking about natural source, but premature, which includes disease, cancer, and those things. And by the way, respiratory diseases are now the second cause of deaths in the world. Second, they were far below in this rather sad list of cause of deaths just a few years ago. Now they're second and they're rising still. So about 8 million, as I said. Out of these 8 millions are indoor. So coming from indoor problems and indoor causes. So that's really significant. And it's not taken into account the portion coming from COVID. So this is really more generally. So coming back to the session. So the panel aims to provide an overview of some legislation, some standards, but also legal obligation and actions related to this prevention, the prevention, but also improving clean indoor air and the responsibilities and obligation, as I said, that are affected or impacted by this. So we'll have a set of outstanding panelists and speakers. We'll start with our first one, Peter Bols. He will talk about the Belgium indoor air law and why and how it passed. So you know that there is, and I will let him explain that. It's better. Definitely do that better than me. So Peter Boll works for the Federal Public Health and Public Service, Employment, Labor, and Social Dialogue. He's the head of the Department of Regional Health and Safety Inspection. During the pandemic, he became the coordinator of the Indoor Air Quality Task Force of the Corona Commissariat, where guidelines and emergency legislation were made for safer indoor air during the pandemic. So very at the heart of the topic. I'll let you start, Peter, with your impressive work with the Belgium team. Go ahead.
Thank you, Stefan, for the invitation. Good evening from Belgium. I made a little presentation on what we were doing and what we are doing right now. During the pandemic, I worked also for 19 months for the Federal Public Service of Public Health, but now I'm back at the Federal Public Service Employment, where I'm department head of the Labor Inspectorate. For the whole topic, it's important to understand that before COVID in Belgium, we already had some stuff on indoor air quality, and we went some back in legislation. And of course, probably if you even go back before the Second World War, then there will be some legislation to be found. But after the World War, we started in 1946 with legislation on workspaces, and that they should have 30 cubic meters per hour of fresh air for each worker present. And that's a kind of legislation that evolved, and it finally evolved until 2019, just before the pandemic, where the legislation on work said that each employer should have risk analysis and an action plan so that he can provide the best possible air to his employees, that it should be 40 cubic meters per hour and per person, or that you should not exceed a maximum CO2 increase of 500 ppm. So given an outside level of 400 ppm, that would make 900 ppm. Except when the sources of pollutions are kept under control. Then you could have a bit less ventilation, because if you have the sources under control, there's no ventilation needed for that. And then you can descend to 25 cubic meters per hour per person, or not increase by 800 ppm, what would be 1200 ppm in total. And legislation says that it should be directly that way for new buildings from new employers from January the 1st of 2020 onwards. And for older buildings, there should be an action plan with a focus on short, medium, and long-term solutions. So short term, it would be like opening a window. Medium term, it could be installing an air purifier, and long term would be investing in a ventilation system. Then COVID came by, and during the pandemic, we had some advice from the Superior Health Council. I have put some links in here. The first guidance on ventilation was there in May 2020, and it also grew during the time. And from April 21 onwards, we started advisory to the public and also emergency legislation, which is probably known because we have things like there should be a CO2 monitor visible, and we also had things like occupancy should be a function of the ventilation that is available. So if you have good ventilation, then more people are allowed. If the ventilation is not good, then the occupancy should be more limited. And we also installed a database with air purifiers so that if you want to invest in an air purifier, you have to know which ones are good. And we learned some lessons from COVID. So yeah, this should not happen again, and certainly not on the same scale. Our government is convinced that better indoor air quality should be promoted. And we should continue and extend the policy on indoor air. And that's why our law of November the 6th, 22 was born. And this law, we had legislation that was focusing on workers, but this law is focusing on public accessible closed spaces. So instead of workers that are put central, here the public is put central. And in that law, we have 2 reference levels. You should think about reference levels as, if you want to invest, what should we invest to? Well, we have an A reference level, and there, of course, you have the choice either to provide a flow rate, either to not exceed a certain CO2 concentration. So either it is a flow rate of 40 cubic meters per hour per person with outdoor air and or air purification. So we put air purification in it, but with at least 25 cubic meters per hour outdoor air per person, or either 900 ppm CO2. A more modest level would be either at least 25 cubic meters per hour outdoor air per person, or not increasing 1,200 ppm of CO2. Second step is measuring the air quality. We are still working on that. It has been elaborated in a first royal decree right now. We say that you should at least monitor CO2. If you want to monitor other pollutants, then that's certainly fine. It's the more the better, I would say, but at least the focus would be on CO2. In order to focus on actions like, okay, if it is rising too high, because CO2 is saying something about the ventilation. If it's rising too high, then we have to open doors and windows. It's also to ensure that ventilation systems that are in place, that they are working properly. And you can opt to either monitor in the space itself or in the extraction of the ventilation system. Second thing is communication. You can communicate with by the CO2 monitor, which is either in the space or in the extraction, but you can have a direct display in the room where people can read the CO2 level, or you can also make it not visible in the room itself, but make it visible by a QR code or some other technology, but then you should have a history of at least 3 days. And a third way to communicate is the communication of the flow rates that are available in the room. But ventilation is not everything. We should also limit the sources of indoor air pollution. So that's why we are asking for a risk analysis and an action plan. So you should describe the room and its facilities for ventilation, air purification, doors and windows that can be opened, the number of people that can be present and what activities they do, what sources of indoor pollution that you have, that can be floor coverings, that can be open fires, and the results of measurements that you have done should be taken into account for that risk analysis. We also want to make a framework for air purification, and there we have two things that are important. First of all, it should work well, and second, it should not harm. So with that in mind, we want to construct, or we are working on legislation to have a list for air purification, not only for COVID, but also for communicable diseases through the air, and not only for the diseases, but also for other pollutants that can be present in the air. And then in a further stage, we want to implement certification and labeling. So you should think about that as an extension of the communication thing. We have three options. So you can show the actual concentration, you can show a history online, or you can communicate on the ventilation or air purification flow rates. But yeah, who's saying that this is measured the right way? This is sufficient. Yeah, you're sure about the values that are communicated well. Then you should have, if you want to be sure, you should have a control, and you should also have strict communication of those parameters. And we also see for the future that if you have a historical level of CO2, that in the labeling, the label can tell something about the history of, let's say, the last year, it did not went higher than X or Y, then it's also something that can be taken into account in that label. Also want to have a good consultation and dialogue. Social dialogue is in the title of my federal public service. And that's why in that law we have made it possible to have an indoor air quality platform. It already exists. In that air quality platform, we bring together the governments, the scientific institutions, the universities, the fabricants, the people who make the solutions, HVAC people, certificators, and the sectors that are involved, sectors that are attracting a lot of public. And we want to bring them together to enhance knowledge, to support the improvement. How should they do it? How can we do it? We're all in this together. It's not the government that says it should be this way or that way, but we try to do it together. We try to make together recommendations for policy, and we also try together to work on sensibilization. So that's in a nutshell what we are up to in Belgium. Thanks for the invitation.
Thank you very much, Peter. Great presentation. We'll come back with the questions and exchange later on. I just want to clarify one thing quickly, really regarding what I said before. So maybe my accent or my wording made it I was talking about COVID like a past situation. Maybe I referred to past data, but definitely not saying or didn't meant to say that COVID is finished. I absolutely not on that path. COVID is there. COVID is still making so many people struggling. I just want that to be clear. So thanks for highlighting that on the chat. Just want to make it clear that's not what was supposed to be, what was meant. Sorry for my French accent coming back at some point. Okay, so next speaker is Janisha Pollard. She's the branch chief of the research branch itself at the National Personal Protective Technology Laboratory, so the NPPTL. And as the branch chief, she ensures that NPPTL maintain a responsive research portfolio that supports the needs for research and guidance to improve the design, the performance, the usability of personal protective equipment and technologies. So our speech will be directly regarding that topic of respirator fit for all their research program. And I just welcome you, Janisha, so you can go ahead with your presentation.
Thank you so much. And thank you for the invitation to be here today. So I do realize I have 5 to 6 minutes. So I'm going to go as quickly as possible. I will say that I did add some QR codes within my slides. So hyperlinks are very difficult to follow at times in presentations. So I do have QR codes that'll directly link to some of the information I'll be presenting. So for some of you who may not be aware, the National Personal Protective Technology does reside within the National Institute for Occupational Safety and Health, which is a part of the U.S. Centers for Disease Control and Prevention. And really, NIOSH is targeted with preventing work-related injury and illnesses by advancing the state of knowledge and practice of personal protective technologies. So specifically with NPPTL, as the nation's PPE laboratory, we do provide national leadership coordinating what we consider to be equitable PPE protection. So, the title of my presentation is Respirator Fit for All, but really our research program focuses on equitable PPE for all as well. So as part of that framework, we're documenting existing characteristics and gaps related to PPE. We're organizing collaborators across the PPE community. We're working to identify solutions and approaches that actually address these identified gaps and challenges. And then we're also establishing a prioritization framework. And so that QR code up at the top right corner actually takes you to our equitable PPE protections workshop, which happens last November. So we do have the recordings available on the website if anyone's interested in learning more about equitable PPE protections or specifically what we consider to be our role. So specifically for Respirator Fit for All research, we're really looking to address the needs of respirator users, as well as address some known gaps related to respirator fit. So this image showed someone wearing a respirator that's incorrectly donned. Clearly there is a nose clip at the bottom and that's on their chin. There's a strap that's under their ear. So this would be an incorrectly donned device. And that's what we're hoping to reduce. So when it comes to respirator users, they do have a series of questions. And, this could be, how do I pick the right respirator for the hazard? How do I pick from all these options of respirators that's on the market to identify one that I think will fit me well? Once I do identify one, how will I know that it fits? How do I know I'm even wearing it correctly or putting it on correctly? How will I know that throughout the day or my work shift or whatever my activity is, that it's going to continue to fit me? And then will other things impact the fit of my respirator, whether that's, eyeglasses or safety glasses or a face shield? NPPTL also commissioned a paper to identify gaps areas related to respirator fit. And that did identify 9 gaps. And this includes, some filter and face respirators do not fit many workers, or, what happens when you wear it for an extended period of time. There's limited knowledge there. Our regulations in the US associated with respirator approval, they may not accommodate new and innovative approaches to well-fitting FFRs. There's also very few studies related to respirator design for members of the public. And we know that to be true because a lot of the anthropometric data, isn't based on the public population. A lot of it's based on military population or working population. And then the comfort is important, but we really don't understand it. Tons of publications were published during the COVID-19 pandemic, and everyone, it seemed like, came up with their own way to identify comfort or their own scale. So even when you compare paper to paper, it's very difficult to identify or difficult to make comparisons because they are using very different metrics. And then the impact of facial hair on fit, or providing solutions for people that do have facial hair or full beards, is poorly understood. Again, the interoperability of FFRs with other PPE, whether that's goggles or face shields and things like that. And then we need a better understanding of respirator performance in real world settings, as well as ASTM F3537 may not be adequate for new fit test methods and instruments. So I'm going to go through some of the things that we're actively working on within NPPTL to address these gaps, as well as address these respirator user needs. So the first thing we're doing is we're integrating ASTM F3407, which is the respirator fit capability standard, into our approval process for respirators. And so that standard defines the performance requirements for ensuring that the model can achieve a pass-fail criterion, which is over 50% based on the NIOSH bivariate test panel. So that requires 25 people who meet the bivariate test panel requirements, and then the respirator would have to pass 13 of those 25 fit tests. And then the hope is that it really assures the respirators can be expected to effectively protect the wearer against particulate contaminants. This is a clean air workshop. We are talking a lot about clean air, but realistically, there's a lot of situations, where the air just isn't clean. So we do have to rely on respirators and respiratory protection. And we do want to be sure that when we do wear these respirators, it's giving us the protection that we expect and the protection that we need. Now, this doesn't eliminate the need for a fit test, but really the purpose of us including it within our respirator approval program is to increase the probability that the available respirators will fit the general working population. Another thing we've done is we've partnered with NASA to develop the Respirator Fit Evaluation Challenge. So this is an open competition. It is a crowdsourcing challenge. It pulls on innovators in the public and small businesses to come up with a solution for fit testing. So the focus is on filtering face piece respirators. It is a multi-phase, multi-year effort. We're currently in phase 2. So phase 1 has ended. It does have a total prize purse of $350K. But really the goal is to have, these innovators create a solution that'll be market friendly, user ready, to provide solutions for fit testing. This could be a new fit test method. This could be a real-time fit monitoring tool. It really is something that we hope to make widely available to support fit testing and respirator fit evaluation by all, whether that's the public or occupational settings. And this QR code in the bottom right does take you directly to the Respirator Fit Evaluation Challenge website. So these are our phase 1 solution winners. All of these winners did go on to phase 2. I think one of them did remove themselves from the phase 2 challenge. As part of phase 2, they are required to develop prototypes, and then they will be tested by NIOSH. Another thing we're developing is a mobile facial scanning app. So, one of the questions that I mentioned that respirator users may have is, how do I pick a respirator that may fit me well? So one of the things that we're working on is developing a mobile facial scanning app. It will be available on smart devices, whether that's Apple iOS devices or Android devices. It'll take a scan, whether that's a picture or video of your face. And then initially, it's going to put your face into our NIOSH bivariate panel, as well as our NIOSH PCA panel. The benefit of putting you or categorizing you into that NIOSH PCA panel is that PCA panel directly informs these 5 ISO digital head forms. And we have these head forms in our lab. So that means if we can figure out what your head form size is, we can do mannequin fit tests to determine which respirators fit these facial head form size as well. So if we can match you to a head form size, we can then recommend a respirator that we expect to seal your face well. But it also allows us to determine when people don't fit within the bivariate panel well, or someone doesn't fit well within our PCA panel. So it will have the option within the app to send your facial scan back to NIOSH along with some demographic information, because we may identify we need another head form size, or we need a new panel cell to accommodate the needs of the working population, as well as the needs of general public who may be wearing respirators. So this link in the bottom left actually takes you to our ISO digital head form webpage. So let's say you identify a respirator you expect to fit you. You go pick it up from your local hardware store, and now what? You can't do fit testing at home. It may not be possible to get it from your employer if your employer doesn't have a respiratory protection program. So another solution we're working on is the development of an evaluation of a train the trainer program to support equitable and effective respiratory protective device use. So this will be a national framework. It's a fixed firm price contract with the Public Health Institute in partnership with the California Department of Public Health. And the goal is really to utilize our community-based settings and our trusted communicators to provide respirator selection information, respirator use information, as well as actual fit tests. So the goal would be, let's say there was a wildfire, you're located in California. In theory, you'd be able to go into your local fire department and they can give you a fit test for the respirator that you bring. So that's really the goal. So by having this framework and this train the trainer program, we'll train a series of trainers that can then go on and train the next series of trainer on, framework and guidance and implementation information that's provided by us. So we can support, respirator fit testing as well as respirator selection nationwide. Another issue that I mentioned was, or another gap is, how do you support FFR use by those with facial hair? And there's numerous reasons why someone may maintain facial hair. It could be religious reasons, it could be cultural reasons, it also could be medical reasons. So a lot of research has been conducted looking at, under mask beard covers. This is not a NIOSH approved configuration. So, this would not be in compliant with US workplace settings. However, we are going to develop an in-house research study where we look at the respirator fit capability when people who have unshorn beards wear these beard bands and then wear a respirator over the beard band. So what we're working on now is developing a federal register notice, because we do want to solicit current NIOSH approval holders that may be interested in this type of configuration. Because if we do the research and they say, hey, we're really interested, we would like to consider how to make this an approved configuration, you know, with the right data and coming back to a NIOSH for approval, this is potentially a NIOSH approved configuration. But it would be up to that NIOSH approval holder to pursue that. So in summary, you know, our goal for FY24, this is a CDC NIOSH goal, is, you know, how do we identify innovative solutions to assess and validate fit of a wide variety of respiratory protective devices and improve adoption by end users. So I shared quite a few things that we're doing with you all today. And I'm happy to take any questions. And this is my contact information if anyone would like to contact me directly. Thank you for the opportunity.
Great, thanks very much, Janisha. A huge amount of information. You were quite impressive in giving us all those things.
Thank you.
Thanks very much. So our next speaker, I should say our next speakers, they will be two, Kathleen Gadd and Ryan Murphy. They will talk about the advocacy sandwich in New Brunswick. They will explain what it is later on. So Ryan Murphy is a teacher of technology at St. Malachy Memorial High School. Kathleen worked in evidence and knowledge translation as a librarian, as well as a medical office administration, turning in fact family medical clinics into clean air clinic with CO2 monitoring, for example. They both advocate for the Corsi Rosenthal box, the HEPA filters, and they're involved in the Protect Our Province New Brunswick, which is behind this big endeavor that led to the advocacy sandwich, which they will be talking to. And Kathleen, you're also a member of the Canadian Aerosol Transmission Coalition. We're colleagues in that coalition. So I'm pleased to welcome you both for this presentation.
Thank you so much. Hi, thanks, Stefan. So can you see my
we see it well. That's perfect.
Perfect. Okay, great. Oh, I'm not sure that it's going as a slideshow, but I also don't trust my internet to work very well. I'll just click through it. Yeah, my mouse is being weird. Okay. Did I freeze there?
We hear you well, but the page is not changing, just so you know.
Okay, perfect. Okay, I think my internet has caught up to us. Maybe. Sorry. So, welcome. Hi. I'm in New Brunswick, which is a small Canadian province. Our population is 800,000 people. So, in medicine and in politics and education, it can feel like everybody knows each other. Our approach is to find and support a handful of people who are committed to effective change. And one of those people is teacher Ryan Murphy. So Ryan is going to speak on two initiatives: promoting the opposition party's motion to modernize the Clean Air Act and his work in forming the New Brunswick Teachers Association.
Thank you, Kathleen. In March, an opposition party motion was presented in the New Brunswick legislature, calling on the government to modernize air quality laws and standards and develop a plan to monitor, report, and improve air quality in public buildings like hospitals and schools to mitigate the risks associated with the transfer of airborne illness. We needed to make that motion so popular that no one could object to it. Nearly 200,000 people have seen that post. It was covered by provincial media. It attracted international attention. And a lot of folks had done a lot of work to bring the importance of clean air to the population. Motion 36 passed unanimously. On top of that, we now had over an hour of video from New Brunswick politicians from all parties discussing the importance of indoor air quality as it relates to airborne transmission. And that started with regular citizens, parents, teachers, community members. Many of us were mentioned by name during that motions debate. It really did start with folks who knew we could do better and realized we must do better. But we kept pushing. At the request of the New Brunswick Teachers Association, the NBTA, I wrote a brief outlining what schools and the NBTA membership in those schools could do to further the ideals of Motion 36 and support the relevant recommendations of the post-COVID-19 condition in Canada report published by the Office of the Chief Science Advisor of Canada. Much of that brief drew on a previous report commissioned by the government of New Brunswick. That report is often cited to teachers and parents and media as the reason HEPA donations are banned and CR boxes must be removed. It actually recommends several times that supplementary filtration should be added to all the rooms. The next week, the NBTA executive passed the following motion: that NBTA work with relevant partners to lobby government of New Brunswick to make transparent how air quality in schools is currently measured and make reporting and transparency around findings readily available. It's a start, but we keep pushing. Tomorrow, I'm speaking at the New Brunswick Teachers Association's first provincial session on school air quality.
Thanks, Ryan. I look forward to hearing how that goes tomorrow. So on our website that's linked on this slide, if I can get it, there we go. So our website is linked on this slide, and you can see the details of these initiatives that Ryan has just talked about. Ryan's brief is linked there, as well as a link to the debate on the Clean Air Act motion that was in the New Brunswick legislature. So our group is called POP-NB, Protect Our Province, New Brunswick, and one member, Dr. Dalpé, also successfully brought forward a motion promoting ventilation in schools at the New Brunswick Medical Society AGM that was held last month. You can see the text of her motion and more on our site. We describe our approach like a sandwich. So we have one layer that's bringing the awareness of the importance of clean air to the general public. And another layer of the sandwich is working to inform and support motions and legislation at leadership levels, like the provincial legislature, the MBTA, NBMS, and any other group that we have connections to, or we can end up at their AGM. So we find it necessary to engage simultaneously the public and leaders because the stakes are so high and there is a lot of work to do in order to bring clean air to New Brunswick. So we're finding that virtuous cycle of the advocacy sandwich working well for us. And I think, as John Levy mentioned in his discussion, once you have success in one area, that does make it easier to bring other groups and people on board. So have a look at our website that's linked on this slide. And if anybody has any questions, we're really eager to make connections worldwide and keep on working on this. Thanks, Ryan, and thanks, everybody.
Thank you very much, both Ryan and Kathleen. Great presentation. I think you now have an idea that we are looking at this important thing from different lens. So we had people from agencies, from the government, from department, now from the people, the communities that can act, that can organize to impact the legislation. We'll now have another presentation from Mark Odenbach. Mark Odenbach is a legal advisor, a lawyer who operates his own firm, which goes by the name of Barber Odenbach. Mark has a strong background in international structured finance, where he provides counsel to numerous blue chip company, international corp, big corp, and investment bank, by the way. But today he specialized in business law for entrepreneur. For many decades, Mark struggled with severe asthma, so it's a personal thing, a condition doctors believe to be incurable but manageable. Surprisingly, during the course of the pandemic, his asthma was cured simply by wearing masks and maintaining a focus on clean air. So that's why we have a lawyer that will talk about those things that we need to do and what we can do. He no more needs medication because he found other ways to deal with that. So welcome, Mark, and we're pleased to have you talking from the legal perspective how these important matters can be approached.
Thank you, Stefan. Can you hear me?
Yes, we hear you well. You can go ahead.
Very good, very good. Thank you to everyone who has been preparing this conference, this expo. Thank you so much. It's great. It's very interesting and very, informative. It's fantastic. From a legal perspective, I don't have the privilege of being a citizen or lawyer in Belgium. If you like, I'm a German lawyer, and Germany, in that respect, as in many others, is a third world country, so a bit lagging behind. But of course, we have many laws and many legal concepts created for the protection of health and of course of life. So in theory, one could apply a couple of laws on clean air, because if clean air kills or at least makes you seriously ill, and if the law says that people have to be protected from diseases and death, it should be very clear that these laws should be applicable, and that's it. So, it's a general laws for the protection of health and life. You have it in different areas of law. You have it especially in the workplace. You have it. You could, in theory, could even call the police if there's a case where people get jeopardized in their health. But all this doesn't happen, and I think if you initiated a lawsuit based on these general laws, very different from the law in Belgium, you would most certainly lose. Why is that? I think it's because, it is acknowledged by judges all the time if you talk to them privately. When they get a case which is a bit unusual, they first decide, what decision they want to make, and then they look at the law and find excuses for the decision they have made from a gut feeling perspective, if you like. I think this is very likely to happen. And I think the real reason is that law is not a science. There's a lot of interpretation and discretion for the judges, and they will be driven consciously or unconsciously by what the other norms in the society are, not the legal norms, but the moral norms, the economic norms, etc. And this complex of all norms together, I've learned recently, is called social institutions. So I think one has to change the social institutions, i.e. the whole mindset of the society, which I think is very difficult. But that is something you are doing anyway, listening to this expo and then to all the speakers. That is what is happening. And if, for example, there were more articles on clean air in the media, judges would read it, or they could read it at least, and then based on that previous information, when they then get a case, they are more inclined to apply the laws for the protection of health, the general laws. Again, in Germany, we don't have specific laws. If there were specific laws on CO2 levels, if there were specific laws on PM concentration in the air, if there were specific laws on, you know, what a school has to look like in terms of clean air, that would be easy. But the laws are very generic. They're very openly drafted, and that's basically it. Well, that's all I have to say. Talking from a third world country, different from Belgium.
Thanks very much, Mark, for the presentation, and from the third world country that you're in on the clean air side. Thanks for this perspective. It makes it really important to dive further into. Okay, our next speaker is Anne Miller. On top of being the executive director of the Project 95, well-known Project 95, Anne is a seasonal healthcare consultant who has worked with clients of all size across the life science, medical device, therapeutics, and diagnostic sectors. She brings strong quantitative skills to bear on project while applying her years of strategy and project management skills to ensure insightful and actionable results. So today you will talk about caveat emptor, the need for enforced standards for consumer protection. So welcome, Anne.
Thank you so much, Stefan. Can you hear me okay and see my screen?
We hear you well, and we see your slide.
Okay, perfect. I just wanted to mention, because I'm following on from some super speakers, that I really had so much envy for the Belgium situation with Peter. Like, if we could all have countries that had these top-down laws and were really like thoughtful, it would be wonderful. I also wanted to say I've seen a lot of Jonisha Pollard's work, but I think the work that the MPPTL is doing is fabulous, and I will speak to NIOSH also. And then Ryan and Kathleen, as I try to attend the CATC, the Canadian Aerosol Transmission Coalition meetings as much as I can, it's just such an energizing group that is working so hard for change in Canada. So I really respect the work that you're doing. And it really, I think, speaks to the need for individuals to advocate as well as for that top-down. Thank you, Stefan, for including me in this presentation, and I'm grateful to you and Yanir and the World Health Network for inviting me to participate. I really won't talk long, but I wanted to thank all of you also for listening to this standards and legislation section, like an area that doesn't seem like particularly sexy, but I think is super important if we're going to make change. And I know that we're all here because we share a desire for clean, safe indoor air. And nonprofit Project N95 shares this goal as well. It's not in the actual presentation, but I don't think. So Project N95, if you're not familiar with us, we are a national nonprofit in the United States, and we're here for equitable access. Like NIOSH was talking about, we're really focused in on affordable, authentic PPE, like respirators, as well as other technologies. We started in 2020, and we tried to get legitimate N95s to healthcare workers. And over time, our mission evolved as we understood that COVID was airborne and that we needed to really be able to protect all people, not just doctors. So we really do focus on offering protection to all people. And like for pandemic, which is still ongoing, wildfires, other infectious disease outbreaks. And we do this through free respirators to the public, or also low-cost respirators. We have our own testing facility where we double check the performance of respirators that aren't regulated by an enforced standard. So my really lovely topic is about enforced standards. And I think about, like, people are like, it rubs people the wrong way, right? To be able to have like an enforced standard. It sounds bureaucratic, but I think that we need to have enforced standards to do a much better job to provide clean indoor air. In the United States, you can clearly see the food sanitation grade when you walk into a restaurant. You know if it's an A or B, and you can decide whether you want to step into that facility. And in the same way, in certain cities like New York City, you can see the energy efficiency of a building. And consumers should have the same assurance that the spaces that they live, work, and enjoy life in are clean, safe, indoor air spaces. So I know that this just sounds very bureaucratic, but I also just want to say that regulated standards really help drive innovation. If you saw the crowdsourcing project from NIOSH, there's been some very innovative designs that have come about, because if you know what your target is, then you know how to, like, you can do all sorts of different things like the ergami, and there's different kinds of masks that have come about because they meet the standard. And the other thing is that they do present significant barriers to entry from cheap competitors. So while it's a hurdle for you when you're going through that process, it also helps keep out substandard products. And lastly, these enforced standards do help protect consumers. So Project N95 really focuses in on treating, these are the 5, I'm going to go to my last slide here, the 5 areas where we need enforced standards. So we really focus almost exclusively in interacting with the consumer. We have a lot of people who call in or email us, right? So it goes without saying that consumers deserve quality, authentic PPE made to a regulated standard. So we all know what standards are. They define the performance characteristics, claims, test methods. But the regulated standard means that somebody's actually checking, an independent body that's actually checking. And that's what we need across the board on all of these categories in clean air. So the US NIOSH rated respirator, the thing we call an N95, the European FFP filtering face pieces, and the Korean KF94, they are all made to an enforced standard, although the hurdles in those enforcements are a little bit different in different markets. But in general, a regulatory authority check perform to the standard. If you're familiar with a NIOSH rated respirator, NIOSH doesn't just require that stamp of approval at the beginning, right? But they have ongoing assurance that this mask performs. So it's like production lot-based testing, audits and inspections, and then they enforce the labeled claims. We saw a lot of product at the beginning part of the pandemic where people were claiming that they were selling a NIOSH approved mask when they didn't have it. And then there are other claims like it prevents COVID. So it's really important. NIOSH can enforce those standards, and we can protect people, and we can protect the companies that are producing that. So I think it's just like, if I can say one thing, we need to have a regulated KN95 mask standard. If you're familiar with the KN95, it's the most popular type of mask sold in the United States. It's made to the Chinese GB 2626 2019 standard. I have no issue with the standard. However, there is no enforcement at all of the standard. When you buy a KN95, you literally have no idea if this product actually performs as described. People think of them as an N95 with ear loops, which is like, hurts my head to say that out loud. But the thing is that these are not, they're not checked by anybody. So I think it's just super important to have. So that's my first point. We need to have regulated standard for KN95. I don't think the Chinese government is going to do that, so somebody else needs to step up and do that. The second thing is that we don't have a child or consumer standard, right? The US standard is for industrial needs, makes total sense, but the world has changed with the pandemic. So we know, and Janisha talked about it, but elderly people, people of different races, children, women, they have different facial structures, right? And these masks don't fit all of these different groups well. And so we really need to have a consumer standard, a child standard. And then, as Janisha mentioned, there's no fit testing for consumer masks, and there's a lot of interest in that. And so whether it's at a firehouse or your hospital or clinic, so I know that in the US, NIOSH is working diligently on these issues. I will say, I hold NIOSH near and dear to my heart. This agency is underfunded, and it's limited in how much it can do. And they have great expertise. So I would encourage people, if you're in the US, advocate for more money for NIOSH. I'd love to see their stuff come to fruition faster. My third area is we need to enforce standards for HEPA air purifiers and FAR UV. It's so exciting, right? We have these FAR UV, germicidal, radiation to clean the indoor air, HEPA air purifiers, and they're really exciting developments for homes, schools, and workplaces. But there's no enforced standards. There's actually a lot of different standards, but there's no enforced standard on the finished device. And so this means that consumers are really not protected at all in this process. So The one place where there is, if you're doing a germicidal UV in a hospital, or you're doing even a HEPA air purifier that's labeled for use in a hospital, that comes under the jurisdiction of the FDA. But otherwise, for consumers, it's really like caveat emptor. Anybody, you have to just be careful. The EPA has these really fabulous Energy Star ratings that for all of these HEPA air purifiers, but many people are really confused. You wouldn't imagine how hard it is. Eric Fielding mentioned this. People don't know how to measure their space. It's mind-boggling to me that that's the case, but people are like, I'll lie down on the floor, and I'll see how many of me I can get across my room. They don't understand how to measure their space. And when you're dealing with consumers, it has to be super simple. And so I would just say that they're really ill-equipped to understand these technologies, and they rely on marketers' claims, right? So they say, like, in a 300 square foot space, this works in a 300 square foot space. But why does it work? How many air changes per hour are you getting? What's your clean air delivery rate? And what speed is that device set on to achieve those things? So these are things that people don't understand, that you have to set it on the highest level. AHAM, which tests some of these devices, the AHAM setting, it's tested on level 3, or level 5, the highest level, which is the noisiest level. And people go in and they set it to a lower level because that's what they want, but they're not achieving what they think they are. And so I would just say that it's really super important that we continue to advocate for protections for consumers. Substandard masks that don't fit, they give you a false sense of confidence. You rip off the consumer. And likewise, these new high-tech solutions are super sexy. They could be a big improvement. Without a regulated standard, consumers can be spending their hard-earned money on a false promise. So I hope that all of you will join me in calling for regulated standards for safe, clean indoor air. So thank you very much, Stefan and Yanira and the whole World Health Network team, and all of you for listening to my soapbox. Thanks.
Thanks very much, Anne. And you're absolutely right. We need enforced standard as soon and as much as possible. The next presentation, and I will just explain something, is from William Banflett, Professor Banflett. So now he's currently on the road, so he'll not be able to speak, but he asked me just a couple minutes ago just to present the key items he wanted to share with all of us today, and I have his presentation. So I can just give you the main items. I can just give some credential on him. So he's a fellow and presidential member for the ASHRAE, so the American Society for Mechanical Engineers, and also is member of the International Society for Indoor Air Quality and Climate. So Dr. Banflett is the author and co-author of so many articles and books. And he is the chair of the ASHRAE Epidemic Task Force, which we all heard a lot about in this pandemic. Present tense for pandemic, as I've learned how to say it now, so it's better. Okay, so this presentation, and I will not go through everything, but the key messages, so you should see it right now, was definitely on the ventilation part, to control aerosol and transmissible pathogen, especially for the healthcare setting, but I think we can definitely extrapolate that to so many things, so many other settings. Transmission of SARS-CoV-2 through the air is sufficiently likely, so we don't need to talk about how far it is. It's sufficient, that's for sure, that airborne exposure to the virus should be controlled. So we need to control it. It's not if we would, it's absolutely something we need to, and that's one of the messages you wanted to carry. And that includes changing and updating the building operations, such as the heating, ventilating, and air conditioning systems. It was to recall a few things, and in a few minutes we'll have the session on science and engineering, so I will not go far on the air care controls and the different layers of mitigation. He's coming with that, but I'm sure others will do that in the next session. So he was to be giving some examples in different places. By the way, his presentation will be available after the session and later on in the day, so you will have the chance to look at every single items he was referring to. So the very first standard which touches ventilation is the well-known ASHRAE standard 62.1. It has been updated in 2022, and it's explaining that ventilation is not only in outdoor air coming in, it's also recirculating air that has been treated for the purpose of maintaining acceptable indoor air quality. So that's an important thing here. It needs to be treated. It's not any recirculated air. Some other technical justification, I'll not get into those right now. The ASHRAE standard 241, which was released this very year, is specifically on control of infectious aerosol. So it's really a new standard, absolutely a key thing that will have a lot of ramification down the road. So that's an important point he wanted to highlight. So the ASHRAE came with new standards related to that. And it goes with a few items. I'll not get into that in detail, but it's talking about how we can dilute, so dilution, but also touching air cleaning like germicidal IV, UV, and reactive species, control of reactive species. There are other standards, indeed, the ASHRAE 170 for healthcare settings, the ASHRAE 241 I just mentioned, but also from the CDC, an older guideline, but has been updated just a few years ago for environmental infection control in healthcare facilities. This presentation that you'll have access to will give you more insights on those. I will not talk about the key characteristics, even some numbers on the number of air change per hour of outside air and so forth, depending on the type of the usage of a room. And what I wanted to highlight, and I promised that I'll say that to you, it's engineering controls are important, and it's an important part of infection risk mitigation scheme, but it's only one part. We need to have many prevention measures. This is one that should not be neglected, but it's one amongst others that needs to be done. There are different ways to achieve that, but the idea here is to clean the air that will be delivered. So that's the clean air delivery approach he's referring to here. And there are so many strong reasons to apply that to healthcare settings, but also in so many other workplaces, at home, and many areas, residential buildings, long-term care, etc. So that's just what I wanted to add before we switch to some Q&A with our speakers, which are here on the panel. So I'll start with a question, and any of you in the panel that were just talking, you can jump in and just speak, and we'll try to spotlight you for the exchange. So I'll start with a question which is a bit more general, but touches one point which was in the chat. So how do we ensure that the different regulations or standards that were referred to are followed? The question was, we often have situation where risk analysis, for example, is required, whether it's healthcare or other places, but in reality, the risk is just assumed to be zero, and they are not applying those standards or those regulations. So from all the panelists, so whether it's from department, agencies, from the legal side, from the community, the advocacy group, what would be a way, or how do you suggest that we ensure that these regulations are followed? Those who are there, and even asking for improving them. So that's if I get a bit further into the discussion. So anyone wants to jump in for that question?
Well, Peter Bolle here from Belgium. I think we should have an effective control, and that's also the reason why we see something in the certification and labeling, so that you have, especially for more high risk situation, a third party that's coming by, and that's ensuring that's looking at the things and looking if the work has been done in the right way.
Mm-hmm. Yes, great point. Thanks, Peter. So, Mark, I saw you raising your hands just before. Am I right? You wanted to speak?
Yeah, I okay. In my very short presentation, I omitted this piece of norm. This is It's the norm 1946-4 in Germany. It's dealing with special norms for in the healthcare sector. And actually, I found it a few days ago. But I'm also a person who got COVID in a famous German hospital in the dental section. And actually, they opened one window. At that time, I was completely ignorant. I thought, open one window is okay, but you need cross ventilation at least. And I now read in the document that they should have had a VEC system, ventilation air conditioning system. That was definitely not in place because I asked them for their clean air procedures. And they said we opened the window. So that is one example of non-application of norms. And I don't have an answer why this is happening, but I can tell you it is happening.
And that's why exactly it's important to continue to push for at least what's there is applied.
Yes.
And even pushing for new things. That's a good example. Thanks for that.
And most probably, if there's no the plaintiff, no one really complaining because no one knows. I mean, this is not my area. I've not been working in this area for ages. I'm coming up to speed now. But if patients don't know, and if there is no real supervision from the regulator, they do what they want, and it's always money, I guess. It's
coming back
costly
often coming back to money, Mark. Definitely.
Exactly. It's costly to implement all the norms. So as long as you can get away without implementation, you most probably will try to. Anyway, that was a real life example.
Definitely pertinent, relevant. Johnny Shaw, I saw you appearing, so you might want to add something.
Oh, I was just going to add, especially when we're speaking about things that are people worn, we really have to consider the human factors, the training, the knowledge, the skills and ability, because many forms of PPE just aren't intuitive. If you've ever seen.
Whoops, you are cutting, Johnny Shaw.
If you've ever, seen the sterile technique for removing gloves. Oh, no. I was going to say a lot of the PPE just isn't intuitive. So training is also critically important for people to understand what they're being protected from and how to properly use their PPE.
Important that people are aware of what and how they should do the things. They're the most important part in this equation. So they need to be able to use it in a proper way. Okay, thanks, Janisha. We've heard well, even if we've lost the camera at some point. But okay, thanks. Any other one wants to jump in on that for that question? Okay, so let's go to another question. The other question was more touching the government itself. So how do we get government, whether it's just on the representative part or whether it's on the funding part from the government, to have their resources to implement solutions? So the question was more focused on monitoring solutions, but I would extend it to all the things we've just discussed. So the standards and also the legislation. So how do we get government to push? We've heard from Kathleen and Ryan how the community can rise up and ask for the legislators to move on some motion. So you can add to that, or we can also talk about other ways. So that's just to see how we work on the government side, so to influence and make sure that the representative, but also the money, as Mark just referred to, the funding is put in the proper places.
Stefan, can I just?
Yes, go ahead, Anne.
I was just going to chime in here briefly that at this point in the pandemic, it no longer seems all that rational. the way governments are allocating resources. And like the idea that it would be logical and scientific and all of that, it just doesn't seem to be happening. Like if you look at the current HICPAC, which is the Hospital Infection Committee for healthcare workers, like the prevention, they're looking at weakening the standards in the United States. That decision is coming up like next week. And so I really think at this point, at least in the US, and I admire some of these other governments that have nationalized health systems who seem to care more about what happens to people. But we really need to speak in a loud voice, as many people as possible getting together on this issue and really advocating. Like if I knew who gave money to NIOSH, I would be like in their mailbox on the telephone, calling them all the time to get more resources to them. And I really think that if you haven't already signed an existing petition to influence the HICPAC committee as part of the CDC, I really highly recommend it, because this is going to set standards for infection prevention in all settings of care in the United States: home-based care, ambulatory clinic-based care, nursing home care, hospital care, and to give employers more flexibility. Thank you so much. Like, I'm sorry, like as a healthcare provider, your first job is providing healthcare. The money part of it has to be a secondary thing, and a respirator doesn't cost that much. So I don't understand it. So that's my soapbox. I really highly recommend we all speak together in a really loud voice and support requests to government.
Definitely a good point. And the ICPAC question is also very current. That's a good time to touch on that point. Thanks, Anne, for the comment. Another one, anybody just raise your hand in any ways. I'll figure it out. So, or just talk. Okay.
Kathleen, I can add a little bit from New Brunswick.
Kathleen, you can go ahead.
Sure, thanks. And here, like I really good mini speech there. I'm amazed listening into that HICPAC meeting last month, what you guys can do in the States. I'm not aware of there being any opportunity like that in Canada for us to give that direct feedback. So I do encourage people to submit their written submissions. The deadline to give oral comment at HICPAC was last night to sign up, but you can still do a written submission. In New Brunswick, which I realize we're tiny, we just were so fortunate to have an opposition party leader who, for some reason, was open to hearing about air quality. And I know that not everybody is fortunate like that your opposition party, I mean, obviously your governing parties aren't interested, or else they'd be doing it already. And so we really need to get this across to the opposition parties and public interest groups, the kinds of people who are already advocating for things like equity and justice. This is a disability justice issue. This is a social justice issue. This is an employment rights issue. And so I think that one strategy is to find these groups who are already moving and speaking, and to just get clean air on their radar. In New Brunswick, we're super fortunate that our opposition party was really interested and open. And so I don't know exactly all of the factors that led to that. It sort of probably helps that we're so small and people really do know each other. And a lot of people are like even related to each other. And so you can get these inroads. But yeah, we do have to work together and find the people who are speaking up and just connect and grow these islands of advocacy and really making that noise, because some of those windows are closing. Like you say, Anne, if the protection is rolled back in the States, then where do we even go from there? So getting those opposition politicians on board and just showing up at these AGMs and you have a voice, and submit your questions, get them on the record, because this is really important. The stakes are high, it's urgent, and it's important.
Absolutely great point. It will be the last words for the for the session. Kathleen, you wrapped this up really well. So thanks for that. Thank you all panelists. It was awesome hearing from you, as I said earlier, from so many diverse perspectives, but all in the same direction. We need to improve air quality to help people that struggle with the disease, the COVID, and even beyond. All the others, airborne disease that are also affected. And Mark gave an example with asthma earlier. So, okay, we'll switch to the next session. The next session is science and engineering. Indeed, we'll talk about the same big topic of COVID-19 and a disease which is airborne. We all understand that the general principle that it spreads through the air, especially in indoor settings where people are in close contact and so forth. So that is why we need to take measure. That is why we need to work to have better standards and all those things we just talked about. But now we'll go a bit further into what is, sorry, on top of the importance of working to improve the context of why on the scientific side, why on the engineering side, it is important and what we can do to improve it. So to understand the scientific principles, the engineering solutions that can help improve indoor air quality, that can protect the measure to protect yourself, to protect your colleagues, your relatives against airborne diseases. And this panel will provide an overview from different perspectives still, but from the lens of science and engineering. So our first speaker for this session is Jose Jimenez. And he will give us an overview, a first overview of the airborne transmission, but more specifically, how it works, why it was misunderstood, and how do we fight it. So Jose is both a chemist and an engineer. So he already has two lenses from which you can look at it. And he's a distinguished professor from the Institute and a fellow of CIRES, so the Cooperative Institute for Research in Environmental Science at the University of Colorado in Boulder. He contributed to the establishment of the Aerodyne aerosol mass spectrometer, so an important instrument for real-time analysis of aerosol size composition. So he definitely knows a lot on aerosols. During the COVID-19 pandemic, he was involved on multiple occasions to educate the public about airborne coronavirus transmission and combat misinformation as well. Another key problem we needed to deal with, and still now. And he authored many scientific papers. I'll not go down on all those things he was publishing. He's in the top 10 cited scientists on aerosol in Google Scholar, just so you know. So Jose, I welcome you to speak about this very creature, which is the aerosol transmission. Welcome, Jose.
Thank you. And just to say that I have really enjoyed seeing my screen, I hope.
We see your screen and we hear you well. Great. Okay. You can go ahead.
I've really enjoyed the meeting so far. And in fact, it's good that I was listening because I was confused about the time. So, but thankfully I am prepared. Let's see. Okay. So you see my screen there. Okay. Yeah, so I'm going to say a few things very briefly. If people want more details, I have posted these slides and many more at this link, jljcolorado.substack.com. And there is also a recording there from a recent talk about air cleaners, and you can find a lot more information there. Okay. So what's airborne transmission? I think most people know, but let's review it. This person is infected, so the virus is on their saliva and respiratory fluid, and somehow that virus needs to enter the physical world and get to the mucoses or the eyes of this susceptible person. That can happen through a surface, when they both touch the same surface, and then this person touches their eye, something like that. At the beginning, they told us this was dominant. Now we know is negligible. Then the one that was really the favorite of WHO were these droplets or drops. And these are projectiles. These are balls of saliva that they can be seen with the right light, and they travel through the air very quickly, and they hit this person inside the eyes, inside the nostrils, or inside the mouth. And this is what they told us was dominant. And then together with those large projectiles, there are many more of these smaller ones that float in the air like smoke. They have too little inertia to be a projectile, so they float in the air, and they infect when we inhale them. This is airborne transmission. Now, at the beginning of the pandemic, and you can still see this video from WHO, and there are many public health organizations that keep saying that this is a dominant form of transmission. But they had this video in which the projectiles left this person, they impacted this person, and that's how infection happened. And partially they were trying to explain an empirical observation for COVID or the other diseases that if you increase the distance, you reduce transmission. And their interpretation is that happens because later in the video, the droplets, the projectiles leave this person, they follow a parabolic trajectory and they land here. And this person is saved by gravity, right? So distance works, but distance works because of gravity. Now, this is the key scientifically of the whole thing. This is a bunch of doctors and public health people who don't study physics, making a mistake on physics 100 years ago and repeating it for 100 years. Because the reason why distance, which is known for centuries, works to reduce airborne transmission is not gravity, it's dilution. Basically, if this person is exhaling an invisible smoke, in this situation, this person is going to inhale a lot more, in this case, a lot less, right? So now, some other nonsensical thing that WHO was saying is like when there is transmission, and when I say WHO, I mean lots of public health organizations, when it happens in close proximity, those are the droplets. That we know because it's in close proximity, and that's a synonym of droplets. Now, there can be airborne transmission, but that's only when you are far, when you are sharing a room. This makes no sense. You know, how are these aerosols going to get there? The real picture is this one. The aerosols are most concentrated in the exhalation of the infected person. And we have two types of airborne transmission, transmission in close proximity, sometimes people call it short range, and transmission in a shared room. Now, we wrote a paper, this was in 2021, led by Trish Greenhalgh and with a bunch of other colleagues, summarizing all the evidence, you know, from super spreading events and lots of other evidence that was already very clear about airborne transmission. And already then we said, you know, maybe there are other routes, but we think airborne is dominant. And I think since then, it's much clearer that airborne is the only important form of transmission of COVID. Now, you know, we encountered a lot of resistance, as many of you know. So why did we encounter so much resistance? I think, I think as many people know, a lot of has to do with politics and economics and whatever, but there was a historical reason that we explore on this paper, and that I briefly describe with this diagram. This is the thinking as a function of history of how many of these epidemic diseases, when a lot of people get, you know, tuberculosis or cholera or malaria, how many of those are going through the air. And historically, since Hippocrates, since the Greeks, it was thought that most of them were going through the air. This was the miasma theory and its variants. And really that was the dominant theory until 1850, when John Snow shows, no, cholera is really the water. And Ignaz Semmelweis shows that puerperal fever is really through the hands. And malaria was thought to be bad air, is shown to go through mosquitoes. So then there is a period of debate around 1900, you know, are there diseases that really go through the air? And then Charles Chapin is an American epidemiologist, and he says this airborne thing, this was a superstition. This really is not true. And you know, extraordinary claims need extraordinary evidence. And really, there is nothing that goes through the air. And the CDC is founded on this premise. The founder of the CDC, we explain in the article, basically said Chapin is the best. And they really thought that no important disease was airborne. So I think that the period since then we qualified as resistance to airborne, you know. So it's only admitted if you really cannot deny it. And that's what happened with tuberculosis and later with measles and chickenpox. It just became so clear that it couldn't be denied. And that's what's happening with COVID-19, but we face again an extraordinary resistance. When you will not find papers like the one I showed you before saying this is the evidence in favor of droplets or in favor of surfaces, because there isn't any. Large droplet transmission has never been demonstrated for any disease, not just for COVID, for any disease. Yet WHO told us immediately that they knew it. Okay, so I'm going to say one more thing very quickly, which was about air cleaners. And we've been studying recently the health impacts of air cleaners. And there are many types of air cleaners that, as people were discussing, you know, sometimes we don't know as consumers what do they do. They all seem to disinfect the air. However, only some of them also reduce air pollution. So these remove viruses, but what about removing particles that are also a big killer, as was discussed earlier? Only a few types, and many types actually increase pollution, and in increasing pollution, they can kill people. So what we've been exploring recently is, well, if we are in a situation like December 2022, where there was a lot of COVID, do they help more than they hurt? And so we're going to show it in this diagram. So this is whether they help or they hurt. So the ones that are to the right of 0, they save more people than they kill. And the ones to the left, they actually kill more people through the pollution than they save from the disinfection. And this is the cost. Okay. So I don't have time. There is more details in the presentation to explain how we got to this. So what we recommend is always filters and activated carbon. Those always have a very positive impact. They're not very expensive. We think these ones are the ugly ionizers or hydroxyl or ozone generators or photocatalytic oxidation. My take is those should be avoided. Now we have these ionizers or bipolar ionizers. They are very expensive and it's not clear that they work. And then we have finally germicidal ultraviolet and electrostatic precipitators, which they do generate pollution, and that pollution is going to kill some people, right? So that gives us pause. We shouldn't put UV everywhere, for example, but we can put it in some places when it has an overwhelming benefit. Okay, so I'll leave it there. Thanks. I'm sorry if I went over.
That was a great presentation, Jose. Great, as usual, by the way, but a great summary of the key things, including the why we were stuck with so weird situation at the beginning of the pandemic and at last still. Okay, our next speaker is Crystal Pollitt. She's from Yale University. She has a PhD and she's an engineer as well, an associate professor of epidemiology, environmental health, more specifically, and she's working at the Yale Institute for Global Health. Her research explores the human exposome through characterization of environment and biological sample using analytical and mass spectrometry and techniques and so many others. So today, she will talk about the development and application related to the passive air sampler to assess personal exposure, especially in the SARS-CoV-2 principle. So I welcome you, Crystal. Just pleased to have you with us today.
Can't find her in the participants tab.
Oh, she's probably has issues and left. Sorry. You're right. So, okay, so we'll just change a bit the order. So our next speaker, and we'll figure out how to get Crystal back into the discussions with us. The next speaker would so be Lisa Brosseau, another great person which did so much during the pandemic. So especially to protect workers, one of the things she's doing really well. She's a research consultant at the University of Minnesota, Center for Infectious Disease Research and Policy. So Dr. Brosseau is a certified industrial hygienist. So we'll have another perspective, not coming from the engineering world, but the hygienist, occupational health world, who worked for more than 30 years as an academic researcher at the University of Minnesota, but also at the University of Illinois in Chicago. Her research expertise is in the area of respiratory protection, hazardous and infectious aerosols, so which is right in the core of our discussions today. She will be talking about control banding, and I will lose my voice if it's continuing, as a method for identifying the level of risk and selecting appropriate controls. Welcome, Lisa.
Thank you, Stefan. Can you see my slides?
Yes, we see well your slide.
Okay. Well, I'm actually not talking about control banding. I'm sorry to tell you that, but it'll be somewhat it'll be somewhat embedded in this. I have published on control banding and talked about control banding in other settings. So if people are interested in that topic, they are welcome to email me, and I'm glad to share my publications and presentations on that. What I am going to talk about is something that's often what I think is really important, but it seems to have often been ignored in the discussion of exposure and thinking about people and thinking about your risk. And I think it's really key for all of us to try to get this concept across, because it informs everything you do in terms of thinking about your risk, as well as deciding how to protect yourself in whatever setting, home, restaurant, exercise facility, work, etc. And this concept is pretty straightforward, and it applies to the exposure in terms of any hazardous contaminant in the air. It's basically that your exposure or your risk is a function of two variables: concentration and time. And I've used these, actually I developed these figures well before the pandemic. And I published them first in a commentary on the CIDRAP website, and then eventually they are in at least one paper. But the purpose was to show people, what happens over time. And the other figures that you've seen from other scientists and engineers are similar, but what this is showing is sort of the time feature that is often neglected when we talk about, but everyone understands that there is a concentration feature to this, but it's the time piece that seems to be not shown. And in the first figure, and this is just showing, excuse me, a cough or a sneeze. So a single emission of particles. But if you think about this as ongoing in terms of talking, then it continues. Over time, you continue to produce lots of particles, mostly smaller ones when you're talking. Over time, and assuming no ventilation in this case, the larger particles are going to evaporate and settle onto surfaces, and the smaller ones are going to disperse throughout the space. So this person nearby in the beginning might experience some droplet propulsion. You have to be very close and facing somebody for that to be even likely. More likely, though, is that you will inhale those particles. With time, standing close by, yes, the concentration is higher, but as you can see, as time goes on, particles disperse. They disperse through diffusion, and if there is ventilation, they can disperse by air current, by the movement of air in the space. Since people generate lots of mostly smaller particles during breathing and talking, so this concentration is going to continue to increase over time. And this, Dr. Jimenez mentioned, they're small particles that take a long time to settle onto surfaces. And it's minutes, many minutes to hours. So even if a source leaves, somebody infected leaves the room, having spent time there, those particles can remain for a considerable amount of time. You notice that I will talk about aerosol transmission, and I want to just highlight why I say aerosol transmission. The word airborne has a very specific meaning to the hospital infection control and prevention folks. They think of things in two buckets, droplet and airborne. And airborne has this definition, and always has had this definition, that it means inhalation, but only in very long distances away. When we take that word and use it to describe what we mean, which is inhalation anywhere, we aren't really getting our message across. So I'm trying very hard to avoid the use of either droplet or airborne when I talk about transmission. And I focus on aerosols, which is really what they are. Any particles suspended in air or in a gaseous medium is an aerosol. And what's encompassed in this is primarily inhalation. As Stefan noted, I am going to talk, at least one of us will talk about the hierarchy of controls and industrial hygienist. That is one of our areas of focus areas. I've found it useful to talk about the hierarchy in a somewhat different way than typically it is presented, which is from the context of infectious disease, there are sources, people generally. Pathway, then the source is the thing that generates the particles, the infectious particles. There is a pathway or a travel, the particles travel through the air and reach the receptor. So where we are trying to intervene is in three places: at the source, at the pathway point, or at the receptor. And the best and most effective place to intervene is at the source. And what I'm again trying to emphasize is there are ways to think about the exposure and intervening at the source in the context of concentration as well as time. If you eliminate sources, meaning say you test ahead of time and people are positive and you say, nope, you can't be here, that by extension ensures that you decrease the concentration. If you basically tell people they can only be in a space for a short period of time, not knowing whether they're infectious or not, you've minimized the amount of time that there can be exposure as well as that there can be emission. Pathway controls are generally ventilation, which is mostly what this expo is talking about. And I've listed a few things which all have been mentioned. You can increase the building ventilation and clean the recirculated air. You can use local exhaust ventilation to collect particles, and you can prevent air movement from source to receptors, which nobody really has talked about here. But this is the purpose of like an airborne isolation room at a hospital, is to prevent air movement from a room where there's an infectious person to the rest of the hospital. And the issue is the lower the airflow means the longer time it takes for particles to actually remove themselves or be removed from a space. Receptor controls are basically personal protective equipment, and I focus largely on respirators because I know how well they work and I know how well other things don't work. But you can think of them as both in the context of concentration as well as time. And of course, the hierarchy says, and control banding would point in this direction as well, do the source and pathway controls first, and receptor controls only come after you've implemented as many of the source and pathway controls. I'm not going to spend a lot of time on this, but we don't really know what the infectious dose of SARS-CoV-2 is, but I will tell you it has to be low. And that would explain absolutely, in addition to the fact that there's aerosol transmission and inhalation, that it doesn't take very many viruses or virions for somebody to be infected. So we know a little bit about this from one hamster study, which suggested a very low dose of 5 virions by aerosol, and a human exposure study, which was done in England by nasal instillation, which suggested an 50% infectious dose of 10 virions. Again, these are very, very low infectious doses. An individual particle that somebody generates, through talking, breathing, whatever, will contain multiple virions. So it doesn't take very many of those particles. I'm not going to go through this in any detail. You can look at it later. And I thank Dr. Raymond Tellier from McGill University for helping me with this list. But there are many aerosol transmissible pathogens, and these are not just issues in healthcare, they are issues in workplaces and many other settings, schools, etc. And there's a long list of human-to-human transmission ones. So, and some of them are common, like human influenza A. And lastly, I just want to talk briefly about my favorite topic, which is respirators versus masks. This is a very good study by Bill Lindsley at NIOSH, where he did a nice comparison of how much inward and outward leakage do you get for different kinds of things you put on your face. And the respirators, the lower the number in terms of leakage, inward or outward, the better. So respirators, as you can see, are very low, have very little outward or inward leakage and very good filter efficiency. On the other hand, as you move down the list towards the face coverings, especially the cloth masks, you start to see how much leakage there really is inward and outward in terms of and that has to do with both their very poor filter efficiency as well as generally their poor fit. And it doesn't matter how well something fits if it has bad filter efficiency. And maybe some of you have seen this, but I wanted to emphasize this or explain this table. And this table is really a time table. It isn't a concentration table. And a lot of people sort of, assumed that what I was talking about was both of those, that I'm somehow suggesting that this is like a risk assessment or a dose response model or something. It's not any of those things. What I was simply trying to do was demonstrate the difference in amount of time it would take you to get an infectious dose if you start with the assumption of a 15-minute period of time, which is what CDC used for its contact tracing period. Anybody who had more than 15 minutes was assumed to have been exposed. Anybody less was not. Well, there's no science, of course, that underlies that assumption. That was made for, feasibility and efficacy. But it was a good starting point because it helped me illustrate what happens if the source is wearing something, the receiver is wearing something, or both are wearing something. And what you note is as you move from a cloth mask, a surgical mask, to a fit-tested filtering face piece respirator or a non-fit tested filtering face piece respirator, you move from minutes to hours. But you also need to consider the fact that the source and the receptor have to be wearing something for it to really make a big difference. So if you're wearing, for example, as a receiver, a non-fit tested respirator, which many of us did, those of us who understood about aerosol transmission, and everyone else around you is wearing nothing, you really don't, you only get about an hour. So you still can't spend a huge amount of time. And that isn't enough time in a workplace by any means, which is why both people need to be wearing something good. And the worker in particular needs to be wearing a fit tested filtering face piece respirator. So that's the end of what I want to say. I just wanted to really emphasize that it's important. Sorry, I'm going to stop sharing. That we think about both particle concentration and time when you're in a space, and that you think about your intervention, whatever interventions you're using, and how they impact both of those features. Whether you spend less time and think about your the likely concentration, the number of people, the number of sources, the activities they're doing, all of those things play a role in your exposure and your risk. Thank you.
Thank you very much, Lisa. It was a great presentation and your topic was absolutely awesome. And your way to explain the hierarchy of control, I like the different approach behind the way you explain it. So we'll come back to Crystal Pollitt now. So I've presented you already, but I just take a few seconds just to recall that you're from Yale University, the Institute for Global Health, and you will be talking about wearable passive sampler for SARS-CoV-2 more specifically. So welcome, Crystal. Please, you're here with us today.
Well, thank you so much. And I really appreciate being able to follow Lisa and as she talks about understanding what exposures are. And that's what I'd like to present today on some of the work that I've been doing in order to develop new tools that we're able to better understand what our exposures are, especially to respiratory viruses, including SARS-CoV-2. So being able to track infections using virus surveillance has really allowed us to go beyond just recognizing where infections are, but understanding just how it tracks across a larger scale and also understanding the risk of different environments. And being able to monitor what our exposures are within the air, given that we have this airborne virus, presents some challenges in how we're able to do that just because of the levels in which we are trying to assess and the challenges with being able to quantify incredibly low levels. So this means that we can't use conventional technologies that require hundreds to thousands of different copies. And so we're left looking with other solutions that will have increased sensitivity. Different methods in which you could evaluate exposures in different settings have really relied on use of surface swabs or use of different active aerosol samplers. So there are challenges with both. If we rely on being able to look at just surfaces and deposition, we might just be missing different points in which we are exposed. Use of active aerosol samplers limits us to only looking at areas in which we spend some of our time. And if we think at occupational exposures or even environmental exposures, we move place to place. We can't limit ourselves to one environment. In addition to all the other caveats with area samplers and active samplers that draw air using a pump through a filter, they're loud, they're expensive, and they certainly cannot be worn. So in order to overcome a lot of these issues, my work's focused on being able to look at wearable technologies. And I have a little guest here who in the course of the pandemic has also learned a lot about exposures. So we've developed a wearable technology that we've called the Fresh Air Clip that passively collects respiratory virus onto a silicone surface and doesn't use any electronics to be able to do so. So this has now allowed us to personalize air monitoring that we can look at early warning signs for transmission risk using this technology. To support a lot of this work, we originally started by deploying some of these surfaces across COVID's infection positive wards within hospitals in the early phase of the pandemic. And we hung samplers over top of where patients were lying within their beds, shown over here in the figure here in this blue box here. And we also put a little picture frame with a passive sampler, so just a silicone film on their bed table. And with both of these samplers in every room that we went to, we were able to then pick up this COVID's or the SARS-CoV-2 laden virus or droplets. So this really then set the precedence to say that we could now have a wearable type of device that used the same type of diffusion-based passive sampling. So with this, we took a polymer film and were able to then have a passive uptake of virus-laden aerosols. And by doing that hospital-based sampling, we're able to demonstrate that passive sampling could effectively uptake these airborne viruses. We were then able to demonstrate that we could effectively extract the deposited virus off these surfaces with consistency within our recoveries, and also have good sensitivity in terms of the number of RNA copies that we could detect per clip using a digital droplet PCR technique. And then to be able to make a conversion between what was collected on a sampler to what actually the exposure was, we were able to then measure what the uptake rate of aerosol was onto a passive sampler. And so this involved being able to have a steady state environment where we could inject a known concentration of similar size particles as we would assume that particles associated with the virus would be, and then allow for sampling over extended durations. And looking at that rate of uptake of those virus-laden aerosols onto this surface, we could then use that to then estimate what the number of RNA copies that someone was exposed to in a 1 cubic meter volume, and then express that concentration in RNA copies per cubic meter. And once we're able to have this technology from measurement to exposure estimates, we then deployed those in a range of different environments to be able to use this as an exposure assessment tool. We were able to use it, and we have now expanded the use beyond the study that I'll show you right now, is deploying it over the course of about a 6-month period in the Connecticut area with healthcare workers, but then also other environments that people would frequent and wouldn't have PPE on, including restaurants. We looked at different homeless shelters, as well as just general community members going about their daily routine. And we were able to then look at what the exposures were in each one of these facilities or areas. Overall, we detected an 8% detection of SARS-CoV-2 using these wearables for these different settings. And we're able to then find airborne levels of SARS-CoV-2 in these different areas that range from 4 to over 100 RNA copies per cubic meter. Most frequently, we found that the virus was detected for restaurant workers, but we certainly also found it for other areas as well. And that's shown over here in this violin plot, looking at these concentrations on a log scale here. And the levels that we were seeing in the bottom were shown in relation to other reported levels. So what's next with this research? So we're now looking to see how exposure of respiratory virus that we are exposed to, that we are potentially inhaling, and then relates to the detection of COVID infection. So we're pairing all of these wearables with collection of saliva and being able to then measure what the relationship is between exposure and then conversion into infection. So we're excited to be looking at this in a number of different daycare settings in the New Haven area. And then further, this work has really then presented other opportunities to be able to look at other respiratory viruses. And we're doing that with a full panel of other common respiratory viruses in addition to SARS-CoV-2. And then further pairing that with chemical exposures that we know that can potentially increase sensitivity to infection as well as severity. So with that, I'll stop there and just thank the wonderful people that I've been able to work with on this project, and then also leave you with this paper here that goes into more detail with this technology.
Great, thanks, Christelle, for this presentation of a concrete solution on which you're working with your team, your outstanding team. Thanks very much. Our next speaker is Ewan Eddy from the University of Dundee. Dr. Ewan Eddy is the head of Scientific Services Photobiology Unit at the Nine Wells Hospital and Medical School in Dundee, Scotland, indeed. So he will be talking about the future of far UVC, the challenges we still need to overcome, where far UVC will play a role in the years ahead, and alongside with other mitigation. So I welcome you, Ewan. Thanks for being here with us. So.
Thank you very much, Stefan. I hope you can see my slides okay.
I see this, we see it and we hear you well, so you can go ahead, that's all good.
That's great, thank you very much. Thank you very much to the organisers for this opportunity to share with you some messages about far UVC. Because it's a 5-minute period, I'm actually only going to give one sort of important take-home message on far UVC, and I'll do that after presenting 4 different pieces of evidence. If you would like to learn in a bit more detail about far UVC, if you just do an internet search, there's lots of great articles and research out there, and most of them are open access as well, which is fantastic. So we've got 5 minutes, 4 pieces of evidence, and 1 take-home message. So let's start with what is far UVC. Well, it's high energy ultraviolet C light that can inactivate pathogens, and when it is filtered to remove longer wavelengths, it doesn't penetrate very far in human tissue. And because of that, it doesn't cause any immediate adverse effects on the body. And to our knowledge, so far that we've found out, there's no long-term adverse effects either. Now, the most common source of far UVC at the moment is the krypton chloride excimer lamp, but there are lots of different people working on alternative sources like LEDs. So what's the first piece of evidence? The first piece of evidence is that far UVC is very effective. This is from data that we published in Scientific Reports last year. And in our room-sized chamber, so it's a 32-meter cubed chamber, where there was a constant production of an aerosolized pathogen, far UVC lowered that pathogen load by 92%. And that's when there were 5 lamps in the room operating at 10% of their maximum intensity. Now, that would be an equivalent to an electrical consumption of just about 6 watts. And with just that 6 watts of electrical consumption, we got a 92% lowering, which was equivalent to 35 air changes per hour. Just to emphasize that, that's 35 equivalent air changes per hour for just 6 watts of electrical consumption. Second piece of evidence is that far UVC gives much higher equivalent air changes than most other technologies. And in this example that you can see here, you can see these high equivalent air change values at different mechanical ventilation rates within the chamber. And these are the types of numbers that really you don't see with other technologies. Now, I have to emphasize and be absolutely clear, I am not saying that far UVC is better than everything else. It is definitely part of the package, but it does need to be a part of the package. The third piece of evidence really is that with far UV, short range inactivation is possible. It's not great. The situation does need to be optimized. So for example, in the image shown in the slide here, the lamp has to be directly between the 2 individuals. And in our studies in the chamber, we found that when our source and our collection were 2 meters apart, we got a 57% reduction when the lamp was on. So it is possible, but not necessarily the best. The fourth piece of evidence that I want to present really is that far UVC does produce ozone. There's no denying it, it's absolutely fundamental. But that ozone doesn't need to be an issue because the ozone produced, or the amount of ozone produced, depends on the amount of far UVC that's being used. So on the left-hand side of the slide here, you can see that in the chamber, when we had 5 lamps at their maximum intensity, yes, there was absolutely an increase in the amount of ozone that we measured. So if we had a mechanical ventilation of 1.5 air changes per hour, we saw 50 parts per billion above background. But if the lamps were just operating at 10% of their maximum intensity, which is the graph on the right here, then there was no detectable ozone measured at all. And remember, 5 lamps at 10% intensity was 35 equivalent air changes per hour. Which really brings me to my one take-home message from this presentation, which is that our evidence is showing that you get very high inactivation without the measurable secondary chemistry. Now, I know that not everybody agrees with me, but where we disagree is not actually on the ozone, but on the efficacy of the lamps, because our experiments are showing better inactivation than some of the smaller laboratory experiments which have been undertaken to date. Now, what gives me confidence in bringing this to you today is that the results from our chamber are now starting to be supported by experiments carried out in the real world as well. So just to reiterate, my take-home message from this is that far UVC can produce high inactivation without inducing any significant secondary chemistry. Thank you very much.
Great conclusion, everyone. Thanks. You have nailed it in 5 minutes. Impressive key messages have passed. Okay, our next speaker, and it will be the last before the panel. It's Alex Segenfeld. Alex Segenfeld received its PhD in physics, so in another viewpoint from the MIT, and is currently a postdoctoral researcher at the New England Complex System Institute. His research focuses on applying concepts and method for statistical physics to further understand social phenomenon, including instability and many other things, and spread of disease. Indeed, he will talk about airflow and filtration, a topic at the core of the discussions today. So welcome, Alex.
Thank you.
We see your slides, so all good. You can go ahead.
Thank you. This is a joint work with the other authors you can see on the slide. The work I'm going to be presenting is slightly different in flavor, but the essential question is, how does the location of air filters and the location of both sources and in the susceptible individuals affect the probability of transmission? And just to give some brief background here, if traditionally in the literature that tries to calculate things exactly as opposed to numerically, the one can make an assumption that the air in the room is well mixed. That is, that the concentration of viral particles at every single point in a room is equal. And if you assume that the air is well mixed, the problem of calculating the efficacy of ventilation or filtration is simple. It depends only on the clean air delivery rate. The clean air delivery rate is essentially how much volume of air is exchanged per unit time. So for instance, how many cubic feet of air are brought in per minute. And the larger the clean air delivery rate, the cleaner the air, if we assume that the sources of viral particles are the same. Now, just as a motivating question, we can ask, is it have one very efficient filter, like a HEPA filter, that filters almost all of the viral particles, or two less efficient filters, if we assume that all three filters have the same flow rate of air? And in this approximation, if you assume the air is well mixed, it's better to have two of the 75% filters, because the filtration efficiency, basically a 75% filter at a certain flow rate is equivalent to bringing in totally fresh air, just 75% the rate. So the situation, however, changes, or an important question to ask is what happens if the air in the room is not well mixed. And so these, what we show here are some simulations of air under various conditions. Here we have a single filter. You can see all of the flow lines. Here we have multiple filters. Here we have some open windows as well. And the point is that all three of these actually look similar in essence to this very simple picture where you just have these circular lines rotating around the room. In all cases, the shapes of the lines look different, but the essence is the same. You have air going through a circular path through the room and then through a filter, or in this case, through the outside air where it becomes clean. And so motivated by this, we can create a simple model here. We have a bunch of air flows going through the room. At one point, we have a source that's inputting viral particles into the streamlines, and then they travel through a filter. And we can ask, how does this compare to, as if this more detailed analysis, how does it compare to an analysis if we assume the room is well mixed? And I'll skip the math and just say the results, which are that between the source and the filter, i.e. downstream of the source, but upstream of the filter, you get essentially the same results that you would in the well-mixed room. But after the filter and before the source, i.e. if you're standing such that the filter is blowing the air towards you, the air is far cleaner, and how much cleaner it is actually depends not just on the total clean air delivery rate, but on the precise filtration efficiency. So a HEPA filter would mean that the air coming out of the filter is 99.9% or more cleaner than the well mixed case. And I'm about out of time here, so just to the conclusions are essentially that the concentration of viral particles are highly location dependent, and that overall, using this more detailed analysis of these streamlines can give significantly different results from the well-mixed predictions. In reality, real rooms are in between the well-mixed and the streamline case. There's certain assumptions that were made, for instance, no turbulence for this model. But this gives us essentially another simple benchmark and with which we can bound the efficacy of air filtration. Thank you.
Thank you very much, Alex. Great presentation. We'll switch to the panel discussion, the Q&A. I have a couple of specific questions for some of you. I will start with a question for you, Jose. It's related to, but if others want to jump in afterwards, there is absolutely no problem. It's a topic that touches many. So The question is, I read it like this. I see that there has been resistance to airborne for some time. So the point is, but what about since SARS-1 in 2003? So SARS-1 was accepted as airborne. Why are so many people willing to believe that SARS could change mode of transmission, even within the scientific or medical community? So what would be your point on that, Jose? And if others want to jump in, just let me know afterwards.
My understanding, and I wasn't researching airborne transmission at the time of SARS-1, but I've talked to many of the primary researchers that worked on that. And my understanding is that there was a lot of evidence that it was airborne, but this wasn't universally accepted. There was a resistance. It was in the frame of this very strong resistance. So many other infection control specialists said, no, it's not airborne. And there is an article from Dr. Sito from Hong Kong, who sits and is still one of the key experts in the WHO infection control panel. And he said, basically, the title of the article is something like, oh, SARS was not airborne. So I think it wasn't, I mean, you can find documents of WHO where they say it's airborne and then others they don't. So I think it ended up in a confusing situation, and it wasn't as large of a pandemic to attract attention for a sustained period of time like COVID. So I think this confusion persisted.
Yeah, it was contained a bit faster, so it never went as far as what we've seen. And you're right, there was some resistance, but it's really worse right now. So that was the point. I don't know if anybody else in the panel want to jump in. Thanks, Jose, for clarifying that. It's important.
Stefan, this is Lisa.
Lisa, go ahead. Yes, you can go ahead.
I think Jose is right, but there are some major differences where you had almost all the transmission was mostly in healthcare. I mean, a lot of the people infected by SARS-1 were healthcare workers. And a lot of those infections occurred as a result of being exposed during aerosol generating procedures, which is why you got suddenly a lot of attention on AGP. And because they weren't wearing respirators. So it's a very, very, while it's almost, I mean, there's so much similarity genetically and genomically, there's a significant difference in that it's most infectious. SARS-1 is most infectious only when you develop very severe symptoms. And otherwise it doesn't seem there to be much asymptomatic transmission, and it's not really transmitted early in the infection time period. That's completely different from SARS-2. And so I think the problem that we have is that most respiratory diseases do have, or many of them do have this aerosol transmission feature to them, but it's not well recognized, and it's not, it's not just not recognized, CDC, WHO, others actually purposefully say they're not airborne. And the reason I say they're not airborne is, as I said, it's not long-range transmission. Now, I don't know how you can rule out long-range transmission for something like a pandemic where we saw, transmission everywhere and anywhere. And I think they finally had a hard time with SARS-2 in arguing that there was not inhalation near the source, which is the thing they don't recognize. Droplet and airborne paradigm don't recognize inhalation near the source. But I'll tell you, I've been fighting the against the droplet airborne paradigm all of my career. And it didn't start with SARS. It started with influenza pandemic planning. Which is from the 90s. It started with a discussion about tuberculosis, actually, which occurred when we started to have HIV outbreaks, and healthcare workers and corrections facilities, employees were being infected. And that whole discussion about aerosols is something people don't want, especially medical professionals and infectious disease physicians and others don't want to talk about. And I don't entirely understand why, but they don't. I think it frightens them, to be honest.
Yes, and as what you pointed out a bit, so the transmission can be really, really fast if someone is not protected without mask anything. We're talking about sometimes seconds. It's no more long time, or the former 15 minutes to be contaminated that was there most of the previous. So things have changed, and it's like there was anyway. Still, and you're right, it came from before, but it looks like there was a kind of conjunction of so many things in that pandemic, in this one. Okay, thanks both Lisa and Jose for that. The second question is for Dr. Hidi. So Iwan, if far UVC is an issue because we would rather like to keep the bacteria on our skin, will there be a risk for losing skin bacteria? So this is the question for you, definitely. Go ahead, Iwan.
Yeah, thank you. So there haven't really been much in the way of studies done on the skin microbiome, but if we think about it from a practical perspective, first of all, the types of environments that we're talking about for deployment of far UVC are environments where you will generally be clothed. There won't be a lot of so much of your body won't be exposed to the far UVC, and therefore the microbiome will remain intact in those areas. The other thing is that the skin's not a smooth surface, and actually the microbiota lie within the crevices and the ridges and within those top layers of skin, and so will be more resistant. And the other thing is that our sort of skin microbiome is used to having insults on a daily basis, stress on a daily basis, be that through washing hands, through applying cosmetic products. So there haven't been any studies exactly to look at the microbiome, but for the same reason that far UVC works better in air than it does on surfaces, is because of that. On a surface, there are lots of places for the bacteria to hide, whereas in the air, that's not the case.
Thanks, that's clear enough. And we'll give a couple of minutes more before switching to the other session, but I would like to have your feedback from your expert standpoint. We were talking before about legislation and limitation in existing legislations, guidelines, standards. From your experts, whether you're hygienists, engineers, medical physicists or chemists, what is, from your standpoint, the limitation and what is lacking? And how they should be addressed from the technical standpoint. So we'd like to hear from you, not from the legal side or the advocacy side, but from the science side, what you see missing at the moment. Anyone can jump in as you wish.
I may. Go ahead.
No, go ahead.
I was just gonna, well, not necessarily from the science side, but my impression is that there are two reasons for resistance. One is that the people in charge are people from medicine that do not understand any of these means of control. I mean, to quote Lindsay Marr, they're very confused by them, and they're the ones who have the power at WHO, it's a medical organization. So, and they're very resistant to accept the input of engineers or scientists like us at the same level. I think that's one key issue. And the other issue is that for politicians or whatever, it's just very inconvenient. If you accept it, suddenly you are accepting a responsibility, and you are stuck with lots of places that have poor ventilation, and they really don't want to accept that. And so they equivocate. I mean, in some places they do better, like we heard in Belgium, but in general they try to not admit it clearly. And in a way, I would say we have an unholy alliance of the WHO types, whatever, that may be resisted for their own reasons, and the politicians that are very happy with that resistance because then they don't have to admit it.
They can just do nothing and they're fine. So, okay. Lisa, you wanted to add to this.
I'm going to add two things. One is to get new standards into impacting buildings, either current buildings or new buildings. You have to have those standards incorporated into the building code. And the building code is influenced by a number of different things, none of which have anything to do with us at this expo. So how do we influence the building codes, because because building codes are actually, they inspect against a building against the code, right? And if you're following the current that's incorporated into the building code, then that to improve ventilation. So ASHRAE and we need to partner with ASHRAE, but we also need to partner with whoever it is that changes the building code. And that's, unfortunately, it's usually sort of a low of, cities have building codes. It's not federal. The federal government doesn't have a building code. And so we are going to have to change this piecemeal until we reach some, enough places agree that look different in terms of this.
Good
Really
point. So starting at the lower level to make it lift up the chain somewhere in time. So great point.
Yeah. Unfortunately, we have to act local better impact.
Yeah. Thanks. Great comment. Addition. Another one. Any of the panelists wants to add on that front? Okay. So it's I can just ask for the last question, what if I'm curious of. What would be one or two initiatives, just one anyway, initiative that you would push? So any of you 5 or 6 that you would push right now, that's more urgent. Some we're talking about some things, others. I just want to see what is the most urgent things, or 1 or 2 things that you see as of now. Anyone can jump in, whether it's on the control, the monitoring, the prevention, specific solution, or more generally advocacy, a bit like what Lisa just said. So what is, it's not an easy question, not necessarily from the scientific side. We often, and I'm coming from that side as well, but in this pandemic, we see that action is key towards solution. So what would be something you see fit?
Maybe say something to that, Stefan.
Yes, go ahead.
Okay. I think from my perspective, it's the convincing of people that we need to clean the air. And then I think once that message has come across that there's a need for it, then the engineering solutions will fit in around that. We'll come up with the solutions that are most appropriate for the different scenarios that we find ourselves in. But I think at the moment, the general public is not convinced that we need to clean the air.
So education, kind of giving the information, making sure they get the proper information. There is so much misinformation, as was discussed earlier. Okay, good, great point, great urgent matter to deal with.
If I may piggyback on that.
Yes, go ahead, Jose.
I mean, I totally agree. My pet method of doing that is the having CO2 monitors publicly visible everywhere that we share the air, or at least in some places, as I think is done in Belgium, because I think it accomplishes, once you make it public and you put it there, people start asking questions and they start pulling from the thread, and then I think it's a more concrete way to get there. And I think it works because, if nothing else, all the resistance we encounter, all the building operators are terrified. I mean, in my kids' school, they yelled at me, "No CO2 monitors." And if it wasn't effective, there wouldn't be so much resistance. And one other thing, there are actually some recent scientific results that I didn't think I could mention in my talk, but I'll mention them now from the Bristol group, that actually CO2 enhances the survival of the virus. So it's not just that CO2 is an indicator of how much virus may be there because it's accumulated of exhale there, but the higher the CO2, the longer that virus stays infective. So actually, infection probability is going to depend maybe on CO2 squared. So it will be even more of a reason to do it.
Absolutely. So great point you're coming with, both of you. Okay, thanks very much. Unless there are someone else that want to add to it, I think we'll close it here. Outstanding exchange. All of you came with great practical solution, but also important things to discuss and to and up to helping the public understand and being part of the solution to resolve this, in which we are all stuck. Okay, so the next section is the exhibitors section. So the audience, everybody is invited to visit the virtual booth, and they are in the exhibitors section. So you need to go in the expo lobby. So they're coming back into the lobby. So you can see the exhibitors booth, and you can get into those and chat directly with the person's representative, or see the information they're sharing. So many of them come with great solutions and practical things. So there's a lot of other things you can learn directly discussing with the people at the heart of those different solutions coming from communities, coming from manufacturing companies, coming from the engineering world. So don't hesitate to get there. I don't know, Dominic, if you want to you want another thing to say. So the next session, just for you to know, will be at 6 p.m. The session, I'm meaning here, the speakers session, will be at 6 p.m. New York time. So just translate that into your various time zone. So 6 p.m. meaning in 53 minutes from now. So you have this 53 minutes, and we'll let the exhibitors booth event open even beyond the end of the sessions later on today. So you will have time to look at them, but that's the very best time right now. They have representatives on their site. So thanks very much. See you then.
Can I just make sure that everyone knows how to get to the exhibitor session? I'll just share my screen for a moment and go to it myself.
Go ahead. So just
if people can find it themselves, do that. But otherwise, I'll just demonstrate. If I'm sharing, it's here in the web portal of the Zoom, and you can click on the exhibitors tab up here. If that, hopefully, that's being shared properly. That should be how it comes in.
Thanks, Dominic. That was a great point to show directly what it is.
Hey, Dominic. I'm getting some reports from exhibitors that they're not really sure how to get into their booths. Given that some of them are probably still on here on this call, can you demonstrate that?
If they can DM me through the Zoom, that might be the easiest.
Okay, I will let them know.
An easy trick is when they're in when they enter into the Zoom room, they went through it through the lobby. Okay, so in the lobby, you see exactly what Dominic just presented on his screen a minute ago.
Yeah, I see that. I see the exhibitors tab. Their question is, if they're supposed to be live at the booth, how do they do that one extra step to, be live?
Okay, so that's the DM point Dominic referred to. So they just need to DM Dominic.
Or Dominic DM me and I'll.
I think that might be a question for Pat, to be honest. Pat, are you here?
Yeah.
I DM'd you, Pat, as well. Okay, it looks like Michael.
They should be able to get in, and because I invited all of them to edit, and they should be able to enter their booth.
So if they're able to edit, they should be able to enter?
They should be, yeah.
Was that in an email, prior email? They should check their inbox maybe.
Well, we did send them instructions on exhibitor instructions.
Another question aside from that is, Dominic, did you happen to prepare anything to show for our YouTube streamers? I wasn't sure if we were going to do that or not for the exhibitors, just to show who they are, or did you want to share screen or anything like that?
That'll have to come later, I think.
Okay.
Yeah, we have to dance for their entertainment for this entire hour.
Is this still streaming on there right now?
Yeah, we are still live, yes.
We are live. And we'll find a way to explain it. So they need to get into the what Patrick said is they have been invited, so they just need to come back to the invitation they received from Pat, and then re-click on it. They should be able to enter it and enter in their place, and people can get into looking at the chat. Just need to get back into the lobby in the exhibitors section.
For the benefit of the YouTube stream, I'll share my screen and browse through the exhibits myself, and that should stream to the YouTube.
Excellent.
Okay, so yeah, I see this screen.
I think these. Wait, still on audio. I think
If you
these
go
links.
to the lobby, if you go to the lobby and then to the Expo tab, I think that's where people are getting stuck. We'd expect to see all of the exhibitors in the Expo space, but we're not seeing that.
Okay, Michael says he sees an option called adding a representative.
Yeah, add a representative, and you should be able to add it on. I'm sorry, we're working this out. We're working this out.
Permissions, maybe.
Yes, we already have a few of the exhibitors which are already set with that representative in. So you can already go into the expo section and enter into a few of these spaces already. So it's just for the others to make the same thing. Right. The other exhibitors to make the same thing. So they need to enter as a representative.
Give me an email, then I should be able to add you as a representative. We'll get this fixed.
In the meantime, I really did like, Dominic, when you were going through the exhibitor tabs and sharing your screen, how you did for Clean Air Accelerator.
You want me to keep doing that while we're working this out?
Oh.
Is that the request?
Yeah, I was going to see if you could keep doing that.
I'll keep doing that live.
We could even chat about them while, while we're here.
Mm-hmm. How much we got here? I make this bigger.
Pat, I asked people to DM you with their emails or to send it by email to your usual email address.
Yeah, that's the way we're gonna do this. Yeah, that's the way we're gonna do this. You send us your emails and we'll add you as a representative.
Pat, I don't want to see what your DMs look like right now.
Yeah, I'm trying to fix this. I'm sorry, guys. Yeah.
I'll tell the air support people.
No, I need to integrate it in.
Patrick, I just want to know we appreciate everything that you do.
This is what I think of when I think of them visualizing the CO2. AirNet always, of course, pops into my mind for that.
The purpose of this is really to demonstrate that the products that we've been talking about exist, and people can get them right now. So we're hoping that people are taking the time before we come back to check out some of the companies that are working on these technologies and products, making them available to people, whether retail or household users, or whether they're school boards, or whatever building administrators, and understanding that these products and technologies are there. It is a solvable problem with the tools at hand. And because it's solvable, because this airborne transmission is something that we can solve, it's not a problem that people should shy away from. The way so one of the previous speakers was just describing, that health experts in the WHO, don't want to hear this conversation because they think it scares them, is the phrase. Having this expo section of the event, or this exhibitor section of the expo, is really about letting people explore the products that mean that it's not a conversation that we should be afraid of. And these ones are made by people in their own homes, right? Air filters that people just make themselves. It's not the kind of thing that the WHO said we should be afraid of.
Well, when we don't have a lot of, the building standards and the codes updated, we have to take things in our own hands. And a lot of people have done that and really come out and shown that. And with the science, people in the industries and people who are outside of it, who are following these, making the do-it-yourself purifiers, or people like Air Support Project, who want to commercialize, a fan and filter purifier, so that people who aren't comfortable doing do-it-yourself can. And they'll be talking later as well in the expo.
just Dominic, if you go now into the expo floor, you'll see that many more of the exhibitors are there. So why don't you go in there and you'll see that you can see more of the booths. So that part has advanced. And you can kind of walk around the exhibitor floor, and then there's the enter booths. And now the enter booths have their information more. And it's if you click, you walk between the areas.
This is fun.
Right, so we can come and talk with the exhibitors here, asking questions here.
Now, how do you tell if a booth has a person at it?
I think, oh, what's going on?
Pat, can you add me to the World Health Network so I can see what happens?
Should already be a representative. I have you listed there as that.
Oh, I'd love to check out World Health Network's booth.
Yeah, you're listed as a representative. You're at Nexi. Should I use a different WHN address or?
Okay, so this is where people can come in and.
Oh, so yeah, I can see.
Yeah,
right
so Yanir is in the
there.
booth. He's listed
Yeah,
there.
some booths are already working, so there are people coming in already. So it's
Okay,
just
good.
to let some time. It took just a bit time, so we might need to let it a bit available a bit longer, just to compensate a bit.
Can we see what's at the World Health Network booth? I know there's a lot of cool stuff there. I actually didn't
Yeah,
get the.
go for it.
Oh, I'm talking to Dom because I'm watching his screen.
Sorry.
But I could go in on my own, but I thought it was cool.
Not anymore.
Okay.
I think someone else's screen has taken over.
Someone stopped. I think he stopped screen sharing. Whoever was screen sharing.
Sorry, I can try again. I can screen share, but what I don't see is how do I chat with people? I'm in the booth and I'm listed as a representative, and presumably I'm allowed, but
Chats will
go
come
back
in
to
on the
chat
side.
with us button.
Yeah. Chats to the WHN will come in on the side. Or they should come in on the side.
like this.
Yeah.
Oh, cool. So, Yanir, do you have, is there details there in the booth? What is that details section? Since you're screen sharing.
So I can go to the details, and then here is a statement and links.
Very cool.
So you can go here and sign up. Or you can, I can go back over here and click on signing up for the welcome program, which is tomorrow at 4 p.m. Eastern time. So the structure of the booth is you can do the chat. And I can go back out, leave the booth if I want. And then I can go somewhere else. Enter booth. And then I can chat here. Hi, colon. And I can also scroll down and see the links or go there.
And so if I think I see Colin's little face in there too, down at the bottom. So that's how you tell who's else is there.
There he is, and he put it in the chat. Great. Okay.
That's very weird because, oh shit, sorry. I think all of them should be up and running.
It's working, Pat. Now it's for most of them, I'm sure. If there is exceptions, it's just for them to. I'm in the ARINET.
Yeah, bear with us.
Working
This
well.
is the first
I
time
went
we're using
into-
this software, so bear with us. There's some growing pains.
Yeah, well, I'm looking at the ARINET chat, and there are people chatting in there.
Good, good, good.
It's working.
Yeah. First time using the Zoom Expo floor, so bear with us.
It's a more recent feature that they added too for their Zoom. So they haven't had as much time to play with this. Sure.
And Vijay is in the ARINET booth, chatting with people.
The expo floor is moving like crazy slow for me. Just trying to drag it around.
I'm wondering about the booth for Ayaka.
Hey, Michael.
Hey there. I'm just bumbling around here. I clicked join and I realized I could join the actual thing that everybody's seeing. Is everybody else able to get into their booths?
I was able, if you can't, post your email to Pat and he will add you to the
Yeah,
booth.
and I'll add you.
Okay. I sent it via email, but do you want me to put it in the chat here?
Yeah, sure.
Sure thing. Let's see.
Are you having trouble finding it, or do you
I don't even see it when I go to the expo floor.
Huh.
I'm trying to navigate.
Oh, I know what's happening here. Just a second.
Okay.
All right. Huh. All right, there we go. You should be good now.
Okay. And then how do I like operate it?
Yeah, go to, you should be I know you have your current email as the one that was in use for the booth. So you should be able to enter as exhibitor or as here.
If you just go into the booth, you should see the chat to the right and you can type there.
Yes.
I don't think I'm seeing the booth. Let me double check here.
And try again. I'll leave this booth. Let's see. No, I still don't see his booth. I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 booths.
Same.
And then there's a chat with us button, and if you click on it,
If you go under the exhibitor tab, your tab's there, indoor air care advocates. And if you, instead of on the expo tab, you go to the exhibitor tab.
the question is, why doesn't it appear in the expo floor? Oh, wait. There are more up higher up.
Oh, really?
Yeah, you have to walk up high. There's a 3M, Dentech, Farmwood, and Make Human Technology. So the question is, so now I see 15 booths. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14 at least. Maybe I missed one, but I still don't see yours.
Same. Yeah, so I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15.
And you're the odd one out.
Think so.
Sorry about that.
It's no worry.
Unintentional, believe me.
You could
It
share.
is on the expo floor, right under Protect Our Providence, New Brunswick.
It's not there. I don't see anything under Protect Our Providence, New Brunswick.
Me neither.
Maybe I'll
How about,
I'll reset it. Now it's there.
yep, there
Do
you
a
go.
refresh. Do a refresh your screen, and it's there.
Yeah,
Sure thing. F5ing right now. There I am.
Yay.
Enter.
there you are.
Enter booth is available, but I don't know how you enter as an exhibitor.
Oh, you just click on chat with us.
Yeah,
It's there at the bottom is chat with us, and then you can chat with people that are there. I think that's what this is intended to do. I haven't seen any other capabilities.
Okay. Yeah, it says message indoor air care advocates. Actually it says who can see your messages as well. And it says the host's account has enabled archiving. Well, that's immaterial. So it just says message indoor air care advocates.
Yeah.
So I'm unsure if, I guess,
how do we get to video chat? Also, is it possible that having this video chat window open is conflicting with the expo booth ones? If does that also open the Zoom room?
I don't know. I haven't seen any button to click on to open the Zoom. I don't see where is the capability to do that.
I mean, I just see chat, and I guess that's just text chat.
In the meantime, that's all I've seen. It may be other things, but I haven't seen anything else. There is this icon at the top that seems like it should do something, but maybe it's supposed to do video, but there's no buttons. But I can say that we now have a lot of booths And we do have chatting.
Next year, this is going to go a lot smoother.
I do recall when I was researching this that there are different levels too for booths. And so if people are at like a platinum or it has different functions than other levels. And so maybe that's something that will.
Yeah, but I don't see it. I'm in the platinum level and it doesn't have any more capabilities. Not that I see anyway.
I'm going to hop out of this Zoom and just man the chat.
That sounds good.
Cool. All right.
Perfect.
Awesome. Thanks so much.
Thank you. Okay, so I figured it out. The way it works is if you go into the booth, to the right and left of the bottom there, it says not active probably. But if you click on that, you can create a Zoom that will stream to the booth. And that Zoom can then be joined by others who come into the booth. That's how it works. Is it clear?
I'm going to try it real quick. So you join the booth, you go down, you scroll down to the bottom of the booth.
Right. You go to the expo floor and you click on one of the booths, any one of the booths. And if you go down, you'll see that at the bottom, to the right and left of the central piece, there is there are these things that say not active. There's some icon there. I have to shrink a little bit. This space is inactive. Please come back later.
Yeah.
If you click on that, and you are presumably authorized, you can set up a Zoom window there. And that allows you to create a Zoom window that people can join. So I can't do that everywhere, but I can do it in the WHN, and I can share my screen.
Yes, it's the representative that can do that, and it opens a breakout room
So
essentially.
here I go start, continue to start session, and now I will allow, but then I will have to leave the meeting that I'm in, you see? But then I can join this, and it will create a Zoom room, and then people that come can join that Zoom by clicking on it.
That's great. So that's for the hosts. And I don't know if they can hear or see us doing this, but if you can, that's how that works.
It's still live from the lobby, Shay, so everybody which has access to the lobby can see it.
Great. Dominic and Stefan, I'm wondering, since we have Colin, who's going to be running the next section here, is in one of his booths right now. Do we want to do any checks to make sure that the speakers in his section are all hooked up to be able to speak, technically wise?
Sure, I can grab that, check that. We've got about 10 minutes before we get going again on the next session, so
it's almost there, Dom, so it could be a good time. I'll check as well, so I'll give a hint.
I'm the first presenter for the session. Can you see me and hear me?
Yes, Lydia, can hear.
We see you and hear you well, Lydia.
Very good.
Because I can see Barry as well, although he's not speaking yet.
Then we have Barry. Barry, do you want to come on and say hi so we can see if you're working right?
I can see Aaron and Joey as well.
Yeah, hopefully you can hear me okay.
I can hear Aaron.
Yep.
Aaron, perfect.
Oh, yeah.
Hey, Lydia. Hey, Barry. Hey, Aaron. Good to see you.
Oh, hello.
I have not heard Barry's mic, and I haven't heard Joey Fox. Is Joey here?
He's in the co-host, so it might just not be in front of the screen right now, but he's already set.
Okay.
Barry as well. So they both are in the, they might just be getting some coffee or a glass of water. So it's 10 minutes though.
I suppose we allow that.
Where are you calling physically, in Melbourne?
No, I'm in Brisbane.
Oh, you're in Brisbane. Why did I think that you're in Melbourne? I mean, maybe because I'm in Melbourne.
Thanks for squeezing in yet another meeting, Lydia. I know you've got a full day today.
Well, that's the problem at 10 o'clock, which is in exactly an hour after the starts a meeting with the treasurer of Victoria. So I managed to organize the room next to the treasurer's office, so this way I don't have to run from the hotel, which would be quite nerve-wracking.
One person's wondering if they want to see the booths in the lobby again. Do they just, and they're in this room right now with us, do they just hit leave and they would go back to the booths?
They only have to go to the lobby.
Which should just be a different
On the
window.
link, it's a different window. They can click on the link from the entry and go straight to there, and then click on the booth, click on the expo, and then they can go around and see the expo floor. And I think we need to, we missed the opportunity to let the exhibitors know that they can launch Zoom windows from their booth, but I think we will have to schedule that for a separate opportunity.
We did say we were going to leave the booths open from 9 p.m. Eastern time to 10 p.m. That's like after our last speakers. So if they are available, then we can definitely play around in those rooms and do that at that time.
We can announce it as available.
We should announce it, yes, just at the start. Maybe, Colin, do you want to announce it, or you would like someone else to, just before starting? That the exhibitors could stay also for 9 to 10 New York time. So you can convert that to Brisbane time, but it's just in a few hours from now. So in 3 hours, essentially.
Hi, Aaron.
Hi, Barry. I see you're back. So you're back in front of the video. So we were just wondering if you
I'm back.
grabbed a coffee or something earlier. So you're there.
Oh yeah. I just got home, Stefan. So
Just on time.
yeah.
How's the knee going, Barry? You on the mend?
Well, that's where I was. I was in the hospital today for a pre-surgical consult. I have my next operation. That'll be, lucky number 5 for this summer. Next week. So
yeah, that's 4 more than you'd ideally want to have, right?
yes, right. Yeah. So that'll be operation number 6 on that knee. I've had 3 in the other one, so that's my 9th. And I only have 2 knees. And I need at least 1 other operation on my other knee. So that'll be lucky 10. So there should be some kind of a prize. Once you get 10, like a free coffee or something, right?
Yeah.
Only I can't fix my left knee until the right one is completed now, because then I'd really be stuck. Anyway, it seems to have turned a corner. So
that's good to hear.
Headed the right direction again. And so we're just going to have a silence for 6 minutes, I guess, until we get started. Is that the idea?
I would chat away, but people say I talk too much. So I really try to hold myself back from talking too much, especially because I had extra coffee just a little while ago. I'm worried.
Right.
Go on, Shay. There must be a new genre of stand-up comedy that focuses on clean air jokes. Surely.
Stefan, I sent you something in the chat.
Hey,
I told
Colin,
you I was going to prepare jokes, but you told me not to. So,
right. Colin, you're really keeping Aaron and I on our toes, because I see our topics keep switching around and back and forth for the last couple of days here. So,
we figured that the two of you are subject matter experts. So whatever you say, it's going to be informative.
Well, we flipped a coin yesterday, and I think we're all good. So,
yeah.
Excellent.
I'm very pleased that this link works, because yesterday when I tried the first time, there was absolutely no way to get to the system, and there were a few panicking emails. First thing in the morning, I checked, it worked. So
well, I wasn't sure what the time zone was going to be. I had missed one key email there, Colin. So I'm glad it was Eastern time, 6 o'clock. And
got it.
Yeah.
Well, we know when we do this event again, maybe this time next year, it'll be 100% glitch free.
I feel like it's going pretty smoothly.
what's the scale of the whole event? Because I know what our session is, but I didn't have a chance to look what's the whole event like, how many participants, what it involves.
Yeah, Pat might know that. We had over 500. Well, the maximum Zoom registrations was 500, but then it's live streaming on YouTube.
Yeah, and overall we had 700 and I think 21 people register interest. At the very least, try to register.
Yeah, and it's live stream on the YouTube. It will restart in a few minutes, and the link will be available. Pat, do you know about when, or is it just after, or a bit?
Just after it's done.
Yeah. Okay. So
And
even if you,
right?
Yeah.
Oh, Sandy wants to know, can you unmute? We only have the speakers with the unmute ability. Is that right now? And participants can, if they write in the chat, we should be able to, all of the organizers will be able to see that chat. Okay, Sandy cannot enter.
Well, Aaron, I think we're getting your beautiful warm weather coming now. We're about 2 days behind you always. And tomorrow is looking really, really good.
Sorry, by here, you mean where?
So I'm in Ontario and Aaron's in Minnesota.
Okay.
And so the wind typically blows from the west, and we would typically get Aaron's weather a day or two later. So
Yeah.
Beautiful day on Sunday. It was telling me, oh, it's 70 degrees, and it's nice here. I think it was 19 today, so that's close to 70 Fahrenheit.
It is cold and rainy today, or it's 45 and rainy out there today. So come Thursday, put on a raincoat.
Okay.
Do we have a plan to ring everybody in from the booths and bring them back?
Yeah, I think we're just about on the hour, so I might give everyone 30 seconds and then we'll get the session underway.
I'm writing a message in the live chat just to, for them to come
Thanks,
back.
Stefan. Great. Hey, Joey, good to see you.
Hello, good to see you. Good to be here.
Okay, it's just gone the hour, so we might get underway. Thanks, Pat. I was about to remind you to press that button. You're ahead of the curve. Everyone, welcome back to this session where we're going to talk about future solutions for clean indoor air. My name's Colin Kinner. I'll be the moderator for this session. I'm a member of the organizing committee for the Clean Air Expo, and I'm also the program director for the Clean Air Accelerator, which is a not-for-profit startup accelerator that's going to be working with startups focused on clean air technologies and solutions to prevent the spread of airborne viruses. So a topic that we've already had some very informative talks on today, and we're going to have some more in the session just coming up. I'm really pleased to be able to introduce the next panel of speakers. They are Lydia Morawska, Barry Hunt, Aaron Collins, and Joey Fox. These folks will be familiar to many of you. Each of them is widely regarded as a global thought leader in their respective discipline area. So we're really fortunate to have them joining us today. Just as a short introduction to the topic we're going to be talking about, we need to think about why we're talking about the future of clean air. So this session is about forward-looking, what's going to happen in the years to come. And I think the pandemic has shown us that the world really needs to bring in a new paradigm of clean indoor air if we're going to reduce the impact of COVID and other airborne diseases. As a species, we learned many years ago that we need to wash our hands to avoid surface-borne diseases. We've learned not to drink contaminated water because we know that there are many waterborne diseases. And we know not to eat things like uncooked meat because we know about foodborne diseases. So the pandemic has shown us that we also need to think about the air we breathe and ensure that it's safe and not contaminated by pathogens so that we can avoid airborne diseases. Personally, I'm convinced that in the future, and hopefully the near future, it will be unthinkable for people to breathe air that's contaminated by pathogens. And breathing clean air will be considered an essential human right in the same way as we expect to drink clean and safe water. So the question for this discussion isn't whether this transition is going to happen, it's a question of how we're going to get there. So our next four speakers are well placed to help us answer that question. They're going to give us some insights into how we'll enter this new paradigm of clean and safe indoor air, what products, technologies, standards and regulations, as well as societal changes are going to be needed to get us there. So I'm asking Lydia Morawska to speak first. Lydia is a distinguished professor and an Australian laureate fellow in the School of Earth Sciences and Atmospheric Sciences at the Queensland University of Technology in Brisbane, Australia. She holds several positions in international air quality research groups and is an advisor on indoor air quality to the World Health Organization. Lydia has a background as a physicist, and she conducts fundamental and applied research in the field of air quality and its impact on human health and the environment. And she has a specific focus on airborne particulates. Lydia is going to be talking about the future of clean air and how it will be viewed in 10 years' time and what is driving this paradigm shift. So Lydia, over to you.
Many thanks, Colin. First question, can you see my screen and can you hear me?
Got it. Very well.
Right. Thanks for inviting me to give this presentation, and specifically on this topic, which is so close to my heart and to my actions. When we are talking about clean air, it's both clean outdoor air and indoor air. One doesn't exist without the other. So I'll be talking about both, starting with, with air quality in general. In 2021, WHO announced the next air quality guidelines. I was privileged to be a co-chair of this activity. Two important points. First of all, that the concentration levels recommended are much lower than before, really close to the background levels. And also, as it is stressed in the document, it applies to both indoor and outdoor air. So with this lowered concentration, really, we cannot go much lower. So basically, in 10 years' time, we won't have significantly different WHO guidelines. But then we can ask, all right, so what's the reality? And if we look at this table, these are the cleanest nations as compiled in that presentation, in that paper 5 years ago, 6 years ago now. Now, what you can see that all of them, the cleanest, are still above 5 micrograms per cubic meter, which is the annual PM2.5 concentration. So this is not that good, but the good news is that now, doing the analysis which we do, we can see that the trend is pointing down, which means concentrations are reducing, and this is due to the many control actions. But particulate matter is only one aspect of air quality. So what's the overall situation? Well, we can ask, what is the situation in relation to Sustainable Development Goals? Is there one for clean air? No, there's not one for clean air, but there's one for affordable and clean energy. Now, in relation to clean energy, we know very well what the situation is. The use of dirty energy, fossil fuels, is still increasing, and the contribution for clean energies is still very minor. And with this, of course, CO2 in the atmosphere is also increasing. And we know very well what it means. The last edition of the climate change intergovernmental panel for climate change showed it very clearly where we are going. Humanity has opened the gates to hell. This was the statement by the UN Secretary General Antonio Guterres just very recently. Well, the gates to hell. But we have a dream, and that dream was expressed a few years ago at the first WHO Global Conference on Air Pollution and Health in Geneva by Dr. Tedros, the Director General. Now, our dream is a world free of air pollution, reduction of the number of deaths from air pollution by 2/3 by 2030. Well, is it possible? How this can be achieved? Well, it's a very clear message, and we know what needs to be done. Air pollution must be terminated through the transition to clean energy. Now, you may ask why this word terminated. There are, of course, other terms used. The big terminator, Arnold Schwarzenegger, was part of this conference, and that was the wording adopted from this. So just closing this vision for in 10 years' time, at another conference, Antonio Guterres said this: Stone Age did not end because we ran out of stones. So really, in 10 years' time, I hope that will be much better progress in terms of clean outdoor air and clean energies. But there's, of course, clean air. There was a event, very important event at the end of March 2023 in Canberra, Clean Air Forum. Really, it was Clean Indoor Air Forum. I think we were a bit shy to state that indoor, and you can see the many people participated. This was really amazing. In our paper 2 years ago, we argued for a paradigm shift to combat indoor respiratory infections, and stressing the building ventilation systems must get much better. So building ventilation systems, but really, we are talking about much more than just ventilation system, just one aspect. All air risks indoors must be considered. And the picture is, of course, quite complex because it is a complex system. So we started from airborne infection mitigation of this. But there's also the outdoor air, and outdoor air penetrating indoors is a huge part of indoor air pollution. Anything we generate indoors, dampness and mold, for which we create perfect conditions sometimes, and making sure that thermal comfort is good. And this must be taken into account at the time of building design, HVAC system design through building operation, and taking into account energy conservation. Now, how this can happen? Without air quality standards, it would be very difficult to do it. For outdoor air, we have both emission standards and air quality standards. Over 200 air monitoring stations are across Australia. But for indoor air, we have only national construction codes, no performance standards. One could say in relation to outdoor air, since all sources in principle comply with emission standards, why do we measure air quality standards outdoors? Because without this, we don't really know what's happening. And really, indoors, we must do the same. At the end of last year, with colleagues, we've published this paper in the Medical Journal of Australia, Health Indoor Air is Our Fundamental Need, the time to act is now. This was an extended message from my article in the conversation a little bit earlier, and in my letter to the then Federal Minister for Health. It may sound like a call to arms, but really this paper was a blueprint for indoor air regulatory framework. So how to do it? It was part of the framework. We are working on the rest of the framework because indoor air standards will be very different to outdoor air standards in the ability to do the monitoring. So I was very pleased when during the recent parliamentary inquiry into long COVID, when I was asked to speak and after this report was generated, this part of this blueprint was included. Of course, it doesn't mean that it's going to happen immediately, but we are going there. So I'd say that the vision for indoor air quality for the future. Indoor air quality standards will prescribe concentrations of indoor air selected pollutants, parameters, ventilation is one of them, and be enforceable, which means monitored in every indoor public space. Ventilation as part of heating, ventilation, and air conditioning system will be an element in the enforcement of indoor air quality, and buildings will be designed to meet the standards. Well, the best way to shape the future is to predict the future is to create it. And this is what we are doing. Thank you very much.
Thank you, Lydia. Very informative, and I'm sure we would all agree that that we need to take some steps to create that future rather than allow it to creep up on us. Our second speaker in this session is Barry Hunt. Barry has for a long time driven the implementation of innovation in healthcare over the years by being a leader in the development of national standards in Canada at Canadian Standards Association, as well as global standards at the International Standards Association. Barry also provides leadership in the Canadian Healthcare Engineering Society, Infection Prevention and Control Canada, the International Ultraviolet Association, Coalition for Healthcare Acquired Infection Reduction, and most recently, the Canadian Association of PPE Manufacturers. Barry is going to be talking about the future of PPE and respirators, and that's going to hopefully touch on the design, the materials, effectiveness, costs, environmental impact, selection and standards, and much more. And all of that in 5 minutes. So we're really looking forward to your talk, Barry.
Well, great. Thanks very much, Colin. And and I'll be presenting it from a Canadian perspective too, because I am here in Canada. But most of the issues are the same all over the world. And so, of course, COVID's not over, and we have long COVID, but we have additional pandemics that are going to be coming. And when COVID first came out here, it had a 3% mortality rate. The next one could be 30%, 10 times worse. And if we look at susceptible populations like in healthcare, we have 10% mortality rates. So we already have very serious pandemics where we need very serious respiratory protection, even though it's largely ignored in a lot of areas. Our next pandemic could come from a lab leak, it could come from terrorism, and it could come from war. And then we have a new scourge, with climate change. We have wildfire smoke. So even though Lydia's slide showed Canada as #1 in air quality, it certainly was not in 2023, where we had 15 times more forest burn this year than our 10-year average. And so we apologize to our neighbors to the south and our neighbors to the east, who all had to breathe our smoke coming from our forests here in Canada. Sorry, Europe, and sorry, States, but not all our fault. And then, of course, we have issues where our respiratory protection is going to be subject to supply chain issues, especially for geopolitical reasons, right? We have concentrations of production around the world of both the raw materials, whether it's oil that gets turned into plastic, for example, or whether it's the plastics themselves or the finished goods themselves. And then they have to be transported around the world. So local is really where we need to go for the future, both for domestic security for each country, but also for planetary reasons as well. So we need better protection than what we've had, and we need it locally wherever possible. The thing we really need, we need standards for the general public. Right now, all of our respiratory standards for respirators are occupational health and safety standards. And so if you are employed by someone who has a business who has to have a respiratory protection program in place, you may or may not get a respirator, but those standards are written for you. So they're written for adults, they're not written for children. And they're not written for people that are retired. They're not written for self-employed people. They're not written for the general public. And we need to change that. We need global standards and national standards for the general public, specific for infectious disease, as opposed to particulate standards, which I'll talk about in a minute. Healthcare co-opted a lot of the occupational health and safety standards around the world, where they decided we're going to only wear a medical mask or maybe not mask in a healthcare facility, as opposed to following occupational health and safety standards and regulations around the world. So there's some tension there. We have to consider the impact on the economy. Better masks, better respirators are better for the economy because now you can open more. The alternative really, if you've got a very serious high mortality rate disease, is lockdown, which devastates all economies. If you can't have travel, if you can't have tourism, if you can't have hospitality because you do not have good respiratory protection, that's very serious. So here in Canada, it was about $1 trillion hit to our economy, the mismanagement of our pandemic response. That was completely unnecessary. PPE wouldn't have been 1/100th of 1% of that, proper PPE. And so we really need to plan ahead for the future. Every country does. We have to consider the environmental impact of the products that we're using. And of course, we have to write our standards in consideration of future innovation. So we can't lock them into very specific requirements that are not performance-based. We have to focus on the performance or what it is that we're trying to achieve. So comfort and convenience, we need more people wearing respirators, for example. We have to get the cost down, environmental impact down. They have to be decent looking. If we want kids or, people who are going out in the town to wear them, they have to look good. And really, quite frankly, the ones that we have now don't. They look medical or they look industrial. They don't really fit most fashion, or most fashion masks are not effective. So we have to fix that. And then we have to consider people's lifestyles. If they want to go to a restaurant, for example, how can you eat and drink? Or if you want to be 12 hours on a plane, fly halfway around the world, how can you hydrate safely with respiratory protection? So here's our environmental impact of single-use plastics. It's an absolute disaster. It ends in, lakes, rivers, streams, and oceans all around the world. Here in Canada, we have said we want to ban single-use plastics by the year 2030. And these half dozen products were already banned for this year. And of course, medical masks and respirators, what are we going to do by 2030? So local is going to be better always. Plant-based is better than petroleum-based plastics, and reusables, of course, are best as far as carbon footprint goes. So right now, when we make a mask, typically that oil is pulled out of the ground in Saudi Arabia, gets put onto a tanker ship, gets floated to China, gets made into plastic beads, gets trucked over to a plant that makes some fabric, gets trucked over to a plant then that makes some finished goods, gets trucked over to a port, gets loaded onto another ship, floats the rest of the way around the world, ends up, coming in the western side of Canada, gets put on a train or on trucks and delivered to the central part of Canada where most of the population is, distributed into other warehouses, etc. So that's gone most of the way around the world. And there's been a lot of geopolitical potential interaction along the way as well. So environmentally, that makes no sense. Domestic supply chain and national security, et cetera, it just makes no sense to be doing that. So local here in Canada, we could actually produce the plastic from natural gas rather than oil, which is one step better, not a lot, but partly, better. And we're not shipping it all the way around the world. So it's more secure and less environmental impact. Better yet, we can use plant-based sources to make plant-based plastics, which are better yet. And so while the plants are growing, they're pulling carbon out of the air. End of life, preferably recycled back into PPE or other high value products. And if worse comes to worse, industrially composted. But still better than pulling carbon out of the ground and then releasing it later. So reusables are just more protective and environmentally friendly, et cetera. And there's just hardly any reason why we're not using them in areas, where you have to wear respirators all the time. Why aren't they reusable? Makes no sense that they're not. We have medical masks, which are primarily for source control. They're not very good at protecting us, but they could be better than what they are. And then we have the other path, which are respirators, which have traditionally just been too hot and uncomfortable and hard to breathe through. And that's because they developed in two totally different ways. We had the medical path were always easy breathing, and then the industrial products were hard to breathe through. They both started out as reusable, one fabric and the other, rubber elastomeric based. And then, they evolved separately and had separate standards. And then the industrial ones got chosen to provide respiratory protection for disease in the mid-90s for tuberculosis. And so we took the hard breathing products, particulate respirators designed for the coal mines, and decided to give those to healthcare workers to protect them against TB. Well, that was a mistake. We should have continued on this easy breathing line and sealed those masks to begin with. And I'll show you a little bit behind that. So here in Canada, we just came up with a brand new standard for respirators. Here's the NIOSH standard at 245 pascals. That's hard to breathe through. And we introduced two easier breathing categories. Sub 100 pascals is very easy to breathe through. But if we were to go with a disease-specific respirator or a bioaerosol respirator, we could get down as low as 50 or 25 pascals, almost like it's not there. 10 times easier to breathe through than the products that have been traditionally manufactured. And that's really where we need to go to. Half the filter material, half the waste. We've contemplated here the idea of going to a really simple category of bioaerosol 1, bioaerosol 2, and bioaerosol 3, all the same filtration level, just difference in the seal and the convenience of putting them on. So here's where we started in the mines. We're trying to protect yourselves from inorganic, dense rock particles. And here's what we're trying to protect against with COVID and any other airborne disease. So watery, lightweight particles that are sticky versus sharp shards that are very dense. And our tests were developed differently. So the respirator test was developed with salt, which is similar in density to the rock dust, whereas the medical mask tests were developed with latex, which are similar in density to bioaerosols. So then if we look at the actual sizes of the bioaerosols that are coming out as I'm talking or speaking or shouting, and then we look at where most of that viral load is being carried, and then we look at how filters work, and we say, okay, well, there's electrostatic charge. Everybody knows that. There's diffusion, there's interception and impaction. And so depending on the size of the particle will depend on how significant each property is. And you can see that when you get down into the very small range where we test for respirators right now, electrostatic rules. And so does diffusion. And yet we're testing with products that are 2.5 times more dense than the products we actually want to capture. And we're testing against ones that are very much smaller than the products we're trying to capture. Virus particles that we're concerned about, typically 0.5 to 5 is the range that are carrying most of the virus particles. Here's our bimodal distribution for most of the bioaerosols. And so we are breathing through products that are way too hard to breathe through for what we actually need and are harder on the planet.
Hey, Barry, just a quick heads up. 1 minute remaining, please.
Okay. So as far as our standards go, we started out just with industrial applications. We started to add in medical, first country in the world to do that when we started seeing disease. And of course, for future, we have to consider the public, wildfire, smoke, et cetera. We're specifically addressing healthcare to make sure that it doesn't get co-opted away from the occupational health and safety side of things. And we're specifically going to address in the future the idea that faces are smaller in healthcare and the general public than big guys that work in the mines. And so that needs to be addressed. Easy breathing, something that's comfortable, multiple sizes. You can get easy breathing products now. You can get plant-based products now. You can get masks that you can shape and seal better now, so you can get a well-fitting. And that's really where we need to go. Particulate respirator standards separate from bioaerosols, as well as wildfire smoke. The big difference with smoke, of course, is the chemicals that can be attached to particulates or have a separate gas phase. And really, that's it.
Thanks very much, Barry. You've given us a lot to think about there, a lot of challenges, but also some pretty obvious opportunities to be going after. Our next presenter is Aaron Collins. Aaron is a mechanical engineer specializing in aerosol science. He's been testing and evaluating masks for some time and sharing his findings on YouTube and in his ever-growing Mask Nerd Google Doc. Aaron's respirator science communication work grew into 2 indoor air quality projects: Open Aeros, which is an open source hardware company developing the sensors and tools for the clean air revolution, and the OSLOV project, which is a nonprofit focused on respiratory pandemic mitigation technologies. Aaron is going to be talking about masks, but from a slightly different perspective, looking at shifting the framework of pandemic resilience and debunking some of the myths about masks and respirators, and hopefully also looking at the future for masks in dealing both with future pandemics, as Barry alluded to, and also wildfire smoke, which is obviously becoming an important topic. So Aaron, over to you.
Awesome. Thank you very much. And thank you very much for the introduction. I want to first check, can you all hear me and can you see my presentation?
Yep, perfect.
Excellent. So yeah, thank you very much. I mean, the work that I really did as part of the Mask Nerd, which is really focused on science communication of respirators, was really driven really about, how do we make masks better? How do we tackle a pandemic? So I'm excited to talk about what the future can hold for us. I do want one caveat that we are now in the future. So we don't even talk about surgical masks. So when I say masks, we're talking about the far better designs that are out there. So this is the colloquial term that we're going to all use in the future. So just to provide some clarity, we now exist in the future. So masks work. And I think one of the important things is that we also have to think about in the future that mask studies need work as well. So how do we improve in our study and design? And so when we think about the future of mask studies, we have to think beyond what we've traditionally done. And traditionally, we've done a lot of studies that are classic prevalence studies. So here's an example of some data that I had put together from a study that had looked at the students in an Austrian school in which a portion of the students wore FFP2 masks and a portion of them did not. And if we look at a classic prevalence study where at time 0, some students started at this rough rate of cumulative rate of infection. And then 8 months later, we see that the students that were wearing an FFP2 mask over that period of time only saw really a 16% reduction. And that's because of how I took that study. But actually how that study was done is kind of how we need to do studies in the future. And that study, when they looked at the Austrian students, actually did a little differently than how I kind of showed that data. And if we just, instead of just looking at prevalence of what the start and end goal is, if we look about how cases spread, that tells us a lot more. So in this study, they actually did twice weekly PCR and rapid antigen, whereas one set of students were FFP2 almost all the time, and some other students only had limited use of them. And what they found during that duration of study, especially during the peak of the Omicron, that it wasn't 16%, but actually during the peak of Omicron, there was a 2.2x reduction in the rate of SARS-CoV-2 infections. And that gap closed only because the second group stopped wearing masks because of the government changed the requirements of when FFP2s need to be worn. So it's kind of quite interesting study. And it again highlights that when we think about the futures of studies, when we look at masks, we have to think about frequent PCR testing, not just when you're symptomatic, to really understand the rate of transmission happening. We think things like genetic sequencing for transmission chains. We understand who was infected by whom. This is important for healthcare acquired infections. We also need specific details given to the users about how and when to use a respirator for a study, and the subjects need to understand that. And really, I think the most important thing is that in future studies, right, in the future, that fundamental design considerations for airborne transmission have to be baked into the study itself. So a classic example, there's a recent N95 study. They're only required to wear them when they were less than 3 feet from a symptomatic patient. Clearly, we all understand that airborne transmission can happen far from that. And so, of course, that study didn't find a significant improvement with N95. So hopefully in the future, the studies are really designed to tackle how transmission really happens. Okay, so masks work, but masks are work. And that is that when we think about masks, there are work on the individual side of things like cost, things like design and comfort and acceptance that's happening at the individual level. So when we think about design considerations, right, we think about how does it fit on your face? How is it comfortable and is it ease of use? And the classic example is a healthcare worker. You know, these came out of the pandemic after weeks of wearing masks. They have sores and stuff like that. So clearly in the future, we need to consider design comfort and duration of wear. We also need to think about general public and non-occupational settings. Barry kind of hit on this a lot, that there's a lot of use cases that don't exist in that, but that also means that we expand to the general public, which means a variety of racial groups. We also need to include the elderly and the children who are not considered in respiratory standards at the moment. There's also the issue associated with social stigma and aesthetics that come at a cost to the wearer. So some people may feel ostracized wearing a mask. And so we need to transition masks to be just a common fashion accessory. If we think of one most common medically worn device that we all wear, glasses. In fact, some people wear glasses even if they don't need them, right? We need masks to be at that social acceptance, which means they need to be part of their fashion and then look cool. The other important aspect is that they require training and tools to measure the fit of the mask. So fit is a very important aspect of respirators, which means that we need low cost and widely available fit testers. This is something we're working on at Open Arrows. But if you think about the ubiquitous of, at least here in the US, of blood pressure monitors, they're available in grocery stores and pharmacies all over the world. You can just go up. So really what we need to think about is in the future is the ubiquity of fit testers so that you can go to a grocery store or a pharmacy or to your fire department and have a performance measurement done on your respirator. And one of the most important thing also is availability. So if there's a huge equity issue associated with this, that the groups that were most impacted by the pandemic, the elderly, the brown and black populations of the US, were most impacted by that and had the least access to that protection. And so that in the future will need to be resolved. Okay, so masks work, but mask standards need work. So when we think about a general public mask standard, we need it not tied to occupational use. And we think about it, masks are designed to standards, and the current standards that we have are really designed to a specific group of people who, again, weren't most impacted by the pandemic. And so we need those standards to better represent the individuals who will be wearing these masks, and that means to cover a huge range of the population. We also need more size, and that drives more size and design considerations. So we need a huge range of sizes that fit different individuals. And we also need to make sure manufacturers measure the performance of their fit on the design. So we don't just make designs, but we actually ensure that they do actually fit the population that they're targeting. I think that's very critical. And then the last one is considerations for the duration of use and specific use cases, such as wildfire smoke versus a bioaerosol that kind of Barry was talking about. There can be different design requirements for different types of situations that we need to breathe in. But I think the key things that will come from that is that they need to be easy to breathe in, and they will need a variety of attachment styles, not just headbands, not just ear loops, or whatever the future holds in that space. So masks work, and so does infrastructure. And so masks help complement almost every situation. So on the right is a plot that was done looking at a large office building and doing a calculation in terms of transmission that might happen in that space of a large office building that had 133 people inside of it. The black dotted line represents an R0 of 0. What we really want to drive in indoor spaces is get transmission low enough that it's less than a R0 of 1, meaning that one individual lead comes in infected and less than one individual would transmit in that space. And if you do that across every building and space, then we have stopped the pandemic. And what we find in this study is that the light blue plots are different tools to improve the HVAC or to the filtration or adding portable air cleaners or a UV. And what we find is that when you add masking on top of that, masking with any combination of those gets that R0 below 1, which is very critical. And so they're really a complement to do things. So what mask wearing does is buy us time to implement the collective changes that we need as a society, which are those infrastructure upgrades and all of the other things that go with masking. That also, when we stop relying so heavily on masking, helps remove the individual burden. It makes space more equitable for all the people that are there, the disabled, the immunocompromised, the immunosuppressed. So we need to make spaces accessible for all individuals. And really, I want to highlight that we really have the tools today. Between testing and air cleaning and UV, we really can actually get that R0 below 1 for a variety of tools, and masks can just be an accessory on top of that and help with that. So masks work and will continue to work best in certain scenarios. So in the future, we will still probably be using masks in a lot of spaces. And these are spaces that are impractical or difficult to make safe in terms of spread of infectious disease. So some of these places that we think about today, many healthcare scenarios where we have people who are known sick coming into an ER, we can use it for source control. We want to make sure that if you're coming in for healthcare, you're not going to get an infection from another people. So we can use it for source control protection for patients. And you can also think about dental and dental hygienists, right? They're very close to your face. They're doing a lot of work in there. Stadiums, they're impractical to make if they're enclosed, like we have here in Minneapolis. They're very difficult to pack, probably make below that R0 of 1, given the density. Travel and planes, likely to remain useful in that space, especially no one wants to get sick on their trip. Also historic venues where it's impossible or very difficult to make the infrastructure changes necessary to update it for that. And lastly, probably one of the more interesting ones is public restrooms. I think there's a lot of interesting discussion about how toilets aerosolize the things that were in them. And I think that conversation will happen in the future as well. So masks work. And what we really can do is we can use them as a tool to help build the future, to enable all of the things in society that we need to fix so that in the future of 10 years from now, we're not talking about really the pandemics anymore, or at least we have a lot of the biosecurity issues tackled. And so I think that that's where I see masks in their as part of a tool to building the future for pandemic resilience.
Thanks, Aaron. You've made some really important points there, and I'm sure if we have an opportunity for some questions at the end of the session, we might get some good discussion going about how we act on some of the points that you've raised. Our final speaker in this session is Joey Fox. Joey is a professional engineer with more than 10 years experience in the HVAC industry. Throughout the pandemic, he's used his experience to educate people about ventilation and filtration and general air cleaning to protect themselves and others from COVID. Joey also publishes a hugely valuable collection of blog posts on this topic of indoor air quality at itsairborne.com. So I'd encourage anyone who's not familiar with that to check it out. Joey will be talking about designing a healthy space, what technologies are going to matter the most, and where should organizations be investing time and money to provide healthy spaces. And so, Joey, over to you. We can see your screen.
Thank you very much. Can you hear me?
Yep,
perfect. You can see my screen and you can hear me? Great.
Got it.
So I'll just be discussing how to design a healthy space and what technologies will be used moving forward. So first we need to determine what the exact issues are. So from my perspective, there's really three main things you need to address. The first is the fundamental basis of indoor air quality for general health and to make sure people are comfortable. Then we have to tackle fine particulate matter, outdoor air pollution. We saw with wildfire smoke this summer. Smog and pollution are leading killers. So that needs to be addressed as well. It hasn't been adequately addressed until now. And the third big problem we have is airborne diseases. So if we address all of those, we've really done a good job at creating low risk spaces. So the first technology which we need everywhere is ventilation. It's supplying outdoor air to the space. This is what's required in building codes. Step one is to make sure you're complying with what's in the building code. There is evidence that increasing ventilation rates beyond the minimum required does have health benefits and comfort benefits. There's an issue with ventilation. One, you're bringing in outdoor air pollutants. So it is better. Usually indoor air is much worse than outdoor air. So it helps, but if there is lots of outdoor air pollution, then there's other technologies that could be better. Ventilation is also the most cost intensive when it comes to energy and creation of greenhouse gases. So you want your fundamental base of clean air from ventilation, and then look at other technologies to clean the air further. And ventilation should be confirmed with CO2. You can verify that you're getting the adequate amount of ventilation from carbon dioxide monitoring. That should be something that everyone uses moving forward. The next step, this is low-hanging fruit and really needs to be done everywhere, is MERV 13 filters. Just like, surgical masks, I don't see a huge use. Lower rated filters are just, we have better filters to actually protect people from airborne hazards. MERV, it's low-hanging fruit, and that's what really needs to be the standard moving forward everywhere, both to protect against outdoor pollution and also you clean recirculated air from any airborne pathogens. So once we have addressed ensuring adequate ventilation in the space and upgrading the filtration to MERV 13, and those are always the fundamental basis, at that point, we need to introduce additional air cleaning in order to control infectious aerosols. We now have a standard on how to do that. So what you do is you find out how much air cleaning you're currently providing, find out how much is needed, and then you have to make up the difference. So we have lots of different options on how to do it. I'm listing the main ones here. I'll go through them. So one is just increasing the ventilation rates further. Again, that has a very high energy cost to it. So it's not always the best long-term solution if you want to take sustainability into account. The next is in-room air cleaners. I will speak about it in a little more detail. HEPA filters, Corsi-Rosenthal boxes, or ones with UV. There's other ways to use UV. One is putting it inside ducts. The issue with putting it inside ducts is if you're already having MERV 13 filtration, there's going to be diminishing returns because the recirculated air has already been cleaned pretty well. So in general, if you're using MERV 13, I would not recommend using in-duct UV. Then there's a few different ways to use UV inside the room. One is upper room UV, far UV, and what's called the Dibel system. I'm sure a lot of people haven't heard about that. If you want to learn something new, I'll tell you about the Dibel system. I'll go into those in more detail. And the last thing I'll just say now, electronic air cleaners like ionizers and photocatalytic oxidation. I have not seen any evidence that they are safe and cost effective at the same time compared to the other technologies. So they're not really for consideration currently. Okay, so in-room air cleaners, this is one of the main things that people have done. It's low cost and it's easy to implement everywhere. They have their disadvantages. One, when you're sticking a fan in a room, it makes noise and it's hard to get very high clean air delivery rates when you have a fan in a room. So this has always been a challenge with these cleaners. Now they have ones with PC fans, which are ultra quiet. They're really nice. That's what I use. But it's not always the best long-term solution, especially in public spaces. These things often require human operation as well. I'm sure we've all seen them off everywhere. If people don't care, which happens in a lot of places, they do nothing. So these are an effective tool. They can work. They're easy to implement. But because of the human operation aspect and the difficulty to get extremely high clean air delivery rates, they're not necessarily the best long-term solution. Upper room UV is really a technology that I think needs to be considered much more moving forward. How it works is you divide the room into two parts. There's the lower room where everyone is, and then there's the upper room above everyone's head. That's the disinfection zone. So you have UV fixtures that shine light into the upper room and you reduce the exposure to people below. You could get extremely high clean air delivery rates, 20 to 30 air changes per hour. Before the pandemic, this was used primarily for TB control, and we have evidence from measles, TB, influenza, and with COVID that this is a very effective tool and can be used a lot more moving forward. Another technology that really became much more well known throughout the pandemic is called far UV. So the difference between far UV and upper room UV uses 254 nanometer wavelength of UV light. Far UV is in a spectrum of lower wavelengths. The most common ones are 222 nanometers. Far UV, your skin can take a much higher dose of far UV light without it actually hurting you. So because of that, you could actually shine far UV lights into a room and expose people to it, and at a pretty high dose, and it's not going to hurt your skin or your eyes. In the picture here, you could see Dr. Ashish Jha, and behind him, there's 2 far UV lights shining. And in the right side of the room, there's an upper room UV fixture. With far UV right now, there is evidence that there's concerns about ozone generation. Upper room UV, I think, is much more ready to be deployed. Far UV, I think we need better evidence on what power we should have in order to make sure that when it's used, it's safe and effective. ASHRAE 241 has guidelines about how to do that. So once we need better data on how to comply with that. The dival system, which a lot of people probably never heard, it's called direct irradiation below exposure limits. This is what far UV is essentially. You're just using UV LEDs that are at a longer wavelength, so they have more potential to hurt you, but you just use it at a much lower power. There's a much lower radiance. You just keep it below what's the accepted exposure limit. You could shine it into a room. So you're not going to get as high intensity as you would from far UV, but it still could be effective, and there's lower concerns about photochemistry, and it's probably easier to install. These are just LEDs as opposed to the krypton chloride excimer lamps with far UV. This is not a really well-known method. I don't think it's been used anywhere, but it is a theoretical thing that can be looked at in the future. So just to summarize everything I've gone through, first, ensure the ventilation requirements are met based on the indoor air quality standard. Confirm that with carbon dioxide monitoring, upgrade the filtration and air handling units to MERV 13. And then you should try to comply with ASHRAE 241, the cleaner delivery rates. You could either increase ventilation, use in-room air cleaners, or various UV technologies, upper room UV, far UV, or even possibly the dival system. So that's everything for me. Thank you. Turn it back over.
Thanks, Joey. That was super informative. You've packed a lot in, and I'll again refer people to your itsairborne.com site for lots of other informative articles and resources on this topic and many other clean air topics. We are going to run out of time shortly for this session, but what I would like to do is I've captured a couple of questions from the audience. There's one theme that's come through consistently, and I'm going to direct it to Aaron in the first instance. But maybe other panelists might want to join in with some comments after that. And the question is effectively around science communication. So we've talked about many of the things that we need to do to provide healthy indoor air in the future. There seems to be some very established consensus around the science and the actions. So the question is, how do we better educate policymakers? And Aaron, given your experience as a science communicator, I'd love to get your thoughts on how we better communicate this science to policymakers and to organizations that are in a position of being able to influence and implement some of these approaches that we've been talking about in this session.
Sure. So just a caveat that I'm an accidental science communication person. That wasn't my original goal, but I very quickly learned that was an important aspect of the work that I was doing. I think there's a few different ways. I'm a big believer in the bottom-up approach, which is educating people, informing them, making them aware of what's happening, giving them the tools to explain it to people, and letting that propagate up further through society to eventually getting to those people that are decision makers and influencers that can really help change it at a sort of at a legislative level. I think also that fundamental mechanism of having the information available at a broadly accessible way also does help on the legislative side, because it gives them the tools to be able to understand this quickly, effectively, to be able to also themselves become experts. So I think making that information out, having that information available is probably the most important aspect of it, and making it broadly accessible. And I feel like we haven't done a great job of that in the pandemic. But I think in the future, as we go forward, I want to see government organizations specifically tasked with how do we take complex topics, boil it down, and to teach it at 3 different levels: the sort of middle school level, the collegiate level, and then the professional academic level, and being able to cover all those ranges so that everyone can understand the issues associated with it.
Thanks, Aaron. Good insights. If any of the other panelists, I know Lydia has had to get to another meeting, but Joey or Barry, if you have any other comments, feel free to add them in.
This is about engaging politicians.
Yeah, I think the question is broader than politicians. It's really about what seems to be the disconnect between the science as we in this discussion understand it and some of the solutions that are in our face, available to implement right now today. That disconnect between what we know and what's happening, and a lot of that seems to be around a lack of understanding of aerosol transmission and some of the science and engineering that surrounds this. So the question, I guess, is how do we address that and do it quickly?
So, I mean, it comes from two ways. The more difficult way, but the legal way, is to have politicians force it with indoor quality regulation in the Clean Indoor Air Act, and then places have to comply with that. So that's the more difficult way. What we need is building owners and building operators to provide healthy, clean air in their spaces. It falls on them, and they don't necessarily have an incentive to do it. And there was the public health failure of not educating them on how to create clean air spaces. So there's a grassroots level that has to go around and educate people about this. And then there's also the political level of ensuring that people are provided with clean air. It's a large, difficult task ahead of us.
Thanks, Joey. Barry, did you have something you want to add to that?
Well, I was going to parrot a lot of what Joey said. So it's not quick, but standards, codes, and regulations are really the key for the future. The problem with standards, codes, and regulations is generally there's no requirement to retrofit. So existing buildings are grandfathered. And so we need some type of a trigger put in for future to make sure. So anytime you do a renovation in a commercial space, for example, you would have to bring the HVAC up to the latest standards. And we don't have those triggers there right now. So that means 50 years to renew the infrastructure. So it's not quick, but that really is permanent. And when you can compare that to masks or anything else in the medical space, standards, codes, and regulations for fixed infrastructure have a definite path to getting there someday, even if it's not immediate. Whereas the other side is much more loosey-goosey. So now you're fighting public health against occupational health and safety, et cetera, and you don't have the same standards, codes, and regulations to fall back on that have inspectors, have a mechanism for enforcement and police and and penalties that you do in infrastructure. So infrastructure will get there. It just won't be quick.
Thanks, Barry. I think we'd agree that there's a lot of good work being done by people who have been part of this event today. So I want to just publicly acknowledge the work that you and many others are doing to progress that discussion. We are going to run out of time for this session, so we're going to move straight into the next session. But before we do that, I'd just like to ask my colleague Stefan to make a couple of brief announcements, and then we'll go into session 6. So thanks again to our speakers, Aaron, Joey, Barry, and Lydia for their fantastic presentations.
And outstanding presentations from all of you. So great. That's awesome. I will be quick because effectively we're running out of time. And I don't know, Yanir, if you want to jump in as well. I don't know if you're there or not so far. But anyway, I will just give you, I put on the chat that we are inviting you to look at the declaration that we would like to put out after the event. So in the next day or two maximum, but something like that. So for the next 24 hours or so, you'll be invited to look at it. If you want to put comments, that will be possible to put comment. And after that, we'll release an invite formally through our regular channels for those who would like to be participating personally, but also from their affiliation. So anyway, so that's, I gave just the introductions of what you to get on the chat, for you to get a sense of what it is. It goes in the direction of what Lydia Maraska said earlier, and all the other speakers after her. So Yanir, I see you're here. So if you want to add a few words, it's just an invitation for those who would like or would feel be part of that.
Yeah, I just think that it's important for us to come up with some statement that can be put out. And of course, we would like to also continue with other activities, but this will be helpful in producing something that we can point to as a summary statement of the imperatives that we are looking to achieve in the upcoming time, which we would like to shorten very much, but we have to lay it out for us in order to help us figure out how to do that.
Great. Well said, Yanir. So that's an invitation for all of you. And on this, I will let the floor to Melissa that will start another awesome, impressive session talking about DIY. So Melissa, the floor is yours.
Thank you, Stefan. So yes, everybody, this is going to be the DIY panel of the Clean Air Expo, in which we'll be talking about the burgeoning DIY movement around clean indoor air and the tools that everyday people have been using to combat poor indoor air quality in their homes, workplaces, classrooms, and other indoor spaces within their community. As I'm sure that pretty much everyone on here has observed over the past, 4 years to a decade, depending on how long you've been paying attention. We live in an era of compounding crises involving various aspects of our environment. And lately, there has been a lot of focus on let's call them airborne disasters. The COVID-19 pandemic is an extremely prominent one, but we're also seeing these abnormally strong, prolonged wildfire seasons in many places in the world, including ones that didn't used to have them, as well as worsening air pollution and air quality in a lot of urban areas. And this has drawn a lot of attention to the importance of clean air and the inability of our current infrastructure to adequately address these increasingly common crises. And one thing that a lot of people have noticed is the incredibly underwhelming official response to addressing this issue that has caused a lot of people to essentially take the air quality of their indoor spaces into their own hands through the building of these DIY air cleaners. And what people involved in this movement have found is that the devices that they're able to create are not only on par with, but some can even exceed the raw cleaning ability of many of the commercial air purifiers that are out there on the market for a fraction of the cost, which is absolutely revolutionary within the field. So we have 4 speakers in this panel who are going to be talking about different aspects of the grassroots DIY clean air movement and what this movement could mean for the clean air revolution moving forward. So starting us off is going to be Jim Rosenthal. Jim Rosenthal is the chairman and CEO of Texas Air Filters with over 35 years of experience in the field. He is very involved with ASHRAE and the National Air Filtration Association. However, I'm sure that the reason that all of you know him is because he is one of the co-creators of the Corsi Rosenthal box. Jim is here to talk to us about some recent work that he's been doing, looking at the filter flow and the idea of flow versus efficacy in air filtration. Jim, would you like to take us away?
I'd be glad to, if I can get this going. Let's see. Okay, everybody hear me okay?
You're good.
Okay. Most of you have seen this picture before. This is the first Corsi Rosenthal box ever made. It was made in August of 2020. Pretty simple, four 4 filters and a box fan. There have been some additions to it. We determined that having a shroud on it dramatically increased the productivity of the airflow by about 40%. So that was very beneficial. And then many things have happened since then. We think about 200,000 of these things have been made all over the world. And if I can advance. Okay, so I'm going to show you one slide that gives several different things. One, these filters that are used are MERV 13, they're electret filters. There are many people who say that electret filters become useless in a very short period of time, not as efficient. And what this slide shows us is a test that we did of these boxes in different lengths of use, coming from new to 2 months, 4 months, 6 months, 10 months. These boxes were used continuously 24/7 for this entire period. And this lower axis down here, you see the particle sizes. And there's very little drop, as you see, in efficiency over even 10 months. If you do the math on them, they're actually all MERV 13, except for the last one. It works out to be a MERV 11. So even after 10 months, they're working very effectively. But one of the reasons why I want to show this too is that these are about the right numbers of efficiency. This is actually coming out of the unit, and these are about the right numbers of efficiency. If you do a 52.2 test, an ASHRAE 52.2 test, this is about where you're going to be. And you can see, like, for 0.5 microns, we're at 50%, 60%, 65%, 1 micron, 70%. And when you're thinking about this, think about a HEPA air cleaner, the filter's at 99.97% versus one of these Corsi Rosenthal boxes. So what happens? Melissa said, it surprises everybody. Everybody who does a test on this thinks there's no way that a MERV 13 filter with those efficiency levels is going to outperform a HEPA filter. But everybody who's done it has found exactly the same thing. And a number of peer-reviewed papers have been written on this with exactly the same results. The Corsi Rosenthal box, and these are really small particle sizes. This is 0.35 to 0.46 microns. The biggest size is 6.8 to 1 micron. So these are really small particles. And you can see that the Corsi Rosenthal box outperforms the HEPA filters substantially. And I found it in my test, and everybody else who's ever done this has found exactly the same thing. And why does this take place? Well, it has to do with, it's not just the filter, it's the filter plus the fit plus the flow. And if you've been around for the last 3 years, you've probably heard me or seen me say this at least 50 times. It's not just the efficiency of the filter that matters, it's the air and the amount of air that goes through the filter that makes a difference. And to illustrate that, I did a little test. Most filters are measured by single pass efficiency, and very few actually measure efficiency in a room. One of the places where you measure efficiency in a room is when you have a clean room. And one thing you find out about clean rooms is that they have extremely high air changes per hour. Like an ISO 7 or a class 10,000 clean room has about 60 air exchanges per hour. I think most people agree that we'd like to be somewhere between 6 to 12 air changes per hour in a normal indoor environment to have really good air. But what happens when you take really high exchange rates? What can you do? So I decided to put a couple of these boxes in. One of them was new, the other one was like 5 months old, put them in my office. My office has gaps under the door. I'm sitting in the office. I turned both of them on to high. It gives us about 40 air exchanges an hour. And if you look at this, within 15 minutes in my office, me actually in the office, we went to ISO 7, class 10,000 clean room standards with 2 Corsi Rosenthal boxes with MERV 13 filters. And that gives you an indication of what happens. And by the way, some people say, well, you know, those particles, if you only get 50%, then the next time you're only going to get 50% of 50%, and you're going to still have particles that remain in the environment. That's not what happens. These particles are gone. Even this very small particles. This blue line is a line of 0.5 microns. They're gone. And the best performance on a MERV 13 is about 45% on 0.5 micron size particles. So that's the concept. If you're going to, and it's one of the things that we learned in this whole process. It's not only the filter, it's the flow that makes the difference. And everything I've seen confirms that. And we continue to learn a lot about indoor air quality through these DIY devices. And thank you.
Thank you, Jim. Okay, next up, we have David Elfstrom. David Elfstrom is a building energy efficiency engineer from Ontario, Canada, with an earlier career in medical physics. During the pandemic, he has focused on the role of the building and ventilation on transmission. He has also been helping to measure and optimize the design of Corsi Rosenthal boxes. David, welcome.
Hello. Thanks for having me in. So what I want to do today is show you how to actually get those clean air delivery rate measurements that Jim was showing you. And you can actually do this by using basically $80 Canadian worth of equipment. And yeah, so the first thing you need is you need some sort of a PM 2.5 meter. This one costs about $43. And the other thing you need is a source of aerosols. So I picked up this compressor nebulizer. It's for about $40, and it creates aerosols that you normally would use to breathe in for medical purposes. And inside this little this little spout, you put a very small amount. This only holds about 8 milliliters of salt water. And so the formula for the salt water you need is approximately 150 grams per liter of salt. How do you do that? That's basically 1 tablespoon of salt in half a cup of pure water. So preferably distilled or reverse osmosis water, and use picoline salt and mix that together, put it in a bottle, shake it up, and you'll use just a small amount over time. That 1 bottle will do for the rest of the time you're doing these tests. You can use other sensors as well, but yeah, the cheap one will do the trick. The other thing you'll need is some sort of a small portable fan to mix the air in the room that you're in, and you want to seal off in your room, like talking about a room, something like a bathroom where it's got some hard surfaces, easy to measure. In that room, you want to measure the volume in, say, cubic feet, then have with you enough supplies to tape over all the air inlets and outlets in that room, and then a towel to throw across the bottom of the door. When you have all that set up, I'll just show you what that looks like. That's me in the ensuite bathroom with all of these things. So I've taped up the register on the floor. I have an air purifier sitting on the floor, and I have the compressor. I have the nebulizers hanging up off the towel rack, and it's all set and ready to go. So I've put the particle meter close to where it's going to get some of the particles coming back from the little circulation fan. That fan, this is actually all based on the same protocol that's used in the AHAM AC1 test. It's just a smaller chamber, but everything's scaled down. It's the same concept. The other thing you need is some sort of a stopwatch. So I'm using my phone in this case. So what I've actually done, this is what it looks like, is if you were to look at all the readings off this meter and plot it against time in minutes, you get a curve on the left, and that's described by that function that you see. But how are you going to do this when you only have a stopwatch? Well, here's the interesting thing. That curve, if you plot that on a log scale, on a log normal scale, you actually get a straight line. And so we can take any 2 points and calculate the slope of that line. Now, what I did with this meter is I actually did a video recording of it and actually stepped through every 10 seconds of the frame and plotted the information. And so what we see here is I took the logarithm, natural logarithm of each point, plotted it against the time in decimal minutes, and I just told Excel, take the slope of that line, give me the equation, and it's 0.476. All I have to do is multiply that number times my volume of my room, and I get the total clean air delivery rate. That's it. That's all you have to do. And so if you wanted to do it without plotting every individual point, what you would do is start with your stopwatch. When you first turn on the air cleaner, it's going to take a little bit of time for the meter to react. This one seems to be kind of doing a running average over 60 seconds or 30 seconds probably. And then you'll see it start to react. Let it start to catch up. I waited about 2 minutes. I waited until it hit 61 micrograms per cubic meter, press the stopwatch. Now, I want to go until it reaches 1/10 of that, 10%. So my target in my mind is going to be 6.1. So I'm sitting there in the bathroom with my stopwatch, waiting until it hits 6.1. Then I hit stop as soon as it gets there, or hit the lap button, and it's 4 minutes, 50 seconds. Convert that to decimal minutes, 4.8333 minutes. And I can multiply that times the natural log of 10%, 2.303. So I've taken that, I've basically done that same thing with regression in Excel, but I've just done it using a stopwatch and 2 points of observation. That gets me the total clean air delivery rate that includes natural deposition. So I'll stop sharing here. Oops, there. Where was I? Yes. So you would repeat that exact same procedure, but use the natural decay. But don't. It's going to take you. It'll take 15 minutes for natural decay to act. Oops. Sorry, my video disappeared. Okay, my video's gone. Sorry. Oh, switch to a different video.
There you go.
Who knows? You repeat the same thing for the natural decay. If you've done a good job of sealing it, it's only going to be the natural deposition of the particles and not just loss out through cracks. And that should be a small number. And it might be about 5% of the total clean air delivery rate. And that's basically what you do. The idea would be to test that first with an actual clean air cleaner that like a HEPA air cleaner. Compare that number that you get. You should get a similar number within, say, 5-10% of what the manufacturer's specifications are. You're great. You can measure anything else once you've got it set up for that. That's it for now.
Thank you so much for that, David. Wayne, I see you have your hand up. Questions are going to be at the end of the panel. If you can just DM the question to me, I will ask it to our participants at the end of the panel. But next up, we have Joshua Agar.
Hello, good morning.
Joshua Agar is an assistant professor at the Institute of Civil Engineering at the University of the Philippines, Diliman. He is a research fellow for the University of Philippines Building Research Service and the UP Center for Air Research and Urban Environments. And he will be discussing indoor air quality initiatives against COVID-19 in the Philippines. Joshua,
Thank
take it
you.
away.
Thank you, Melissa. And I'll be sharing the screen. So good day to you all. So I'm very honored to present the indoor air quality initiatives against COVID-19 in the Philippines. But to put some brief context, Philippines is, unlike other first world countries, it's a lower and middle income class countries. Therefore, most Filipinos cannot afford to get sick. Therefore, they wanted to and talk get how do you put this? They don't want to get sick, especially particularly on COVID-19. And with that said, they very much welcome the initiative on ensuring that the air is clean. So Filipinos care for the air that we share. And one of the research programs initiated by the government here is through the Center for Air Research and Urban Environment, so UPCARE. You can look this up on the website, where we have previously deployed sensors, outdoor air quality sensors, and not only in indoors, but also on outdoors. We have also developed schematics on how to conduct indoor air quality measurements, while at the same time, we are also developing sensors and filters. So let's focus on the filters, because the reason why we are conducting research on filters, because there's a shortage, so particularly this project 5 right here. So the reason why we have been developing filters is because not only the Filipinos are fascinated with Corsi Rosenthal boxes. So the moment that it was introduced in the Philippines, lots of people have been inquiring on how to make one. However, the main shortcoming is that the source of MERV 13 filters. So MERV 13 filters are not that quite abundant here in the Philippines, so it's very tough to find. So here, these are some of the details of my journey across Metro Manila, on which I look for. I really scrambled to look for MERV 13 filters, and here are the filters that I got. And there's also a need to find an alternative for box fans, because box fans are not readily available also in the Philippines. So we opted to do instead PC fans. So this one right here, which can be sourced in the slums of Manila, while at the same time, we also tested making Corsi Rosenthal boxes using exhaust fans. And as a result, what we found out is those PC fans that we have bought in the slums of Manila, in Quiapo, they have high delivery rate, clean air delivery rate, but they are noticeably noisy. So as you can see here, the noise meter has been recording by about a noise of about 80 decibels. While at the same time, there's also a proposition to instead use HEPA filters for Corsi Rosenthal boxes. So if we combine that with exhaust fan, so you'll have this portable air purifier which you can deploy anywhere as long as there's an outlet. While also at the same time, you can also use the same schematic for the box fans for using the exhaust fans this time. So we have conducted Corsi Rosenthal box making activities back in April last year and in September last year. And what we found out are, what we have produced are different variants of Corsi Rosenthal boxes. So this one uses small wall exhaust fans. This one uses larger wall exhaust fans. And this uses industrial exhaust fans. But particular interest is being put to these types of industrial exhaust fans. So what we have produced ultimately is this type of Corsi Rosenthal box. So courtesy of Professors Fortunato de la Peña Jr. and Professors Mark San Valentin, where they have produced their prototype on which they use these industrial exhaust fans, and they 3D printed the enclosure. So basically, this is a modular type of air purifier where users get to have the components, then they get to assemble the Corsi Rosenthal box themselves. And as to the cleaner delivery rate, so it's about 606 CFM while also exhibiting less noise. So we have been improving upon this product, and at the end of the day, given the situation here in the Philippines, Filipinos are very resourceful. It's just they need, or not only Filipinos, but people in lower and middle income class countries have the necessary resources or manpower resources to conduct these types of activities. The only support that they need really is having supply to these filters. And with that said, may I impart that may all of the filters of the mask and filters of the air purifiers that we're using may filter all of the intermediate size aerosols that carry these respiratory pathogens in the air this 2023. And with that, I conclude my presentation.
Just fantastic work that you guys are doing over at the University of the Philippines, Joshua. Thank you so much for sharing. And the that wooden CR box that you showed, that is just so cool. All right, so final speaker in the DIY panel, and then we will go to the discussion, is going to be Mark Denning. Mark Denning is a PhD level multidisciplinary engineer and advocate for clean air in schools. He is an engineering advisor for the Air Support Project, and he is here to talk to us about the future of the DIY movement and going beyond DIY.
All right, great. Thanks, Melissa. Can you see and hear me?
Yep.
See my screens? Great. My name is Mark Denning. I'm act as an engineering advisor for the Air Support Project. And who are we? So the Air Support Project is an open source social startup with a mission to make clean air accessible to all. So the scope of our work is really kind of twofold. We do both product and education. So in terms of product, we're working on developing a low-cost, high-performance air purifier. And then on the education side, we're developing clean air educational resources that are, for the most part, available on our website at airsupportproject.com. So first off, I'd like to thank the indoor air community, the DIY community, that we've drawn so much inspiration from. So really our journey began, like so many others, like Joshua, for example, with being inspired by the Corsi Rosenthal box, as we all know, is a simple yet highly effective DIY air purifier. And as we've seen, that this innovation has transformed into really an international DIY movement. And Jim, talked about, how there's just numerous CR boxes have been made, and it's been very exciting. I'd like to point people to a blog post that Sarah Massey, our head of projects, wrote on our website, airsupportproject.com, entitled "Thanking Our Heroes Who Focused on the Air." It both serves as a way for us to thank all of the people that we've been inspired by and learned from. It also serves as a pretty good history of kind of this movement and what's occurred up until pretty recently. I want to point out, I think Jim did a great job talking about that issues of what's really important is that flow plus, filtration, of course, fit. But I want to say something and point this out. I think we're actually part of something very historically unique. So I don't think there's been another case in the history of humanity, really, where a DIY, do-it-yourself community, their activities actually revealed that a technology that was previously thought maybe to be mature or fully commercialized actually had fundamental flaws in its engineering methodology. And I'll explain what I mean by that. So I'm reiterating a bit of what Jim talked about earlier. And I'm going to call this the sort of Catter optimization curve. It's a bit of a simplification here, but I hope it illustrates what I'm trying to talk about. So what's important, really, we found out is that we need to clean the air, right? So the clean air delivery rate's what's important. And it turns out that you might have a very good filtering filter, but because it restricts the airflow somewhat, it actually, as you increase the efficiency of the filter, the clean air delivery rate can actually drop. Unfortunately, the air purifier industry, almost all of the devices available on the market, have maximized the filtration efficiency, thinking that that's the way to go, but they've actually sort of put themselves in a suboptimal part of this optimization curve. So the movement, the Corsi Rosenthal box movement, and all the academic papers that have come out and other home testing, like David we talked about, has revealed that it turns out the best way to do this is actually a different approach, where you have a lower than perfect filtration efficiency, but a very high flow rate, and then you get the best possible clean air delivery. So we're over here, the market is over here, and we need to get back up here because CATR's what matters. We say this all the time at the Air Support Project. So the title of my talk was Going Beyond DIY. So what do I mean by that? So we've got this situation, right, where the DIY movement revealed that there's a better way to make air purifiers, but all the air purifiers on the market are kind of not doing it that way, right? So what I'm here to say is, and I think a lot of us will agree with this, there's an urgent need to commercialize this approach, this technology. I think we have to move beyond, maybe I shouldn't say we need to supplement the DIY efforts and commercialize this technology for it to become more accessible. I want to say right off the bat, I love DIY. I make CR boxes all the time. Literally just yesterday, I delivered 2 CR boxes to my daughter's school. There's like 9 of them there now. So I can't help myself. I just keep making this stuff. But even as much as we all love it, I think we have to recognize that there's some limitations, right? The 2 main limitations are, one is not everybody can build their own devices. I'm an engineer. I like to use my hands, right? Not everybody can do this. But also, I think even more importantly is that if we want to deploy these devices to institutions, particularly schools, which is near and dear to my heart, they need to be able to purchase off the shelf and tested products. And the great thing is there's already motion in this space. We're working on this, but there's already, for example, Clean Air Kits is already selling excellent air cleaners that use this approach and are just fundamentally much better than anything else you can get on the market. And so I want to make a statement too, like if we really want this to be really massive, we got a lot of them out there, but if you want even more out there, mass adoption is going to require mass production. And at the Air Support Project, one of the key things we're trying to do is produce these devices at the lowest possible price. You saw Joshua talk about what it's like in the international world. Money is scarce. So we think affordability is crucial. So right now our target, these numbers may move around, but we're really trying to put together an air purifier, a good one that runs as well as a CR box might. Hopefully we could target a retail price of $120 and deliver something like C100 CFM, the kind of air cleaning you would get with a CR box. So where are we at and where are we going as a project? So on the product side, we've built and tested a single fan prototype. I won't get into too many details here, but we have what I think is a viable design that we could move forward with if we wanted to. But I think we're going to take a little more time to optimize various design elements and possibly change our approach a little bit here and there. But we do have sort of a viable design that we could move forward with. Right now, we're communicating with manufacturers, really trying to figure out what this might cost and entail to actually get production going. In terms of the education side, again, at our website, airsupportproject.com, you'll find all kinds of material our team has put together on COVID and wildfire smoke mitigation. We also have, we're a very open source company. We're planning to open source all the hardware designs and open source all of our materials. So you'll find completely free to print pamphlets, and we also have a new magazine called the Clean Air Times. And I'd like to take this opportunity to make a very exciting announcement. It appears, we don't know the full scope of what this is going to look like, but it appears that we will be partnering with the Balvi organization. This is a direct giving fund started by Vitalik Buterin for high impact COVID projects. We just found out recently they'd like to move ahead and support us. So we're very excited about that. Again, we don't know all the details, but this is a big milestone for our project, and we're very excited about it. Last thing I'd like to do is actually invite people to get involved with us. So we still have a long way to go, and we do need a lot of help. So we're looking for advisors who could help us in all of the different aspects of what we'll need to do, including engineering, manufacturing, marketing, and sales. If you think you could help out and want to get involved and inspired by what we're talking about, please email Sarah Massey at sarah@airsupportproject.com. We'd love to have your help and make this thing happen. So, okay, that's it from me. Thanks for listening.
Thank you, Mark. Spotlighting all of you for the Q&A. discussion section. Wayne, yes, you DM'd me your comment about the PC fan box that you were working with. Would you like to go ahead and unmute and share your story?
You hear
should
me?
be able to
There you
unmute.
go.
Okay, all right. I just wanted to thank David and Jim for teaching us all how to not only build these things, but then do the experiments to understand how this works. And I just did a really fun experiment yesterday that sort of piggybacks off the ones you did. And that was to see for a PC fan box in a large room, like a 600 square foot open area apartment, can one PC fan box uniformly bring down the particles in that space? Because we've had some critics question, say, oh, well, that's only PC fans aren't going to circulate the whole room and they're only going to work around the box and so on. And I was really surprised. I did this with my son and I walked around the room with a Tim top at 7 locations in this large room, like 25 by 25 foot. And, just at each location, we take samples at 1 minute interval, and it followed the expected 5 ACH curve perfectly uniformly across the room. You could only tell like 5 or 10% difference for, when we were sensing, directly in front of the fans. But I was kind of amazed by that. It's counterintuitive. Obviously, it's counterintuitive to a lot of people that rooms mix that quickly and uniformly. And we'll be publishing a nice little write-up on that to put that to rest once and for all. But I really wish we could, have all the classrooms across the country do these kinds of experiments. We may try to have like some kind of science fair support project just to get more kids doing it, because we're dealing with these infectious aerosols are, it's all invisible and it's just so easy for myths and misconceptions to pop up, and it's nothing like doing the experiments yourself.
Melissa, could I say something here?
Yes, go ahead.
Don't know how to raise my hand other than raising my hand. Wayne has done a tremendous job with this, the clean air kits and the PC fans. And when we first developed this concept, we did it open source for a reason, and that was two reasons. One, because it was the right thing to do, and we thought it was going to help the world deal with pandemics, and I think that is what's happened. And the other thing is, we're really smarter as a group than we are individually. And there are so many people who have worked on this project over the last 3 years who are much smarter than I am, who have done fabulous jobs. They have, the amount of research, people like David Elstrom and Stefan Stevanovic from the UK and so many other people, and Joshua Agar, thank you so much. You're an inspiration for me as well. I've always wondered what you look like other than the picture on Twitter. And I look at people like, David Elstrom, who's smiling. I just can't imagine anything that we've done that compares anywhere to what Dr. Corsi and I could have done individually. And just so thankful that this is more than just 2 people. It's everybody's project, and that's what's pretty exciting for me. So. Thank you, everyone.
Thank you for that, Jim. Okay, so we're being booted out the door. Apparently, we are running up on the time for the next session, which is going to be the practical implementation session, being hosted by Shay.
Hello, thank you. Yes, thank you, Melissa.
Unpin all of us.
Welcome, everyone. I know we're a little bit behind schedule. We're just starting our practical implementation session here. Clean air is a fundamental prerequisite for sustainable development. By promoting clear air solutions, we aim to contribute to several sustainable development goals, including good health and well-being, sustainable business and community centers, and proactive individual and public actions. In this practical implementation section, we will hear from several speakers who will tell us how to bring these practical solutions into our lives. To start off today, we have Cara Darling from Lighthouse Complex Care, and she is the practice manager and research lead with Lighthouse Complex Care, a clinic which has offices in Delaware and Colorado, taking great steps to ensure their patients are safe from COVID. Today, she will be speaking on effective development of mitigations in healthcare, standing by the Hippocratic Oath. Take it away, Cara.
Thanks, Shay. Hello, everybody. I'm so excited to be in the presence of so many greats. And I see a lot of friends out there. So I'm really happy that WHN gave me the opportunity to participate. And without further ado, we've heard a lot of good science and a lot of good information. I want to flip the script a little bit, and I want to talk a little bit more from an implementation standpoint, a little bit more away from the science and a little bit more into like, how do we effectively deploy some of the tools that we know and have, particularly in healthcare where I work. And actually, I have a little bit of an advantage in my clinics because we deal with people with complex chronic conditions. And so a lot of our people are immune dysregulated. And I think I have an easier time sort of justifying the multiple layers of mitigation that we've implemented versus, say, a regular primary care clinic or a regular healthcare setting. So, but I just wanted to share my thoughts, and let me see if I can share my screen, about what that would look like, trying to basically be an advocate across the board for effective implementation of clean air in healthcare. So hopefully you guys have my slide up. And so basically, when I come to think about like implementation of clean air in healthcare, the first thing I think about is the Hippocratic Oath and doing no harm. First, do no harm is the main tenet of the Hippocratic Oath, and everyone knows that, you know, particularly physicians, but even other medical professionals are sort of bound by this. And nobody gets into medicine because they don't want to help people or don't want to do a good job in making people feel better or have a better quality of life. I really do believe that if you choose healthcare as a profession, then the people who choose healthcare do want to improve their patients' outcomes. And so building on this do no harm is one way that I've learned to present implementation of the mitigations in a healthcare setting. So it should be enough that we can talk about preventing the nosocomial infections. You know, that's an infection acquired in a healthcare setting. And as of March in 2023, the Omicron studies ranged sort of wildly, and I'm sure that varies depending on how the different healthcare facilities have implemented their layers of prevention. But, you know, from 4.7% to 30.9%. And, you know, it's really just about sort of worst case scenario that you go to seek healthcare, or you're already in some sort of compromised position where you need a procedure or surgery or a consult, and then you catch COVID on top of that. So one thing that we do talk about and advocate is, you know, definitely preventing these nosocomial infections. And then we have the whole, you know, other kind of, you know, medical argument, and I'm talking about some medical arguments here, that we want to prevent the COVID sequelae, including and but not limited to long COVID. So I think we all understand and know the long COVID prevalence somewhere around 15-20% is what it seems like it's sort of falling out at. It sort of increases the more times you get reinfected, and long COVID is a big deal. But what's a little bit less talked about, and what we do see also in our clinic besides long COVID, we see these sort of one-offs that are also, they're not technically long COVID, but they're sequelae of COVID infections and multiple COVID infections. Things like gastroparesis, where you can't, you know, go to the bathroom, things like acute liver injury or liver enzyme elevation. I mean, everyone knows about like the, the heart inflammation that can come along with COVID or lung problems, but you may not hear as much about like the positive ANAs and autoimmune conditions that are being triggered by COVID infections. And so, when I appeal to the Hippocratic Oath, I would definitely like to, bring the medical arguments in and say, hey, we're supposed to be, healing people and not causing infection. We're supposed to be preventing, preventative care for sequelae and long COVID. But I'm going to tell you guys right now that not every environment, and I'm sure you guys know this, is like this environment here, where everyone's like, yes, we've got to clean the air. It's very important. We have all of these things that we need to do. And healthcare is stressed out right now. Healthcare basically has, a lot of challenges. And some of them are pandemic, and some of them are sort of systemic challenges that we faced ahead of time. But since the pandemic, we've got a high level of burnout. We've got a lowered pool of people that are working in healthcare. We've got supply chain issues. I mean, just in the past, I don't know, probably 9 months or so, we've had shortages, maybe a year. We've had shortages of things like lidocaine to numb people, albuterol, ADHD medications, basic antibiotics. Like right now, we can't get liquid amoxicillin. And so we've got, supply chain issues along with this still ongoing, pandemic happening, and all of the sequelae of the pandemic. Healthcare workers are also not immune to long COVID and even sort of the cognitive hits that happened. And so when I start thinking about healthcare and I'm walking around like Hippocrates and I'm like, let's first do no harm, we keep running up against this, this bottom line, let's not do, we can do no harm, but what is it going to cost us? Along with all of these other stressors and things we're dealing with, how is this actually going to help healthcare in the U.S.? It's privatized. It's a business. Even in the bigger institutions, we have to look at the bottom line. And so, how do we sell sort of these mitigations? How do we effectively advocate to implement all of these tools that we have, keeping in mind the burnout and the other challenges that the healthcare industry right now is actually facing? And so the way I've approached it and, been successful, like I said, in our own clinics, and even advocating in some of our partners, our collaborators, we have sort of a network of physicians that we talk to and refer, is by using these other intangibles that actually do help drive your bottom line in healthcare, besides just the medical arguments. We have the medical arguments. A lot of people may or may not actually understand some of the medical arguments, particularly the sequelae, but everybody understands these sort of intangibles. If you get someone sick when they come to your healthcare facility, they're not going to be very satisfied. They're not going to be very happy with you. And patient satisfaction is a big deal in healthcare. We have all these surveys and reviews and all these metrics that we want to meet, and as we should. And so making sure that less infection equals better patient satisfaction is a great talking point if you're talking to investor groups for private clinics, or you're talking to your administration in a larger healthcare setting. Knowing that not infecting people makes them more satisfied with you is something it would seem basic to point out, but we also remember we're dealing with sort of a we have this whole pervasive sort of denial and everything is over and COVID's not a big deal. And then we also have some of the cognitive stuff that's, I think, hitting us sort of societally. So stating the obvious sometimes, patients will be better satisfied with you if you don't infect them, sometimes actually can advance your goal. And then, of course, better patient satisfaction not only leads to better publicity, but also when you can advertise yourself as a COVID-safe clinic and people can, have the confidence to come and get COVID-safe care. I think this is a little bit of a lesser point just because there's not as much demand now for COVID-safe care. We definitely have a lot of work to do in terms of public awareness and public health messaging, which I know there's going to be a session on later. I think Shay's going to talk about, but we still can say, look, if we're not infecting people, we have better patient satisfaction. We are advertising that we're caring for our patients. We're going the extra mile. We have these mitigations in place for our patients. And then on the flip side, because there is this sort of strain on the healthcare system, We have better employee attendance if our employees are not getting sick and they're protected from infections, not just COVID. And a lot of times I'll even start saying that, when I'm talking about our mitigations, I'll be like, yes, we are preventing COVID and staph and strep and all of the other kinds of, RSV and the flu and everything else that keeps people out of the workplace with our mitigations that we're actually, largely implementing for COVID. And then better.
I just wanted to let you know you have 1 minute.
Sure. And then better employee safety in terms of employee retention, because if you get, if your employee gets sick and they take a cognitive hit, and then they may or may not be able to continue in the future. And so you've heard about the tools, you've heard about filtration, there's our Clean Air Kit friends, you've heard about FAR UV, our sterile ray friends, masking, all of those things. We can do all of these things, but in terms of implementing them after we know what to do, then we have to, basically sort of convince the powers that be or the people around us that to actually let us do them. And so my last little point was, when you're looking at things to implement, you sort of also want to keep in mind that things like ventilation, filtration, and FAR UV, in my experience, even though they might be a little bit more expensive, can actually be easier to implement than actively asking people to do things like put on mask and test. And our clinic has them all. We have mask, test, ventilation, filtration, and FAR UV. But when we talk to other sort of partners and people, everyone seems to be really open to, air filters or improving their ventilation status, or even the FAR UV stuff. And there's a little bit more reticence for the mask and the test. So anyway, that is what I wanted to sort of share with you in terms of my thoughts on implementation today. Thanks for having me, and I'll be quiet now.
That was so great. Thank you, Kara. I'm going to switch our spotlight over. Here we go. Thank you. I really appreciate you highlighting the needs, stresses, and challenges of preventing infections in healthcare facilities, along with proactive solutions that you mentioned that providers can take to do no harm in this moment too. Next up is Dr. Marianne De Alessandro. Marianne has served as the Director of National Institute for Occupational Safety and Health, NIOSH, National Personal Protective Technology Laboratory, NPPTL, since March 2012. She has also served as the Associate Director for Science for NPPTL from 2003 to 2012. Marianne leads the effort to align PPT initiatives with user needs across all workplace industry sectors. She played a key role in the COVID-19 in response during leading personal protective equipment research, respiratory conformity assessment, combating counterfeit and substandard PPE, and addressing respiratory protection needs for the general public. Today, she will be speaking on steps to keep workers and the public safe when respirators are needed. Take it away, Marianne.
Thank you, Shay. Can you see my screen?
Perfectly.
Okay, excellent. So I'm honored to have this opportunity to share my perspectives on promoting clean air by focusing on worker and public protection. So our mission at NIOSH, the National Institute for Occupational Safety and Health, is to develop new knowledge in the field of occupational safety and health and to transfer that knowledge into practice. We believe every human being deserves safe and healthy clean air, and we are making incremental changes across workplaces as well as the public to realize this vision. Strategies for providing respiratory protection for the public and for workers without formal respiratory protection programs build on over 50 years of NIOSH occupational experience. I would like to offer insights into 3 areas NIOSH is emphasizing to move toward every worker and every member of the public having safe and healthy clean air. That's education, collaboration, and innovation. So using education, collaboration, and innovation, we can protect workers who fall under occupational respiratory protection programs such as OSHA, workers who are outside of those programs, as well as the public, including children and vulnerable communities. First, through education, we must make safety and health everyone's responsibility. People need to know how to protect themselves when the air is not clean. Every minute in the United States, a young person between ages 15 and 25 is injured on the job, adding up to over 2.8 million adolescents and young adults injured at work over the past 6 years. It's not enough to have standards and guidelines. Standards and guidelines need to be understood at every level, not just through enforcement. Educating the workforce and the general public as early as possible about the value of living a safety culture and caring for the safety and health of yourself, your employees, and your family will lead to productivity, efficiency, and better health throughout your life. First of all, on this slide, I have a couple of our resources. This is just an example. We have many resources that people can use to educate themselves and others on our website, and that link on the bottom left is our website. So educating our youth is the beginning. Through NIOSH educational programs, such as the NIOSH Safe Skilled Ready Workforce Program, we are working starting at the middle school level to have every person in the country, before they join the U.S. workforce for the first time or start a new job, to have the foundational knowledge, skills, and abilities they need to stay safe and healthy at work and contribute to a positive safety culture in the workplace. The programs are customized for each state and several U.S. territories, and also are available in Spanish. Some programs have been modified and adopted internationally as well. These curricula can be adapted and translated to every language through partnerships with any nation, and this is our first step in providing every worker a safe and healthy environment. Our vision is to have these programs in every state, in our country, and across the globe. Collaboration with industry, labor, and other governmental and non-governmental organizations is a second area of emphasis. Successful partnerships with industry are important both during routine work and emergency response operations, especially as the nature of work is changing more rapidly than ever before, and the public could benefit from respiratory protection during wildfire smoke events, mold from floods, or infectious disease outbreaks, to name some examples. And finally, the third area of emphasis involves fostering a positive safety culture through innovation in every industry sector for adults and children in the public on every continent, across every company, large and small. As Alcoa Corporation's safety leader, Paul O'Neill, emphasized, safety is not a priority, it is a precondition for organizational behavior. Individuals should not have to think about safety and health. These topics should be second nature. We have partnered with industry, labor, and professional societies to document best practices and safety culture and to improve health and safety standards associated with respiratory protection when the air is not clean, and workers and the public must protect themselves. These guidelines and standards will continue to evolve as the nature of work continues to transform with each technological innovation and the globalization of the economy. In closing, in a rapidly changing world of constrained public resources, the power and creativity fostered by emphasizing global collaboration can and should be deployed for the public good, and working together on education, collaboration, and innovation through positive health and safety culture solutions and clean air, we can be successful in protecting the people who are exposed to unclean air hazards every single day. Thank you for having me today.
Thank you, Marianne. Thank you for highlighting the need to not just make regulations, but informing the public of the resources available by NIOSH and NPPTL, and on the importance of collaborations with industries in supporting the public health and safety. Next, we have Nicholas Burt. I'm not sure if he made it in. Nicholas, are you here in the room right now? If not, we can come back to him. And we will go to, I'm assuming he's not here, so we'll go ahead and move to Catherine Walsh from Boston Public Schools. Catherine is the Sustainability, Energy, and Environment Program Director of Boston Public Schools. Catherine leads district-wide initiatives to transform the sustainability measures and environmental health of 132 Boston Public School buildings. She joined Boston Public Schools in 2017 following a sustainability career at the University of California, Berkeley. She holds a bachelor's in political science with a minor in environmental studies from Boston College. And today she will be speaking on the future of indoor air quality sensors in the classrooms. Take it away, Catherine.
Thank you, Shay. I'm having trouble sharing my slides. I apologize. Oh, here it is.
No worries at all.
Are you able to share them or?
What we can do is I can move to a pre-recorded video that I have coming up next, and we can set you up with our tech guy, and he can get kids.
Sorry about that.
No worries. We'll come back. From now, we'll go to, we have Peter Peach from Clean Air Stars. He is, he currently maintains a website developed to help businesses understand how to assess their indoor aerosol transmission risk, find professional guidance where time and resources allow, get advice and testimonials, and build a directory of businesses with safer air. You may have also seen their excellent air filtration recommendation tool and assessment on how to improve indoor air quality at the Clean Air Stars website. I know those are some of my favorites. Today, Peter has sent a pre-recorded video, although he did, I think, end up making it here. So he'll be available for the question and answer session at the end of this section.
I'm Peter Peach. Since 2021, I've run a not-for-profit website called Clean Air Stars, aimed at both helping business owners reduce the risk of airborne transmission of viruses like SARS-CoV-2, as well as help customers find those businesses. The topic of my talk given to me today is Safe, Clean Indoor Air, the challenges to facilities management. I'd like to caveat this talk by saying I am not an engineer. I am an anesthesiologist with a background in virology and training in public health. I have been in contact with many business owners about cleaner indoor air, however, so I do have a few insights. Providing cleaner indoor air is a public health intervention. It's a way we can reduce the burden of disease and cost to society through properly considered investment in cost-effective interventions. Like many public health interventions, we often take them for granted. A successful outcome is simply the uneventful absence of a bad outcome. It is not as exciting as putting out a fire, nor is it as obvious as removing cigarette smoke from our public indoor spaces. Clean indoor air is a relatively new concept for most people to grasp its importance and to know what actions to take. That is, if you exclude the 100 or more years of advice on its importance that had been given to us, but we've since forgotten. Finding the right advice on indoor air quality can be challenging for business owners. Infection control isn't considered in the ventilation in most building codes. Businesses I spoke to found little value in contacting their local HVAC company who had little awareness of infection control. One thing that did become very clear was the need for clear guidance from authorities on how to assess the adequacy of a space's existing ventilation and recommendations for improvements where needed. This slide here is an example of the advice given to Victorian businesses from the Victorian government here in Australia. So one important challenge is that many companies are willing to sell expensive, ineffective solutions that don't actually help their customers meet available, well-defined clean air delivery targets, measured in litres per person per second or air changes per hour. Many focus on marketing complicated sounding technologies while avoid discussing how their solutions will help meet objective performance standards like clean air delivery rate. Expensive, ineffective solutions don't make for cost-effective public health interventions. Providing government financial support for businesses for ventilation assessments and upgrades is important, but we've learned, A, it isn't enough to incentivize broad uptake. It will require standards and enforcement. If not well thought out, it opens up taxpayer purse to abuse from companies selling ineffective and expensive solutions. This scenario is not just a resource allocation issue, it's also an opportunity cost where a genuine opportunity for improved outcomes is missed. Where the decision is made that installation of portable air filters is required, it's surprisingly difficult for business owners to match options available on the market with desired clean air delivery targets for a variety of reasons, including data transparency on device performance, as well as their noise levels. This pain point was the reason why the open source air filter selection tool on the Clean Air's website was developed to help people solve this. For facility managers, it's important to note that ongoing regular maintenance of either mechanical ventilation or portable air filtration is critical. Duct filters in mechanical ventilation needs changing. Pre-filters on portable air cleaning units do need regular cleaning, sometimes as often as every month or two in dusty environments like schools. Without regular pre-filter cleaning, a device's clean air delivery rate can decrease by 50% or more, drastically reducing effectiveness. And this was one example of a device that was used in a school here in Australia that showed a 50% reduction in flow after 2.5 months that was mostly restored by cleaning the pre-filter. Portable units also need to be automated. They simply cannot rely on human interaction in their design if we want them to be powered on at the appropriate fan speed at all the times they are required to be used. So, in summary, we need to make it easy for business owners to understand when and how to improve the quality of their indoor air. They don't necessarily need to know themselves, but they need to know who to call and have the appropriate solutions delivered to them. Recognise that there will be a return on investment, but this is dependent on properly considered implementation, as well as ongoing attention to maintenance to ensure sustained risk reduction. We need strict and clear technology eligibility criteria along with goal-orientated clean air targets for any cleaner air incentive programs to optimise their cost effectiveness. And finally, we need to recognise that financial support and incentives are necessary, but are not sufficient. We need enforceable building standards if we want to see widespread change. Thank you.
Thank you, Peter, especially on the importance of maintaining those HEPA units, the pre-filters, et cetera, for maintaining their function and for all your work helping business owners. Next, we're going to go to Nicholas Burt. Nick is here. Nick, do you want to raise your hand so we can unmute you? He is FMA. There he is. He's waving. Do you see him? I'm going to do him. Ask to unmute. Let's see if we can do this.
Okay, I think I have been unmuted, and I think hopefully you'll be able to hear me. And thanks to the network for allowing me to say a few words today. And I would like to just build on some of what Peter has spoken about previously in the facilities management space, and perhaps provide some insight into the role of facilities management in the direction of improving indoor air, and some of how that might play out in the Australian context. I work for the Facility Management Association of Australia, which is the industry and professional peak body that supports and represents the profession and the industry more broadly. And so our role is really one of not only advocating and educating in various aspects of facilities management, but also to support the industry and to work with government to ensure that the right regulation settings are in place. And so it provides us with a great opportunity. I guess from the indoor environment space, facilities management has always seen that as a core role, and from the professional perspective, but it's not always been front of mind for the rest of the community, whether that's in the workplace or whether it's more broadly general public. But more recently, Clean Air and clean indoor air particularly has become the forefront of people's minds. You know, the pandemic has created many things, including a consciousness of the need for indoor air quality to be maintained at quite a high level. In the Australian context, you know, the mandating of masks was a real eye-opener for many people using facilities, and having never experienced that before, became super aware of the need for managing indoor environments much more than was previous to that. You know, the fact that during that pandemic period that there was no flu season or no flu epidemic in Australia, you know, because of some of those health measures, was only another opportunity to raise the awareness of clean indoor air and clean indoor environments. So there's a greater interest now at a public level, at a community level, of keeping safe indoor environments. And that's not just offices as a workplace, but also in other building types. And we're hearing much more about it through our membership of facilities management professionals, shopping centres, restaurants, to name a couple, hospitals and other public transport environments are some of the areas which have been highlighted as super important, and where people are really cognizant of the indoor air. Workplace, it's health and safety. In other environments, it's really about health and well-being and promoting the positive aspects of people's health. So we know that it's, you know, and I don't have the research with me, but we know that it improves cognitive function. We know it improves health outcomes, you know, from a respiratory perspective. And so why wouldn't we want to be a part of that journey? Facilities management professionals are crucial in the value chain for building occupants and users, and for improving and educating owners about some of the aspects that need to be a part of a appropriately managed facility. So in Australia, the role of FM is recognised as one of the top 10 professions that's crucial in driving net zero emissions. And the reason I'm mentioning that is because I believe that this indoor air journey, this improving indoor air journey, is really related in a very similar way to the journey that we've taken around the reduction of carbon and the net zero journey. So I suspect the same realisation over time will become around the importance of facilities management in the indoor air quality space. So I think, to build on some of what was already said, is that it's really important that we do have standards. And in Australia, we don't currently have standards around indoor air quality. You can't manage what you don't measure. And so to improve indoor air quality, we need to have a standard that we're measuring to, and that needs to be ongoing measurement, and something which is fairly simple, so it can be broadly implemented across a range of different facility types, and that everybody is aware of what that standard means. And so having the translation of 4 or 5 different metrics which improve indoor air, maybe things like flow rate, CO2 concentration, particulars, and so forth, having that bound up into a system which is easily understood by the public, such as a star rating system, is a space we believe would benefit the opportunity for improving indoor air. And that's a very similar journey that was made in the energy efficiency space in Australia. The opportunity to mandatorily disclose energy ratings in a star format that everybody understood became then really a race to the top, rather than a legislative imperative to drive improvements in energy efficiency. And I think that opportunity exists for us in the indoor air space. Once we let people know at a public level, and we let the stakeholders understand what indoor air is, and we measure it and we tell them what it is in any indoor environment, or at least in all public environments, people will make a choice about the environments that they want to move into. And then all of a sudden, as a facilities manager or a building owner, or the combination of the two, working collaboratively, you'll be aiming for something better. And so we let the market then drive the improvement and push it down a path. And that is a very similar path that has happened in that energy rating space. Now, we already have complex systems for rating indoor environment. What we need is a tool which is very simple to implement, so it can be broad-based, and we need a minimum standard for which all buildings will comply. That combination of measurement, management, and the standard is what will drive improvement in this space. And so many examples that we've got. I don't have the time to go through in further detail, but more than happy to be a part of an ongoing conversation. Our 3 key things will be: put a standard in place, mandate its disclosure to building occupants or facilities users, and then use that as an opportunity to drive the market. And all of that can be supported by a public policy incentive program to improve outcomes and to drive where there is changes needed to facilities, improvement in capital plant or expenditure, that's supported through government initiatives. I'm happy to leave it there and let others take the conversation further. Thank you for the opportunity.
Thank you so much, Nick. Thank you for highlighting the needs for facility standards like flow rate, PM, the idea of the star rating system I really liked, and the fact that you can't manage what you don't measure. Next, we are going to go back to Catherine Walsh. I think we got her slides now. Pat, is that confirmed? Do we have her slides that I'll
Yep,
see?
they're going to be on the screen very shortly.
Wonderful.
Like right now.
Thank you, Shay and Pat. Appreciate you saving the day.
Thank you. And again, she's from Boston Public Schools and talking on the future of indoor air quality sensors in classrooms.
Thank you. Next slide, please. Just thank you, honored, humbled, and very grateful to be here with you all. So I think it's important to just start with a little context about Boston Public Schools. It is the oldest public school system in the United States. We serve an incredibly wonderful, diverse student and staff population. We have about 48,000 students, 10,000 staff, and we have 119 schools across 132 buildings. An important note in relation to this conversation is that with the age of our buildings, only 1/3 of them actually have full central HVAC. Another 2/3 rely on natural ventilation, so operable windows for their ventilation, with some limited and supplementary ventilation in about 1/3 of those. Next slide, please. So we've had a long time history, commitment, long before the pandemic, to indoor air quality management at Boston Public Schools. We follow recommendations from the U.S. Environmental Protection Agency's Tools for Schools program. They have a wonderful schools program around indoor air quality, and they recommend a layered risk reduction approach. So that means implementing many different strategies in parallel, in layers at the same time to address indoor air quality in schools. And so the piece that I'm going to be focusing on, the layer today in terms of technology, is what we did to modernize our monitoring and reporting layer. Next slide, please. So prior to the pandemic, we started conducting market research around live monitoring in our classrooms. And that's because we have about 5,000 classrooms across the district. Historically, we had been conducting indoor air quality testing with manual instruments, which, while that's better than nothing, we all know that's really just a snapshot in time. It's not giving us a full, true picture of what's happening with our indoor air quality in our classrooms. You could take a reading at 9 a.m. when you visit, and then that reading could be with good air quality. You could leave, something could happen later, and you wouldn't even know what's going on. So we looked into modernizing and investing our approach to testing, and so that it would help us better communicate the data, address issues in our operations and our investments, and also be able to be more transparent with our community and do some priority decision making. Next slide, please. So in December 2020, we actually launched an RFP, a request for proposals. We ended up signing a contract in spring 2021 with SGS Galson. Basically, we ended up installing 4,500 sensors across our district. We prioritized sensors in every single classroom, every main office, and every nurse's office across the district. We also decided to put an outdoor sensor on every school rooftop, knowing that the schools span the city of Boston. Different neighborhoods, different areas of the city are facing different ambient air quality challenges, and we wanted to have a baseline at each location. We chose 6 parameters to focus on that were most important for us as a team, and those were carbon dioxide, which we use as a marker for ventilation, temperature and relative humidity to look at thermal comfort, carbon monoxide. We have a number of boilers across the district as part of our heating source, and then particulate matter, PM10 and PM 2.5. Next slide, please. Another big piece of our decision to put sensors across the district was to create a completely public dashboard where we are sharing all of the information live at all times. So you could actually visit our dashboard right this moment and see what's happening in our schools. That was a really important step for us in terms of committing to transparency, being able to connect better and communicate better with our own community, and to be able to use this again as a tool to make necessary investments across the district. Next slide, please. So in addition to what you saw prior, which we have district level view and you can run the district level summary, we also have the school view. Next slide, please. And a classroom view. So again, parents, teachers, students can pull this up on the website and look at their either individual school, a district-wide summary, or even their classroom level. One of the things we're actually hoping to launch before the end of the calendar year that we've been working on is a mobile app. And that's in response to seeing that about 70% of our visitors, likely the majority of our community, is using a mobile device to access the information. So it's, again, very important that we're responding to the needs of our community. So stay tuned on our mobile app. Next slide, please. But just collecting data and putting it out there is not enough, right? Again, back to that visual of layers. It's only one piece to addressing and managing indoor air quality management in our schools. This piece with the monitoring, you actually need to do something with the data. You need to be using it not just for communication purposes, but to actually make improvements and change. So we've been using it in a number of ways in our operations. I'm reporting through facilities management. So we're using this data to work with our HVAC team, our energy division, dealing with thermal comfort, increasing ventilation rates. We're responding to concerns around neighborhood house fires. We are using it to update our policies. We've even used it in both winter and summer times to address should we have school if there's extreme heat and cold. And next slide, please. We're also been using it to make more greater sort of investments, so capital investments, not just the day-to-day operations, but as I mentioned, one of our greatest needs and one of the greatest strategies we need to help improve indoor air quality across Boston Public Schools is investments in HVAC across our schools. And so we've been able to use this data to make prioritization plans. So for example, right now we have 6 schools going through a design fee phase process where we're collecting feasibility studies from a vendor in order to invest in full HVAC systems in those 6 schools. We've been able to use this work to get some serious grant funding from both the state, support from the city, as well as sharing our story across the world. That was a nice, unexpected outcome of this, and trying to help other schools like us learn from this program, hopefully share our mistakes with them so that they don't have to go through what we've gone through, and just, again, working together to improve indoor air quality across all schools. The last thing I'll mention in next slide, one of the results that's been very important for us as from this program is a research partnership with Boston University School of Public Health. They've been helping us really process and analyze the data points. We are collecting more than 2 billion data points per year. It's a lot of data for operations folks to manage, make sense. So having a research partner to help us has been really critical. And we actually just added a second phase to this research project where we're going to be working with BPS Health Services to start to overlay all of this IAQ data with things like absence data, communicable disease clusters, asthma incidents in our schools. So that's something really exciting and important that we're working on in addition to using this data to try and make operational investments. And so I can end there. Be conscious of time. Thank you all.
Thank you so much, Catherine, for discussing those IAQ sensors that measure CO2, PM10, PM2.5, beyond just a snapshot, but on a dashboard, and how you use this to get state and city grants, as well as your success securing ESSER funds and being a leader in the community here. Because we're a little bit late on time and I don't want to dip into the last section, I'm going to go ahead and skip over our QA session. In fact, the questions I did see in there were answered in a lot of people's presentations. And so you guys did a really fantastic job with those. And we will move to our next session, our final session, which is Driving Change with Dominic Meager leading it here. Thank you so much.
Thanks, Shay, and thanks everyone for coming and sticking around, especially all the speakers. It's been really amazing to hear all these talks covering such a wide range of parts of this story. And you know, some of the things that came up really hit on what we're trying to do here, I think, which is, you know, demonstrate that this is a solvable problem. I remember one of the speakers earlier said doctors are trying to avoid this discussion about air transmission because, you know, they're afraid of the implications. But what we've been hearing here is that there are solutions, and so it's not a conversation that we should be afraid of. Right? We've heard how the technology exists, the product exists, the standards exists. You know, many of the rules and regulations exist, but it doesn't seem to be happening. And so this session now is about, you know, maybe the last part of this whole train of achieving change, which is the sort of the politics of it. So I'm going to start with Shay. So Pat, Shay's pre-recorded a short video. Pat, have you got that lined up?
Right, yep.
Yep, so Shay is with the World Health Network and is speaking on driving change in public health. And we're focusing first on more of the personal side of things with the PPE and you know, the politics of that a little bit, and moving up through each of the speakers. But over to Shay, if that's ready to go.
Okay, good. All right, good.
Thank you, Dom. I'm here today to talk about how crucial it is to use clear public health messaging to break political, economic, and social barriers to infection prevention. One of the biggest barriers to the goal of reducing infections, slowing viral evolution, and subsequently reducing chronic disease, disability, healthcare strain, economic blights, and premature deaths, and the confusing and often conflicting public messaging on how to use the tools effectively. As you've already heard, there is a scientific consensus that SARS-CoV-2 is spread in aerosols when we breathe and talk, and yet the actual public health policies have not been updated to align with this information. We also know that the dangers of COVID-19 move past those of acute infection and have for millions of people developed into serious, long-term, often chronic, and sometimes deadly effects of long COVID. Now that we understand, we need to get the appropriate public response and the political response. We need to acknowledge where our messaging has gone wrong, where it was politicized, back away from misinformation, anger, unwillingness, and confusion on the science, and put that to an end. That is what the clean air revolution is about. As we've seen today, the technologies exist, the impetus exists, and the science and research into COVID-19 transmission, control methods, and long-term effects exist. Yet having the tools is one thing, and getting people to use them effectively is another. This begins with clear public health messaging. There have been many models that have attempted to describe how to use multiple layers to prevent COVID-19. One that I think almost everyone is familiar with is the Swiss cheese model, in which using more layers of cheese or prevention strategies reduces the chances that COVID will break through their holes or weaknesses and lead to an infection. The problem is that when you're using, say, 2 or 3 of the wrong layers, the holes are not filled up and you can see right through. Let's take a step beyond this model and look into how these layers interact, honing in on masking. And when I say masks, I'm referring to respirator masks, such as N95s, their equivalents or better, ventilation filtration, social distance remote, testing, and vaccination. Communication is key here, so I'll suggest some examples of ways to answer important questions. The first piece of cheese that people often want to take out is masks. However, wearing a respirator mask in public spaces is important and prescribed in almost all public situations. Masks are a form of cleaning the air, a very effective form, considering it directly filters air as it's exhaled from a possible source, and again before you breathe it in, with a high level of filtration. When wouldn't it be prescribed? If you're remote or virtual, obviously you don't have to wear a respirator mask. Those who are under 2 have certain disabilities, those for whom it seriously interferes with breathing or who are in medical situations in which they can't wear a respirator mask wouldn't need to wear a mask. Yet when you have individuals who cannot mask, it's even more important that those around them are wearing a respirator mask and that other layers are brought in as well. The more people who are masking in a space, the lower the risk of COVID-19 transmission. Second, some may wonder, is there a difference between one-way, two-way, and universal masking? Yes. Universal masking offers significantly more protection. This should be the standard. However, these spaces are harder to find right now, and we may sometimes have an essential service where we have to go into a one-way or two-way mask setting. If you find yourself in such a situation, you'll want to add as many layers as possible at the highest level as possible. For instance, you can improve your mask efficiency by finding one with a better fit or with a higher level of filtration, for example, elastomeric respirators or PAPRs. And you can ask for others, such as medical providers, to mask. How does ventilation and filtration factor in? On top of masking, extra ventilation and filtration to the 6 to 12 air changes per hour range is recommended for the purposes of infection control, leaning towards the higher end when higher numbers of people are present in the space. Remember that COVID-19 can build up and linger in indoor environments for hours, and ventilation and filtration take time to clear viruses out of the air. Masks give you protection during that space and time. Ventilation and filtration lower the density of infectious particles, making masks more effective. What about 6 feet? For one-way masking, personal space, like 6 feet, becomes even more important as viral density is stronger closer to the source. Spacing out provides the space and time necessary for ventilation and filtration to start to clear those infectious particles out. Note, 6 feet is not a magic number. Viral aerosols can and will travel beyond this distance, which is why wearing a mask is necessary even when spaced out. If personal space cannot be guaranteed, then it's even more important to add additional layers, for instance, testing. Different uses of tests. Adding screening tests can reduce the number of positive people coming into a space by catching some positive cases. However, because tests can miss and or delay picking up many cases, they cannot rule out an infection or contagiousness. Accuracy of tests is increased by using multiple tests, repeat testing, and PCR tests, but masking should not be removed unless a regimen is followed to have that person enter your bubble, which often requires significant isolation periods and multiple tests. What about vaccines? Vaccines are an additional layer to wearing a mask, not a substitution for. They're to reduce risks of severe disease during the acute infection. However, their effectiveness wanes over time. They don't prevent transmission or infection, and they do not prevent long COVID. Also, not all people are or can be vaccinated, and not all who get vaccinated are significantly protected. Thus, vaccines are not a substitute for other layers of prevention. In summary, it's important to not simply focus on using many layers, but instead pay attention to how these layers actually work. Find compatible layers to provide true risk reduction for you and others in the community. All are at risk for serious effects of COVID-19, and our actions affect those around us. Using clear messaging on what really works is the first step in overcoming obstacles to technological development, implementation, and policies, and bringing these tools into our home, work, school, and business spaces. Thank you.
Thanks, Shay. I think so. That's a demonstration of the sort of really clear messaging that I think some of the other people have been talking about. We're moving over. I'm going to introduce Mike Bailey from Clean Air Stars. and his focus has really been much more on getting the technical correctness of some of the messaging that's gone into installing filters in classrooms, right? Mike, do you want to explain your story and how that all went on?
Sure. Well, what I prepared today was, excuse me, a talk about what can be achieved through community action. So I'm coming to you from Huntsville, Alabama, roughly speaking, technically Madison, Alabama, and my day job is information security. But I also co-founded Indoor Air Care Advocates with my wife, Sarah, and our friend, Jennifer. And we've accumulated some good examples of community action, and we'll weave in a little bit about the technical correctness aspect too. So Indoor Air Care Advocates, I should say, supports parents and caretakers and teachers and community members in getting schools to understand and adopt the contemporary recommendations for proper ventilation of schools. And we follow authoritative experts like ASHRAE and EPA to try to build a coherent picture out of the diversity of guidance. And you can get our welcome email and our advocacy guide at tinyurl.com/better-school-IAQ. So the experts have spoken, and they've said that standard ventilation rates that you would encounter in mechanical code are not enough. This is according to the American Society of Heating, Refrigerating, and Air Conditioning Engineers. How much is enough? If you look on the right-hand side here, we've spreadsheeted it out a little bit, and we find that it's between roughly 2 to 5 times what you'd get with mechanical code. That's where the recommendations kind of center. All right, and then there's also a new standard that Joey Fox mentioned called ASHRAE Standard 241, and this is about 3 to 4 times what's required by mechanical code. So that's during times when you would have a reason to reduce infection risk. So the impact of meeting these can be a 70 to 80% decrease in exposure and transmission. And there's also science to suggest that Dr. Shelley Miller at UC Boulder has highlighted for us on the right there, that hitting these targets in buildings can actually diminish attack rates of epidemics by a significant amount. So I've lost my notes, so I'm just going to go from memory here. So we need to press for what we know is right. The first thing is to educate ourselves. The EPA's IAQ Schools website has really excellent information and webinars. The Center for Green Schools, which is run by the U.S. Green Buildings Committee, or Council rather, also has high quality information. Our blog has a lot of information that points to authoritative sources as well. Once we've educated ourselves, we can help our friends and community members connect the dots and understand that schools don't have to be petri dishes. We can speak at Board of Education meetings, and we can write op-eds for our local papers. On the right, you have an op-ed here that I co-authored with a co-founder of Protect Their Future. And this op-ed not only educated some people, but also got us connected with more people who are looking to work on this problem, including people from the Pew Charitable Trusts. So a part of speaking out is sometimes connecting with more people who want to help with that problem. The next thing we need to work on is getting schools to meet code to start with. Our measurements that parents have taken across the United States really confirm what the experts have said, which is that schools don't meet code, generally speaking. And so it's no wonder why people call schools petri dishes and why schools are having a doubling of absenteeism when they're trying to carry on their business as usual with a whole new way for kids to get sick, right? It's just not working so well. It's important to note that many schools don't really know that if their carbon dioxide is exceeding 1100, they're very, very likely not meeting code. And there are even more aggressive benchmarks that have been set by the CDC in 2020. So we've been lending carbon dioxide monitors to faculty and to students. And there are also programs through the US government, like the EPA, through their regional indoor air coordinators. They can lend CO2 monitors, depending if they have them. And then also the Department of Energy's Efficient Healthy Schools campaign absolutely does have CO2 monitors and will lend them to schools. So these are helping us quantify what the problem is. And the bottom line is that we just need those schools that have problems to get a testing, adjusting, and balancing to get back in spec. The problem there, though, is that it's been said before that an HVAC might not get us around to the recommendations or the standards that have come out. This is Bill Banflett, the former president of ASHRAE, saying that that's probably the case. And he suggested a good way to fix that is to bring HEPA filters into the room. And the EPA has said this too, that you can supplement with portable air filters. So that's how we bridge the gap between HVAC and what it can do, and then the recommendations and standards. So here as an example, we have Effie Greathouse, who started Safe Indoor Air for Oregon Schools. She didn't feel she was getting a lot of response, and so she connected with 100 parents in her area and mobilized them to write not only to the school, but also to representatives. And eventually they did find some movement there. The school did adopt portable HEPA filters. Another person in California, Lisa McConchy, felt not listened to. And this is I believe a school board president. I don't have my notes, but a person who you would think, has a hand in deciding things, right? And just felt unlistened to. So she assembled a straightforward presentation that you can get from her website, lisamcconchy.com/clean_air_advocates. And she prevailed, and they now have about 10 times the clean air in that classroom. So another example is if your school isn't working with you, try pivoting. We've encountered a school that thought that their feelings about their confidence in their systems were a better air quality measure than our CO2 monitors could bring them. So we just moved a little bit east to another school district. We presented the expert recommendations that we're aware of to them and the science, and that was in January. In July, they accepted 2 portable HEPA filters per classroom for their classes. So when the wind isn't blowing in your direction, maybe tack a little bit to the left or the right and see if you can get some movement somewhere else. In summary, we really need schools and legislators to appreciate the significance of the opportunity at hand. We've witnessed and sometimes supported the formation of state groups all over the United States, and there's legislation in the works in many of those states as well. And I have a kind of an incomplete list here just to give you an idea of some of the places where parents are getting together and caretakers and community members and teachers. So I would encourage you to please join us at tinyurl.com/better-school-IAQ, and we'll email you the parent/advocate guide and try to connect you with other people working in your state. And that's all I have about that. Thank you.
Thanks, Mike. That was just about perfectly on 5 minutes, so well done.
Thank you.
And that's really great to hear how community groups are able to advocate and get change driven through the political systems. And I think some of that as well, making sure that the change that goes through is actually the right change that we need, that actually meets the standards. And otherwise we end up creating demonstrating a change that's ineffective, and everyone looks around and says, well, hold on, that didn't work. And that people think that it proves that the change isn't what we need. So it's, that part of it, I think as well, that you guys have been working on is really critical, and well done. Have we got Andrew Hewitt? Can I get Andrew Hewitt up on the, great. Well, there we go. Andrew, great. So Andrew is a union official and health expert. He's been working with the Allied Health Professionals Union in Victoria in Australia throughout the pandemic, and that's given him a really fascinating front row seat to a lot of the political debate throughout the last few years of this issue. So Andrew, I'll let you take it away.
Yeah, thanks, Dom. And just before I start, I'd like to acknowledge the traditional owners of the land that I'm speaking from, which is the Wathaurong people, the Kulin Nation, and pay my respects. Thank you for the opportunity for actually speaking, and just to sort of flesh out what Dom was saying. So I'm actually a health professional by background, but I've been a union official for the last decade, and that's given me the benefit of a front row seat to the pandemic response in Victoria. And so what I'd like to do is talk to you about what we did well and what we did poorly, and in terms of the outcome. And for those of you unaware, Australia did pretty well in the pandemic response in the first couple of years, and then it kind of went pear-shaped from there. But within that, Victoria had a pretty bad outcome in the first 12 months, and there were a lot of lessons learned in Victoria from that. And so what was happening on the ground was that the government was meeting regularly with the health unions, the leaders of the health unions. So we actually had weekly briefings, and we also managed to get weekly briefings with the PPE task force and the chair of the task force. And that gave us a direct input and direct feedback and direct consultation with what was happening. But the big thing that happened was that there were about 4,000 healthcare workers got infected in Victoria over that period, and they realised that there was a big problem and in terms of the workspaces. And so they put together a task force, and they called that the Healthcare Worker Infection Prevention and Wellbeing Task Force. And several of us union leaders were on that task force, and that was really instrumental in terms of shaping the way the Victorian response went from that point on. Important achievements out of that task force that largely went unheralded was we were the first jurisdiction in Australia to actually put out a statement recognising COVID as being spread as airborne, and that was a big thing because then that influenced the PPE guidance from there on. The Victorian Health Building Authority actually updated their ventilation guidance after that. It meant that the chief health officer, when he was doing his daily press briefings, he would quite often mention the fact that COVID was airborne. So that was really important for us, and that was a big step forward. We also managed through the task force to generate an audit of the ventilation standards in COVID wards in I think it was ended up being 21 hospitals. Unfortunately, that report was never made public, but the report demonstrated that there was a real failure in terms of the standards within those spaces. And as a consequence, the hospitals started gradually improving their ventilation standards, and they're still going through those processes now, 3 years later, in terms of the upgrades. But it also led to what they called, they did a hotspot study, which is actually a publicly released document, which demonstrated the spread of aerosol particles throughout a simulated ward or bed space. So that laid a really solid foundation for us as health professionals to demand proper respiratory protection in the workplace. And that led to the task force implementing a respiratory protection program. So that meant that all the health services then had to go through fit testing of their N95s. It meant that all the health services had to produce a COVID safe plan. So all these outcomes put us on the right path and meant that we were actually heading in the right direction. That all went a bit pear-shaped, 2022, the end of 2021. And so there's still a lot of work to be done. But from our point of view, the foundations are there. And what I wanted to share with you is in terms of things that worked and things that didn't work. And the things that really worked for us was getting organized. We collaborated. So the health unions or the leadership, we met offline and we collaborated. So when we met with the government, we were all on the same page. We didn't always agree with everything, but we would caucus beforehand and we'd get a consensus position, and we would put that, and we put out joint press statements, and we would write letters and co-author them to the Premier or to the Health Minister. And they were very powerful, and it meant that they were helping to push the direction that we wanted to. And as I said, that's led to some better outcomes. What didn't work so well? Well, the regulator, the Work Health and Safety Regulator, was disappointing in terms of their response. We managed to meet with them regularly. So don't rely there. Communication was one of our important things, and communication from the government was not always to the health workforce was not always ideal. And so the unions really took up that space. It's important to keep the pressure on, and don't expect gains straight away. Don't expect big gains. Take the little gains when you get them, and if you don't get them, go back again. You think of yourself more like a terrier than a greyhound. So you got to keep nipping away and keep chipping away. Don't always accept no for an answer. As Michael just said, I think the previous speaker just said, if you can't find an answer where you want it, move on and go again and see how you go with the next in the next area. So think of yourself as, and most of us here may not think of yourself as, but think of yourself as an activist. Every opportunity you can, put your hand up, get involved, get on committees, speak up, and do your part. Be patient. Governments and bureaucracies move slowly. Look for allies everywhere. Sometimes they're not where you expect them. But if you speak to people and you get involved, you'll find them, and they're there. Don't let aiming for perfect, undermine a good outcomes. You can't always get. I mean, as a union official, we're used to not getting what we want, but we always try and get better than what we had, and we just need to keep pushing forward. And ultimately, I think to some degree, lawsuits are going to start to force the hand of the governments and the employers, and so we will see change. But in the meantime, do the best you can, keep pushing forward, and stay safe. So thanks, Dom.
Thanks a lot, Andrew. you mentioned lawsuits, and I did just see earlier while we were talking that the Ruby Princess class action has just been ruled in favor of the litigants. So that's Australians will be very familiar with that, but the rest of the world not so much. The Ruby Princess was a cruise ship that arrived in Australia at the very beginning of the pandemic and had a huge outbreak, and people came in through that. There was a bunch of problems in the way that was handled. And so the fact that that's just been ruled as in favor of the class action litigants is going to be a big deal, I think. But before we move on to that, I'll introduce Chris Wallace and get her up onto the platform. Oh, there we go. What did I just do? There we go. Chris, are you? No, you're not muted.
Hi, Dom.
So Chris is a great to see you. Thanks very much. Chris is a professor of political history, leadership, and public policy at Canberra University in the capital city of Australia. Chris, I'm not sure how much of the conversation you've managed to catch so far, but we've heard all the products exist, everything exists, everything is available to be done, and it's not happening. So please explain what's up.
Yes, I love your concept, Dom, of we know where to take the horse to drink, but how do we get it to drink? And great contribution so far this session. Thanks for including me in it. My job is to kind of politically frame this, how we got to this mad point and where we go from here in 5 minutes. Big ask, but let's go. So very essential to understanding what's just happened is we need to take deeply into our hearts and minds and activist selves the deep truth that human beings are herd animals. So what made the herd run in the direction it did in relation to the last few years and the experience of the pandemic? How did we end up at this position of very low systems performance in terms of public health? Well, there are a few really important factors in it that don't explain everything, but they explain a lot of it. The first thing is, especially in the Anglosphere, the dominance of laissez-faire thinking. So, of course, that's partly driven by global capitalism. People want to make a buck. They don't want to think about how they're making it. They see interventions that could make making money safer as an impediment, just friction. Let's get it out of the way. Of course, we have some contending institutions in terms of social democratic political parties and unions that stand against that. But the impact of private enterprise globally has been a really powerful factor in the let it rip mentality that's come to dominate. The second thing is that it's, again, especially in the Anglosphere, political parties of a conservative nature have very much dominated the realm. Political parties seem to have an inbuilt bias in Australia, Britain, and the US in terms of winning more often than our Labor Party, the British Labor Party, or the US Democratic Party. One of the big driving factors in that, I think, is that conservative parties understand viscerally that moving votes is about emotion, not reason, not facts. Whereas on the social democratic side of politics, where I think it's fair to say many COVID activists reside, people generally think it's all about facts and reason. If you shove enough facts and reason down people's throats, they'll go along with it. Not true. We know that from climate science. Very important that we come to grips with that fact. But the fact that conservative political parties have dominated our parliaments, your Congress, that has really backed in that free enterprise laissez-faire approach, including to public health, which has killed so many people, basically. On top of that, and really kind of intensifying it, is the polarization that's come through hyperpartisanship, disinformation, the political inflammation driven by bad actors internationally. We know who they are. We don't need to go into that a lot, but that makes a bad situation so much worse. I think an underestimated factor has been people haven't really come to grips with the nature of the medical profession. Now, it's very tricky these days to use the word elite, but in the old sense of the way that word used to be used, the medical profession are historically an elite. They're affluent. They often live in insulated, affluent areas with great health services. They're not the front line of, the cafe with shocking air and internal customers coming at them in a COVID unsafe environment. They extrapolate from their own position. They're often ideologically aligned with conservative political parties, or at least the interests of the rich. And they, these people that we turn to for really sound, objective public health advice, often philosophically and ideologically and in class terms, they're not actually dispassionately looking at the evidence and coming up with sensible recommendations. And that lack of medical consensus has been a big problem at various points in the pandemic. What do we do about it? Well, I think bearing in mind that humans are herd animals, and this problem of the drift to low performance is not a new problem. We know that from other systems. We know that we make our own culture and we can remake our culture. How do we, borrowing some ideas from behavioral economics, how do we change the choice architecture so that we can, spin back up from this drift to low performance? Well, of course, systems thinkers will tell you the first thing you've got to do is establish good absolute standards and work out how to get them adopted. So that's really the challenge at hand. So a couple of ideas on that front. First of all, influencing the choice architecture around ventilation positively in terms of turning it into a really boring technocratic problem. Now, the minute we do that, you end up getting out of that heated posture where you've got to fight people for the truth. If we can turn it into a boring engineering problem akin to what's an appropriate air temperature, heating and cooling wise in a building, that could be an important route through which we can make progress. Of course, Mike Bailey referred to establishing quality air benchmarks. That's absolutely central. There's widespread misunderstanding about that. In terms of the Overton window, we ought to be overshooting on that and not undershooting. We ought to be going for 600, not 1100, knowing that we'll probably end up at about 850, just a thought. Changing the choice architecture in a negative sense, and again, this may well be the slow but ultimately most impactful move we can make, and that is to turn it into an occupational health and safety problem and engage unions. And Andrew, I note your points earlier about how that doesn't always work, and occupational health and safety regulators aren't always interested in these things. But I tell you what, insurers always are. If it's going to cost them money, they're going to be interested. So we should not ignore the insurers as a target for action here. Yes, Andrew mentioned test case litigation. I think this is the most impactful route in terms of a battering ram for change. Again, if you threaten moneyed interests with losing money, well, they're going to take notice and take action, and the insurers are going to be with them on that. So we've really got to get going much more strongly on the test litigation front. And then I think it's really important to kind of use nudge to create a public health good program. And, there's no reason why we as community activists can't organise to do this ourselves. We shouldn't always wait for government. Hopefully we can recruit government to do it. But I think crucially, it needs to not be COVID specific. To the extent that it's not COVID specific, it would get much greater uptake. There'd be much less resistant. We'd be depriving, the ferals, the nutbags, the cookers from the fight they always want to have with us. It's important we stop having that fight. It doesn't help. So a good non-COVID specific public health campaign built around fresh air, the virtues of fresh air, the virtues of up-to-date vaccinations. You don't have to say for what, just the general principle, and the benefits of inside buildings, decent CO2 levels, as we know as a proxy for the likelihood of infection. So that's my offering.
Thanks so much. That's fantastic. And that leaves us a bit of time as well for more discussion on this front. Can I ask, some of the things that were said there lays a certain degree of blame in the medical profession. And I think there's a bottleneck as well in regulators. We heard that some of the standards, in fact, I think Marianne from NIOSH mentioned that it's not enough to have standards, everyone has to know them and people have to follow them. Is there a role for more transparency or accountability in these official government advice bodies? does anyone want to jump in on that who is a bit closer to that than me? Is there, we have some of these groups like HICPAC in the US or ICAG in Australia, or other groups like this, and their advice seems to be all powerful but uncontestable and not connected to the science or the evidence. How do we sort of open that can up?
I think common sense can be a powerful tool, Dom. We're not going to win. We're not going to get a medical consensus on these things. There are too many ideologically charged players against the backdrop of the pandemic to really hope for that. And, the right wing of politics often deploys common sense as a devastatingly powerful cultural tool. And we can be doing that too in terms of clean air. I mean, you just hear the words clean air and it's a good thing. There's probably 200 years of clean air culture that we can draw on. And, of course we need great regulation and we need excellent absolute standards. We've got to keep, as Andrew said, being like terriers, not greyhounds in grinding away to get those up. But at the same time, we need a pincer movement. So we focus very much on the rebuilding the public health culture, which has been smashed. And governments are on the back foot over this. We need to do that. It needs to be a massive thing. And that secret weapon of the concept of common sense can cut through to ordinary people who will never know what a ppm is, right? I think that's potentially very useful.
Mike, I saw you put your hand up a moment ago. Do you want to still jump in?
I was going to add my 2 cents, but I like Chris's 2 cents.
Meet me and raise me, Michael.
Real quick to jump in with that too, because I want to make sure that, but people, I'm a volunteer for World Health Network, and I've seen the work that individuals can make of all shapes and sizes when it comes to organizing together. And I think that the more that we have in diversity, the stronger we are together. And that we have put together some networks, groups of people that have sort of panned off, like the infection prevention team, which is working, on HICPAC specifically on improving transparency and improving our ability to get our voices heard by coming together. And so that group right there is also organizing doctors together. I definitely would recommend people check out WHN.global to get more information on those movements and to not feel intimidated to be part of them.
I wanted to ask another question about some of the ideas that have seemed to become entrenched, and whether we can overcome them. Blair Williams in an earlier talk described these as who's a political science at ANU, I think, described these as hegemonic ideas. Right? And one of them, I think, has been this idea that it's all too difficult. There's nothing more we can do. Right? And once we sort of fall into that trap of there's nothing more you can do, then people start rationalizing it as, well, if we can't solve this problem, it mustn't be a real problem anyway, and so it's all mild, we don't have to care about this. And the expo has really been focused on knocking that particular idea out of the park, right? And I think the previous speakers have done a fantastic job on that. We've really demonstrated that this is a solvable problem, with existing technology and products and tools. But we still have to get that idea to knock over this sort of existing hegemonic idea that there's nothing we can do. Where do you think of the sort of soft targets for that? Or I guess another part of it is, a follow-up question would be, what are the other big ideas that we have to knock out? So there's a sort of two parts. Yeah, Mike, go for it.
I think we need to find some school in the United States that has implemented the recommendations, which heretofore, I don't know of one that exists. I know many school indoor air quality claims have been made. I don't know of a single one that has survived a carbon dioxide monitor. And I think we need one to be able to point to that and say, here's what happened with illness, with attendance, and with grades. If we have yet to do that, then we have no right to engage in fatalism about this.
Yeah, Chris.
So everything Mike said in his presentation earlier, and then equally applies to the university sector. And that should be another powerful scene for action. But I honestly, I hate to say this, but I think detaching COVID from this effort is, you know, it's always going to be central in our hearts. But if we're to succeed, we've got to unhook it from that so that we can join it up with a whole lot of other things to dissipate the resistance. Another idea I have is, for example, I don't know about the US and UK, but every house in Australia now that goes onto the real estate market has to have an energy rating out of 5 stars, so that potential purchasers can see whether it's a great passive solar house that's going to have low heating costs and be healthy to live in, or a miserable cold box. Starting with the commercial real estate sector, for example, and also institutions like hospitals, schools, universities, having a 5-star air rating system. So, you know, if you were looking at working at UPenn and you saw it had a 1.5-star clean air rating, you'd go, forget it, I'm staying at Yale, you know. Or I'm going to choose this hospital to have my private surgery and not that one because it's got a 5-star rating. If we turn it into a positive competitive differentiator through a star rating system, with a proper CO2 benchmark, not a dangerously compromised one, it could be a really useful thing. There's a couple of guys working at Harvard on the measurable, you know, Mike's talking about, we've got to be able to demonstrate it. That's a very social democratic thing to want to do. You know, the right wing never worries about that. They just go for the emotion. But, you know, I agree. My inner nerd agrees. But there's a couple of guys at Harvard whose names I don't have immediately to hand who've done superb research. This is before the pandemic, on the productivity improvements amongst office workers, depending on the level of CO2 in the building. You know, it's unarguable. It's powerful stuff. So some way of translating that into a popularly perceptible differentiator quality-wise for buildings could be an interesting project.
I just dropped a document in the lobby chat that may even have that exact study about some of the productivity improvements. And it's also got William J. Fisk at Lawrence Berkeley, some of the greats, right? Talking about how you can get better grades and kids will attend school more because they're not sick. Definitely want to make hay of those things. Also in Connecticut, where they adopted the EPA's tools for schools in 2011, they saw in Hamden, Connecticut, a 50% and more than 50% drop in absenteeism. And that's kind of a square peg and a square hole with the E3 Alliance in Texas in 2015 found that illness was about half the reason kids don't make it to school. And it was the leading factor by a factor of 10. Skipping, the next most prevalent reason, was 5% of the reason kids didn't make it to school rather than 48%.
So that's fantastic stuff, but that's usually where the social democratic push stops.
Of course.
Our kind of people think that's it, you say that and everything's going to follow. The task with things like this is, what emotion do you hook it into that can actually impact on people and what they do, impact on people's behavior? So, you know, the examples you mentioned, hooking it to the idea of parents' ambitions for their kids, right? You hook it to that kind of hit you straight in the heart motivation, we might get some action. But while we only talk about it in cold-blooded, objective metric terms, no one's hearing us. So it's going to go against the grain to work out what we have to do to make our position in impact on the world. We have to discover and learn how to deploy emotion with the facts, with the reason to get impact.
Yeah.
Just to make a quick comment, Dom, I don't really have an answer. I don't have a magic wand, but I think in terms of health, and that's obviously where my focus has been in the health workforce, if we don't break that disconnect soon, we're going to have serious problems in terms of being able to deliver health services. And that's probably going to be across all industries. I mean, you look at teaching, trying to get teachers. And I would have thought by now that the sickness rates, absentee rates would have made people be within those environments be more aware, but we really do need to break that cycle of disconnect so that we can actually get people to take up these mitigations, and so that we can and if we can't get them to wear a mask, we need to have the air environment clear clean, and it's you know it's really becoming imperative to keep the workforce in at work.
Yeah, we're just coming
Again,
up
can
close
I
to
just say
time.
that's a really fantastic point, but completely rational. Now, can you hook that to an emotion that can move the economists? Look, the absenteeism figures, the research done in the US, Australia, elsewhere, phenomenal. You know, the absenteeism rates caused by bad public health policy around these issues is horrific, but no one is willing to do anything about it because money, right?
I just,
Again,
oh, sorry. I just wanted to jump in because I think that, you know, exactly what you're saying is right. And earlier, Colin had asked me for, you know, a clean air joke, and I have one, and it's, you know, why did the duck's mask complain? Because he always gets stuck with the bill. And the people who are getting stuck with the bill right now are the individuals who are getting sick, who are going to hospitals, who are getting the healthcare bills sent, who are missing work, who are getting disabled. And so we all need to put our money where our mouth is. We all need to put that mask on when we go out, because that's an easy way to show where you're standing when you want to clean the air. Step one, you know, and continue with all of the policies and pushing them in your communities, because those ground efforts are going to make a difference.
Yeah, I think who pays is a really fascinating question, because the cost, if people are getting sick, someone is paying, right? It's either you have to pay, the person getting sick is paying in terms of lost health, or the government is paying in terms of, you know, dealing, you know, preventing the problem or cleaning up the problem, or business is paying in terms of being told to do it instead of government doing it. But the cost exists as soon as the infection is there. And you know, whoever pays for it is you know, part of what we argue about, I guess, Mike. Yeah.
Or the parents are paying for it when they have to chase the doctor's notes. Yeah.
Yeah, exactly. And you know, I've seen a lot of data on absenteeism that I've taken to some unions and asked them about, you know, how come they're not advocating for you know, their workers when the sickness rate in their industry has gone up so high, and they tend to, you know, their response is that they're looking at the data and not seeing it. You know, they're not aware of it. And I'm not sure where that disconnect is. Is that, you know, is seeing this problem? Is there a blind spot on our side just everywhere, or?
I find that people have bought into the idea that if we all agree there's no problem, then we can proceed. I do think that I see some almost comical levels of disruption from illness, that people are just kind of like, well, that's normal. It's like, well, it is now because you accept that, but it doesn't have to be.
Yeah, so I want to maybe have one more question because we're running out of time. Do we have to win the discourse, or can we just get this done? You know, is there a way through the politics to sort of just have things implemented at the business level or the government level, or do we have to persuade everyone before we can get anywhere? Oh, Chris, you're muted.
Some people would like me on mute all the time. I think Shay's making a really key point when she talks about how it's all been individualized. So there's obviously a collective culture move necessary here in terms of rebuilding the public health culture from the ground up. But, you know, how do we get a big business to understand that absenteeism is costing X? It could be X minus a lot if they got their air right. You know, through moves like that, you could get some real impact fast. And the other move is getting new regulations for new builds of all kinds to embed new proper ventilation standards. I mean, masks are going to remain a supercharged issue, but if we can get ventilation right, we can have a massive impact in the sense of not making the perfect enemy of the good and getting the good up while we work on the perfect, but changing it from a collective problem from an individual problem to a collective problem is going to be very central, I think.
I notice a lot of the hand washing places responsibility on the individual to somehow hand wash away an airborne respiratory health threat. And that I'd like to evoke some feelings of anger about that, because it really isn't on parents to, you know, to make their kids not sick by having them wash their hands when it literally is just floating in the air. And what frustrates me is that schools have the audacity to call parents and ask why their kids are sick so often, but none of them have adopted those recommendations. I don't want to make schools the enemy, but when parents are being called because of this thing that schools have visited upon those children, that's really frustrating.
Yeah, well, I think it's been a little bit of a depressing session, to be honest, compared to the others, which were sort of full of solutions. But I guess that's the world of politics. Maybe one of the final things to say, I guess, would be that all the experts we've heard from and the regulators who have all these solutions, you know, we really need you all to be more activists as well and become part of the political fight. I think the ones who have presented obviously are taking that approach, but we need that from more as well, I think. And I think with that, I'll hand over to Yanir, I think, to wrap up, make final statement about the expo. So thanks everyone for my session, and Yanir, over to you.
Thanks, Dominic. I want to say a few things briefly. I started the program and I'm here to wrap up. Thank you all for joining. I forgot to introduce myself. I'm Yanir Baryam, one of the founders of the World Health Network. I want to acknowledge really the amazing program with its tremendous insights and diversity of understanding. When things work as this program has today, it looks easy, but I can assure you it was a tremendous effort of the team that put it together. We have heard about the incredible importance of clean air, of how there is a wide range of differences between countries taking it seriously or not seriously around the world. We learned about the science and technology and the opportunities for DIY innovation and new technologies. Finally, we heard about the implementation and activism to make a difference. For me, the arc that we heard showed the way we need to move forward. We can be inspired by these efforts, but we also need to expand the ways to make progress. Every step that we want to make takes multidisciplinary knowledge and innovation, as well as determination to confront the existing inertia. I don't know a better way than to develop collaborations, which is the focus of the effort of WHN. As Shay mentioned earlier, we invite everyone to join together to make this happen. And for those of you who want to learn more about what WHN is doing, we have regular welcome meetings, including one that is happening tomorrow. In case you would like to join, I will put a link in the chat. I really, really want to thank the organizers, Colin Kinner, Melissa Smallwood, Dominic Meager, who just chaired the last session, Stefan Bilodeau, Shay O'Neill, and last on this list, but surely not least, is Patrick McClung, who's done all the technical side and really deserves a tremendous applause. And of course, all of the speakers and exhibitors. With that, I want to close, but I want to mention first that our plan is to leave open the expo this evening. It is available for people to walk through and wander to discover what is there. And beyond that, with all deep appreciation, I want to wish everyone a very good night. Thank you very much. And I look forward to seeing you again soon, and with progress that we have to report about what we've accomplished in the interim. Thank you very much.